Good afternoon, everyone. Right. Welcome to the class. Yes, good afternoon. Good afternoon, everyone. Right. Have you got the answer? Many people message me like, okay, right. Sir, I gave one question here. Few people, not few people, many people ask the same doubt. Sir, we are getting confused, etc. In the mathematics, not in the measurement notation, in the mathematics, they have given that. Sir, V is equal to how much I gave you? 100 plus or minus 4%. I is equal to 50 plus or minus 3%. Right. Okay. Right. Find out the value of R. So this was the general question. Clear? Right. Sir, R is equal to V by I. Okay, before going to that, what is the shortcut here? Shortcut here is R is equal to 100 by 50. 2 plus or minus root of 4 square plus 3 square. This is what the general answer by using the shortcut. Right? Okay. Now, so R equal to V by I. Dou R by dou V. Dou R by dou V. What will be the value? Just 1 by I. Other parameter, right, with respect to this, will be acting as constant. So therefore, 1 by, what is I? 50. Okay. Next, dou R by dou I. Dou R by dou I. V is constant. Keep it aside. D by dx are 1 by x. So simply 1 by I square. So therefore, what is that? 100 by 50 square minus. If you are having the problem with partial differentiation, it is very difficult. Very difficult. Clear, guys? Right. So what I gave you? These are probable or something. Any one error. So probable error, random error, something. No problem. Okay. Right. So random error. Right. In resistance. What is the formula? Root of dou R by dou V. Dou R by dou V whole square into. This is a procedure, right? What you have to do here, this is a simple shortcut answer. 100 plus or minus 4%. As we are going by procedure, what I told you, 100 plus or minus 4% of 100 is 4. 50 plus or minus 3%. So 50 plus or minus 3% of 50 is 1.5. I told you already, in the procedure based, always, in the procedure based, always, what is it? Value form must be taken. So therefore, 4 square plus dou R by dou I whole square. What is the current error? 1.5 square. Okay, right, sir. What is dou R by dou V? 1 by 50 square into 4 square plus minus 100 by 50 square into 1.5 square. Simplify this entire thing. What will be the value you are getting? If you simplify this entire thing, what is the value you are getting? Right. Okay. What is that value? You'll be getting 0.1. Some people have given that 5. Many people have given 0.1 ohm. Okay. So therefore, what is that? Random error in R is equal to plus or minus 0.1 ohm value form. Value form is 0.5. Therefore, total resistance R is equal to V by I. What is V? 100 by 50 plus or minus 0.1 ohm. Therefore, 2 plus or minus 0.1 ohm. Sir, 0.1 is a dash percent of 2. 2 plus or minus 5%. Clear? Both are correct only, but in terms of percentage, you can get it. Many people may say, like, sir, I am getting confused here. Right? Kindly, I told you, if you are perfect in the mathematics, then only or all other subjects are clear. Okay, those who got, okay, right. Right. See, clear, guys? Right? But people are getting doubt here. People are getting one small doubt. That is what, sir, 5% of, I'm just going to give that 1 second. 5% of 5 is 0.1. 5% of 5 is 0.1. Is it? Is it? Come on here, come on. Be perfect in the mathematics. Ali, I gave in my entire explanation. I know generally people are getting confused with respect to value to percentage, percentage to value to conversion. That's why when I was saying that, the total value correspondingly I have given. Clear? So therefore, 2 plus or minus point percentage means what you have to write here? 0.1, right? Into 100, right? By 2. 0.1 into 100 by true value. What will be there? 20, 100 by 25%. That is what? This answer. That's why be perfect in the mathematics. Be perfect in the mathematics. But many people, I got shocked actually. Many people message like, right, sir, I'm getting doubt in the differentiation. I'm getting doubt in the differentiation they're asking. Come on, guys. So this is the earlier class question. And one more thing, that's what I told you, before messaging me, think once, twice, thrice, then only message me. The moment you see the question, sir, I'm not understanding, posting to me. Don't do that. Don't. Many people did the same thing. I told clearly in the R parallel method, here, what is that? 100 ohm was there. In that 98 to 102 we have taken that procedure. 50 ohm was there. 49.5 to 50.5. Okay, what we have got there? True value we have got 33.33. So 33.33 only here. 33333 will be there. Have you taken the total value? No, that's why before sending me, think once, twice, thrice, then only kindly send, because 500 members are simply passing 555 messages, it will become 2500 messages, 2500 questions, different people. So kindly before sending me, think of it first. One student gave the message like, sir, REM you have got is 33.77. I have taken the round figure number just for clarity purpose. As the time is not to be wasted by calculating, I give the value REM1 and other REM2 is 32.88. And he has taken the picture in the calculator and understand. Very good. That person I don't know. Sir, error, I am getting X percentage. And here, with respect to this one, right? Error, I am getting equal to, right? Something else. Why? So both are different. You told that same. Kindly think once. 100, what is that? 98 is reduced by 2. 102 is increased by 2. Definitely with minimum common sense, we can understand that what is it? The error will be equal on both the sides. Error will be equal. At any cost, you should have the same magnitude. But the person has taken the photo in the calculator. Sir, I'm getting different. If you're saying that, I cannot do anything. You should have the minimum thought. You should have the minimum thought that, come on, we should get the same value. Why we are not getting the same value is you might have not taken all the digits randomly. I have taken only 2 digits, but it will be 33.7. So some number will be there, right? You take all the numbers, you will get here, what is it? Plus 1.3334. I told you. Sir, I'm getting 1.28. I'm getting 1.36. Come on, think of it. That's why before sending, right? Kindly think of it. Here you'll be getting minus 1.33%. Before sending, actually without sending me also, you can answer, you can understand that too. Already told you so many times in the class. Here reduced by 2, here increased by 2. So automatically equal division is there. Means the minimum thought should be okay, I should get equal. But why I'm not getting equal means what you missed, you are not taken all the digits. That's why think of it, kindly think of it. Harshit Reddy, what is your problem? Harshit Reddy, what is your problem? Vishnu Ajit, did you attend my all 4 classes? Right? If you attend my class, you should not ask that question. Now, finally, after completion of chapter, you are saying that, sir, uncertainty means percentage limiting error. Is it correct, sir? What is this? Right. Sir, parallel connection. Yeah, this is valid question. So here, already told you, you don't listen while I'm explaining. That's the main problem. Random error concept, parallel method. All I told you one hint also, but this much of lengthy will be there in the conventional paper only. I told you ESC connect that too, very rarely topic only in the ESC prelims. In the gate we don't have. Right now we are taking gate and ESC prelims only, not ESC mains. After completion of this entire thing, after the prelims or before the prelims exam, generally we will be taking separate batch for ESC mains. Are you clear? So that's why ESC main question, you no need to worry. One thing I told you already clearly. R1 plus which one? Yeah, R2, right? In the parallel, right? What is that? Separate method. Obviously, what is that? Dow R total by dow R1, dow R total by dow R2. Proceed. Use the procedure method only. Use the procedure method only. But you people got confused here itself, right? But 100% you will get definitely confused here because you are not perfect in the mathematics. It seems. Kindly get habituated with the mathematics subject. Clear, right? So this is the total discussion regarding earlier chapter, error analysis. Yeah, Niharika, yeah. I know, but I cannot say that openly with openly directly. That's what I'm indirectly saying that. Right. Thank you, Niharika. Thank you so much. Right. Next, and few people ask that, sir, in the CRPQ, one question bank is given now. In that question number 6, sir, solve me, solve it, solve it, solve it, solve it. Continuously message me in my mobile phone, and now also one person is continuously, almost I have seen 5-6 times that message. What is that? This question, before starting, try to understand in that question which is there. Wheatstone bridge is there. Wheatstone bridge is there. So you should have the minimum thought like, okay, why am I not getting means bridge concept we don't know. Why bridge concept is not known means faculty has not explained. Why means bridges is a separate chapter. It will be clarified later. But this is given in the first chapter only. Why means this is related to error analysis. But error analysis and bridge combined question is there. I will solve that question later. Don't worry. See, if you want to know about the schedule, right, kindly go through the OTS platform. In that schedule will be there. In that schedule will be there, go through that, right? So this is a total discussion related to the earlier chapter. Okay, right. Right. Next one, already we have started the next chapter of this. Types of instrument, that is basic instrument we have started. Introduction I gave you, right? Right. Now I'm revising the total discussion. Concentrate. Basics of instruments. All I told you, basics of instruments. The classification is absolute instrument and secondary instruments, right? Absolute example I gave you. I give you later. Secondary instruments classified into what I told you: indicating instruments, recording instruments, and integrating instruments. This is the introduction we have taken. And examples also we have taken. Integrated instruments, one is energy meter. Recording instruments, XY recorder, seismograph, ECG, etc. we have taken. In the indicating instruments, what we have taken here? Ammeter, voltmeter, wattmeter, etc. I told you. What are those belonging to means here? Electromechanical instruments, ammeter, voltmeter means electrical supply, mechanical movement, that is analog type devices we can say. And electronic type of device also will be there, because electronic ammeter will be there, electronic voltmeter will be there. In that electronic, analog may be there, as well as digital also may be there. All these are coming under which one here? Indicating instruments. Clear? So this is the corresponding. But in this, digital instruments will be studied later. But in this classification, we are going to study only analog instruments. This is the total topic I have given as the introduction. Only names I have given. Don't worry. What is absolute instrument? What is secondary? Complete definitions, indicating, recording, and after giving the entire definition, be clear. I'm going to start indicating instruments operation. How the pointer is moving from 0. How the pointer will be stopped over there. Everything I'm going to give clearly information. So kindly concentrate. Today's class is complete class is very important class and playing the crucial role in the entire measurement subject, because this is the basic instrument topic. Remember, complete basics will be taken regarding the instruments. So kindly concentrate. First one, sir, absolute instrument. Sir, what do you mean by absolute instrument? The absolute instruments are the not normal instruments. These instruments do not give the direct readings. Means, suppose supply is given, pointer is showing some value, yes or no? But these instruments will not give the unknown value directly by showing 0.2. Okay, 0.2 is given, 0.2 will be shown. 0.3 is given, 0.3 will be shown. Ideally, I'm speaking. If I give 0.3 amperes of supply, pointer should show 0.3 compulsory, ideally speaking, or near to 0.3. Those devices are, but which devices? Indicating our secondary criteria. But these instruments are not giving their readings directly. Directly will not give. How they will give, but give in terms of instrumental constant. Give in terms of instrumental constant. What do you mean by this? Means concentrate. Suppose Suppose one instrument is there, right? Here 0 to 10, for example, it is showing some 4, for example. For example, the instrument is showing 4. We cannot say, sir, I is equal to 4. Okay, ideally speaking, sir, it is showing 4, so I is equal to 4. No, these are the absolute instruments which will not show the reading directly. How it will show means these will be showing in terms of instrumental constant. These will be showing in terms of instrumental constant. Means for every device, some constant will be defined by the corresponding manufacturer of that device. Suppose K is equal to 2, for example. What does it mean? If it is showing 4, we should not say 4. We should see the instrument constant. So 4 into 2. What is the value? Actually, given value is 8. Given value is 8. But be clear. Sir, why these are designed like this means these are used as a reference devices. These are used as the standard devices. Where we use in the standard means in the standard laboratories will be there. In all over India, laboratories will be available. In those laboratories, we are going to use these type of devices. So that's why in order to understand the things related to absolute instrument, you should know about the standards. We should know about the standards given to the corresponding notations in the entire practical world. So what are those standards? Concentrate. There are 4 types of standards. One is international standards. International standards. Okay, right. After that, national standards. These are called as primary standards and secondary standards and working standards. These are the corresponding 4 standards. Kindly concentrate. Sir, my question here is why I'm explaining all these, even though this topic is not mentioned specially in the syllabus, but we need to understand this to get the corresponding topic. So what do you mean by this entire thing is, suppose I'm taking one corresponding point. Like see, this is the scale here. This is the scale. Okay, this is 0 to 10 centimeter. If you take this scale throughout the world, any corner of the world, yes, this is called as 10 centimeters only. Okay, right. So means all over the world, same standard will be there. Okay. Sir, I'm using, this is unknown body. First class I told you, unknown body. Okay. Sir, this is placed here like this. Okay, this is 10, 11, 12, something. Okay, this unknown length is 12 centimeters, something you're giving. Measurement is okay. But my question is, sir, how do you guarantee? How do we guarantee this is exactly 10? Right? Concentrate. If the scale is given to us, with the help of the scale, we can measure unknown bodies 8 centimeter, 9, 11, 12, etc. We can measure. Okay. But my question is, sir, how can you give this value as 10 centimeter for granted? How can you give this value as 10 centimeter for granted? That's what the actual point. So that's why be clear. Sir, how do we know that this is 2 centimeter or this is 1 centimeter? How do we know that? How do we know that? Means scale will be there and that mark will be there. No. If anything is equal to that mark, we can measure, okay, unknown body 1, 2, 3, 4, etc. But my question is, whatever the scale is there, scale is available with you, that scale is giving the 10 centimeter value or 5 or 1, etc. How do we guarantee that? Means that is a scale universally used in all over practical world as the same value. That's why this type of thing is called as standard. That's why I told you the first class only, start India only, predetermined standard I told you. What is that? It is already determined. Means all over world, some standard will be there. Suppose this much of length is there. Sir, this is equal to 1 centimeter. Throughout the world, anywhere you go, that is what called as standard. So that's why the international standard is highest accuracy among all the standards available practically. So that is what international standard, right? International wise, some laboratories will be there. That is simply we can say International Board of Measurement System, IBMS, like that we can say. In those laboratories, right? Okay, this much of length equal to 1 centimeter all over the world. Yes, that must be followed. Okay, right. Sir, some value of current is there. Yeah, this is one, this is two. How do we know? That is standard actually. Okay. Second thing, sir, whatever the standard we are maintaining worldwide, can we maintain that as it is, without any small change in the countrywide? No, because in the countrywide, geography is different. Environmental is different, etc. So due to that geographical or environmental changes in the national wide, with small deviation acceptable base, national wide standards will be there. Those are called as primary standards. We say means these are the standards should be followed over all over India or all over any country you can take. These are called as primary, means country level their own standards will be there. That is primary standard. Okay. Sir, according to the primary standard, according to the national level standard, can the manufacturing industry people, design the devices 100% perfectly according to the reference? No. While designing, some acceptable tolerances will be there. 100% perfect, we cannot design. That's why in the designing, okay, plus or minus 2% tolerance is acceptable. Like that will be there. Those are called as secondary standards. Secondary means this is international worldwide, this is national wide, this is manufacturing industry wide. And finally, manufacturing industry, one device is designed, one device is constructed. That device we are using, practically if we are using, are we using that instrument 100% correctly? No. According to our convenience, according to our own conditions, again some tolerance will be there. No, that is called as working standard. We say working standard. Now tell me, all over India, all over world, which is highest accuracy? International standard. Little bit less accurate, national level, primary. Little bit less means secondary, that is manufacturing industry. Finally, least accurate is working standard. Clear? So approximately I'm giving. International standard is, now don't take this number, 99.99%, because 100% I'm not giving. 100 means ideally. Okay, this is international. If you're coming to the national, it may be 99.8, smallest accept, because of the geographical or environmental or etc condition. If you're coming to the secondary, 99 may be there. Coming to the working, 98 may be there. In this way, the order of accuracy will be changing. But finally, working standard is also, yes, accept only. Working means 30% accuracy, not like that here. 98% accuracy only there. Approximately, don't take this one. Means if you compare these four, working standard is least accurate. But don't say working standard is least accurate. Don't use, not like that. Working standard is approximately 98% less than these three I'm saying. So this is what the way of designing the corresponding total devices. That's why whatever the primary instruments I told you, whatever the primary instruments, absolute means what I told you, primary. In the last class I told you, absolute means primary instruments. So therefore, primary instruments are the instruments used where? In the national level laboratories. For which purpose? Reference purpose, to design the devices in the manufacturing industries. So that's why these will not give the value directly. These will give the value in terms of its own constant. But these are accurate meters. Hence, these instruments are used in research laboratories. That's why national level laboratories will be there. No, there we will use. By utilizing those, we are going to design the secondary type of devices. This is what the complete theory regarding absolute instruments. Example, what I told you, tangent galvanometer, I told you only for introduction point of view. Tangent galvanometer or relays current balance or absolute electrometer. These three meters are the examples of absolute meters instruments. But here the question is, very, very important question is, sir, these instruments are available to the common user for practical usages. True or false? These instruments are available to the common user for practical measurement purposes. No, these will be available. These will be available in which one? Yeah, these will be available Which one? Correspondingly, laboratories. Which one here? National level laboratories. But what I told, common user for measurement purposes. No, these are for which one here? Reference purposes only. So that's why absolute instruments are highly accurate. But we are using these devices for reference purpose, designing of other devices. That's what the thing related to complete absolute instruments. For this understanding purpose, I have taken this entire thing. Clear? Right. Now, coming to the secondary. Sir, coming to the secondary here. Secondary instruments are of three categories already told you. One is indicating, recording, integrating. Okay. But examples I gave you, definition is what I told you, but I have not given the note. Don't worry, I'll give you everything. Indicating means as long as the supply is there, the value will be shown at that particular instant I told you. Means the moment supply is switched off, the pointer will come back to zero. Therefore, instantaneous value we can say. Okay, that only I'm showing now. Sir, here, indicating instruments. These instruments will give the instantaneous values of the quantity to be measured. Instantaneous means at that particular time, at that particular time, 5 is there, 5. If you're changing something, 6 is there, 6. Changing something, 3 is there, 3. Like that, at that particular time only. That's why these instruments will give instantaneous values of the quantities to be measured. And already told you, N-log type, no, yes, scale and pointer mechanisms are involved. What I told you, ammeter, voltmeter, wattmeter, etc. Now, which type of etc. I told you, PMMC, ammeter, voltmeter, both are there. MI, ammeter, voltmeter, dynamometer, wattmeter, frequency meter, power factor meter, all these type of devices coming under indicating instruments. The next chapter itself is PMMC, separate topic. MI, separate, like that. Dynamometer also separate, topic by topic I'm taking. This is what indicating instrument. In the last class, I told everything regarding this entire instruments introduction, but I'm giving the clear-cut note here. Okay, right. Sir, second device, what I told you, recording. What do you mean by recording? I told you, recording instruments are the instruments which record the value over a period of time. Suppose 12 o'clock you have started, 12:20 you have stopped. During this 20 minutes of time, how the value is changed, that is generally represented with graphical representation. Example, ECG, seismograph, or simply recorder is there, XY recorder we can say. So that only I'm showing now. Sir, here, recording instruments. These instruments record the value to be measured or observed over a graph paper by a lightweight pen. Actual terminology I'm giving nothing, but it will be observing over a period of time. Nothing but on the graph paper, recording the value on the graph paper. Recording the value on the graph paper. Okay, after that, these are also used to observe load variation continuously. Electrical people, IN people, no need to worry. Electrical people, you are having load flow analysis in your power system. Load flow analysis. What do you mean by that? Midnight to midnight 12 to means 0 hours to 6 hours. What is the load variation? 6 hours to 6 to 9 a.m. What is the load variation? 9 a.m. to 6 p.m. What the load means? That load flow analyzer, load flow analysis, all those are graphs will be there. No, yes, in those analysis also we can use this type of recording. That's why these are also used, or these are used to observe load variations continuously. Continuously means what? Over a period of time. Yes, correspondingly the value will be keep on getting changed based on the switch on, switch off, switch on, switch off the corresponding customer loads. Right? I told everything, but I'm giving the note now. So what I told you, recording voltmeter, recording wattmeter, storage, oscilloscope, all I told you in the last class. Oscilloscope has two features. Not only this, other feature is also there. That's why I'm not writing, I told you, but people ask, sir, okay, I'm writing here. Satisfied? No problem. Storage means in this storage concept is also there. That's why this is generally we study digital type of devices. But example you can take here, no problem. Oscilloscope. And we can also write which one? XY recorder. In the last class I have written now XY recorder. And instrumentation people, right? biomedical measurement. If subject is there to you, biomedical measurement, if it is there, ECG, in that it is there. ECG comes under recording type. Or one more thing I told you, seismograph. Seismography is for measurement of earthquake. This is the total discussion regarding recording instruments. Introduction only name, example, no name and example only. After that, elaboratedly, chapter by chapter, we are going to take. Next, what is the other thing now? Integrating instrument. Sir, integrating means, I told you already, energy meter. Integration means cumulative summation. Integration means, what is it here? Cumulative summation. So what do you mean by cumulative summation? Be clear, guys. Sir, in our house, in our homes, meter is there. That is which meter? Energy meter. Right? In that energy meter, what you observe, suppose today only after the session, if you see the energy meter, what will you observe? You will observe the present value, or you will observe the total cumulated value from day 1 to present time. Means day 1 to present time, the cumulated value will be shown over there. Suppose in the meter, suppose you're having 1995 reading is there, for example, like this reading is there. Sir, 1995 units of energy now you are consuming? No, up to now, from the day 1 installation of the meter, from that day 1 up to now, what is it? 1995 units. I'll tell you what everything I'll tell you. This much of energy utilized means this is not indicating, this is not recording also, but majorly people are having one wrong thought. Generally, even electrical people also, iron and instrumentation, both people. Sir, integration means energy meter means coming under record. No, energy meter comes under integrating only, not recording. Means recording. What do you mean recording? Suppose here, this is 0, 12 o'clock, right? 18, 24 hours time I'm taking. Okay. Sir, at the end of 24 hours, if you see the meter, by looking at the meter, can you say that, okay, at so and so time, nothing but at 18 hours of time, right? Okay, I have consumed this much of power. At 12 hours of time, I consume this much of power. Can you say that here? No. In the energy meter, which is there here, cumulative summation, 1 plus 1 plus 1 plus 1 plus cumulative summation will be there. But what will recording? Recording means at the end of the operation, if you see the device, complete variation should be available like this. Some variation like this, some variation should be available. Means, okay, 0 to 12, this much of power is utilized. 12 to 18, this much of power. 18 to 24, this much. Like that, we must be able to observe. That's a graphical representation I told you. That's what I told you. Graphical representation, that is in the recording type. That's why no one should say energy meter comes under recording. No. What is it here? On the graph paper, in energy meter, where is the graph here? No way. So that is the reason why energy meter comes under which one? Integrating type. That's why see, these instruments will give the total electricity. Few people answered in the last class, sir, electricity meter. Yes, this only energy meter. Consumed over a period of time. Energy meter. Or what is energy unit? kWh meter. Or one more power, kVA or reactive power related energy. Or ampere hour also. 3 meters are coming under category. What is it? Energy meter, ampere hour meter, or kVA or H meter. These are the examples of integrating instruments. This is a total discussion I have taken so far in the last class, but I gave only introduction. Now I have given the complete definitions and all. Every point will be given. Kindly wait until I give. In the last class only, at the time of the ending session, so I want the notes of indicating, recording, and integrating also. People ask, no need to worry. I will give everything. Don't worry. Now I'm going to start indicating instrument. Our total electrical and electronic measurement subject is majorly related to this indicating type. After that, few chapters are there, digital type, etc. Okay, so that's why. Be clear, guys. Indicating instruments and starting. Indicating instruments. Right. So far, I gave you introduction, definition, and corresponding examples I gave you. Indicating instruments. Clear? Right, sir. Now here, sir, indicating instrument. So what do you mean by indicating instrument and what is the corresponding operation? I'm going to explain elaboratedly. This operation you don't find any textbook that much clearly, because in the textbook gunshot points are given. Gunshot points are given. The two high standard language it is given. So that's why try to understand each and every point while I'm explaining, because this is playing the major role in the today's class, in tomorrow's class also, related to PMMC, MI, EMC, and all of the other topic will be there. Okay, right. Kindly concentrate here for few minutes of time, 15 to 20 minutes of time. Mute from your side, away from your keyboard, keypad, and kindly listen carefully. After that, I'll give you time to ask the questions on this. Be clear. But I'll be explaining this topic again and again. I will go to that. I'll come back. I'll go to that. I'll come back like that. So many ways I'm going to explain. So kindly concentrate. Sir, here, this is the instrument. This is 0 to some 10 I'm taking. What is 10 called as? Full scale value. 10 is called as full scale value. Okay, right, sir. Here, pointer will be there. Okay, and here supply terminals. First thing you have to understand is, sir, the moment we connect this device, let me take ammeter. The moment we connect this device in the supply circuit, automatically what I told you in the starting day, the current will be flowing through the coil of the instrument. The current will be flowing through the coil of the instrument, and the coil gets magnetized. The coil gets magnetized. The moment the coil gets magnetized, what we can say, magnetic effect will be induced. So therefore, what is it? Effect will be induced. But what is that effect? Example purpose I'm giving magnetic. Example purpose I'm giving magnetic. But other things are also, I'll tell you some different effects. Right? One effect will be there. Sir, the moment magnetic effect is there, for example, whenever a current carrying conductor placed in the magnetic field, whenever a current carrying conductor placed in the magnetic field, it experiences a mechanical force. I hope everyone knows this. This is Lorentz force equation. This is Lorentz force equation. As you know, whenever a current carrying conductor placed in the magnetic field experiences a mechanical force, this is Lorentz force equation, or in the simple way, motor principle also we can say. Motor principle. Electrical people, life itself is generator and motor topic generally. That's why you might be aware of this. But IN people, base fundamental law, Lorentz force equation, current carrying conductor placed in the magnetic field, it experiences a mechanical force. Therefore, force will be produced. Okay, and the manufacturer will take care of this. About which one? The manufacturer will design this entire device, such that the physical connection, right? The force is to be exerted in this direction only, because the topic is 0 to 10, nothing but normal device. Immediately, sir, what about these type of devices? Those type of devices are not there in the present syllabus in terms of construction and operation and all. Galvanometer, we say. Galvanometer application only there in 90s, in the 2000 time, galvanometer types and construction was there. Right now, not there, no need to worry. That's why, according to the present syllabus of the two, last year also changes happened. So like that, new syllabus based only will be taken, no need to worry. But galvanometer application is there in the bridges, in the potentiometer, everything will be taken. But our total construction and operation is related to normal device only. Okay, that is 0 to full scale. Okay, right. Sir, the instrument does not know. People are thinking that, sir, how the instrument knows that force will be produced like this only. Instrument does not know. Manufacturer designed the device such that the force must be acted in this direction. Sir, which force it is? Point is like this. Like this means angular force. So therefore, what we can say? Torque. Angular force means torque. Okay, sir. Whatever the torque is produced on the pointer in this direction, definitely that torque moves the pointer from its initial position. Thereby, slowly the pointer comes over here. Okay, sir. What is the purpose of this torque? This is to deflect the pointer. This is to move. But technically, what is deflect? This is to deflect the pointer from its initial position. Deflect the pointer from its initial position. That's why this is called as TD. I'll give the name, don't worry. Deflecting torque. Therefore, the first and foremost torque required in the instrument is deflecting torque. Okay, acting in this direction. So as it is moving, right, at some point, right, assume that at this point, the pointer has stopped. For example, I'm taking here, sir, I is equal to 4. Let me take one example where it has to stop approximately 4. Okay, let me take ideally 4. Sir, this pointer is getting force only from one direction. Okay, the two here, what I told you in the starting class, bearings are placed for smooth movement. Bearings are placed to reduce the, what is that? Dead time and dead zone due to friction. I told you, inertia. That's why to minimize that, bearings are used, but we cannot eliminate it. Why? Can we say friction will be 0 for a moving object? No way. Friction can be minimized. Friction will be 0 means the moving object should not have any weight. Is it possible? No. Minimum microns related weight will be there. That's why friction will be there. No problem. Therefore, bearings are placed for smooth movement. I'll say generally. Okay, sir. The smoothly moving object is getting the force only in one direction. Is getting the force only in one direction. In this direction. Sir, how does the pointer get stopped over here? Means it is getting the force like this. Force only. How does it get stopped? Means it has to experience one opposing force also. If opposing force is not there, the pointer will be stopped at which position? Very, very important. Earlier paper model question. If opposing force is not there, you give 4, 5, 8, 9, any number, automatically pointer goes moving. Pointer goes and stopped at which value? Full scale value. Stopped at which value? Full scale value. That's why in order to stop at the required position, like according to the given value, we need to have one more force here. That force is also angular force. This is opposing force. We say, okay, so this opposing force is controlling the pointer or not? Yes, it is controlling the pointer. It is controlling the pointer to reach the corresponding required position. That's why this torque is called as controlling torque. Okay. Now, whatever the displacement made by the pointer, that is theta. Okay. Right, sir. See, if you want to have the stopping point of the pointer at the given point, right? See, this given point is called as, sir, 4 is given. The pointer has to be stopped at 4 or near to the 4. That position is called as technically final position, we can say. Final position. See, this is full scale value, but this is final position of the pointer. Final position of the pointer is not the full scale value. According to the given value, this one. So therefore, final position we can say. Okay, right, sir. At final position, the pointer is getting stopped means TC and TD both will be opposite. Okay, both will be equal or need not to be equal. In order to get the stopping point, the main force as well as the opposing force both must be equal and opposite. Then only the pointer will be stopped. So therefore, at this point, what is it here? TC is equal to TD. If TC is equal to TD, then only we can say the pointer gets stopped. But, sir, the moment we switch on the supply, TD is produced, TC is produced, okay. But the pointer gets stopped instantly, or the pointer makes oscillations like this, conceptually. Means the pointer makes oscillations. Why? Here bearings are there. Kindly consider, here bearings are there. This side one force is there. This also one force is there. The two, how much time will be taken to produce of those two torques? Fraction of seconds only. It will not take 1 hour time or 2 hours time. No. Therefore, within very less time, these two torques are produced. That too, on a smoothly moving body, on a smoothly moving body, if two equal and opposite forces are produced almost suddenly, does the moving object get stopped? Does the moving object get stopped instantly, or by making some oscillations like this? Means instantly or by oscillation, means definitely small oscillations will be there. That is what the body nature. Why? If any moving object is there, suddenly stop, definitely yes, oscillation will be there. The two, as it is smooth arrangement here, what is it? Bearing arrangement is there. Therefore, what is it? It is continuously making the oscillations. Sir, if it continuously making the oscillations, do we have any observation properly to write the value 4 or 4.1 or 5.2 like that? No, that's why these oscillations also to be removed or reduced, or we can say eliminated, we can say normally, strictly speaking. Therefore, in order to stop the oscillations also, what we require? One more force we require. Why? If any body is oscillating, we need to stop. That means some force is required. No? Yes. That force is which one here? Damping force. That is damping torque. Now tell me, in the indicating instruments, what are the essential requirements in the essential requirements available? Means deflecting torque. What is it? The torque which deflects the pointer, which moves the pointer from its initial position. Controlling torque TC. Controlling torque is a torque which controls the pointer to reach the corresponding final position. In my experiment, 4 I have given, 4 will be my final position. Suppose if I give 6, yes, 6 will be my final position. So that's why according to the corresponding given supply, yes, the corresponding TC will be produced, should be produced. Thereby the pointer has to be stopped. Next. Sir, at the final position of the corresponding pointer, oscillations will be there, but those oscillations will be nullified by again some force that is called as one more torque damping. Means oscillation means damping we say. So therefore, damping torque is required. One thing. Second thing, sir, the moment the pointer reaches over here, the pointer makes oscillations. I told okay. Suppose for example, 4 is given, 4 is there. The pointer tries to make or makes oscillations for small displacement or throughout the scale. Come on, guys, I'm asking the question. The oscillations will be for small displacement like this or throughout the entire scale oscillated, means the oscillations will be what is a small displacements only. Why? It cannot move up to this because TC is there. Is it no? Healthy. Sir, it cannot come here also because TD. That is the reason why both are almost approximately equal, means it is having oscillations only about its final position, not throughout the scale, only small division displacement. So therefore, sir, it is making small division displacement like this. Now tell me, in order to stop these oscillations, large force is required, small force is required. Obviously, small force. Why? If any body is making small distance movement, small distance related movement, in order to stop that, definitely small force. That's why always be clear. Damping torque is generally small, generally provided with small magnitude only. That will be sufficient. In that way, they will provide. So this is the complete operation of an indicating instrument. Complete operation of indicating instrument. Okay, but what is my question here is, sir, conceptually I'm saying that supply is given, effect and effect based force is acting in this direction, thereby the pointer is moving. The moment pointer is moving, opposing force must be produced, that will be equal to what is the main force, pointer has to be stopped, finally oscillation nullified. Okay, that's why this is called as complete operation of the circuit. Complete operation of the circuit. Okay, the point here is, sir, after taking the operation of this entire circuit, after taking the operation of this entire circuit, what we have to study now, how we are going to produce TD, how we are going to produce TC, and how we are going to produce damping torque. How we are going to produce these three torques is very important task. Continuation. Clear? So for the entire topic, deflecting torque, right? This is the entire thing basic. Controlling torque, complete topic is basic. Damping torque, again, complete torque. Topic is basic point. That's why step by step each and everything I gave you. Right? Okay. I'm coming in the reverse way. Sir, damping torque should come into picture when oscillations are there. One second. Right, sir. Oscillations will be coming into picture when the pointer reaches about its final position. When it is reached means Tc equal to Td. How? Tc production. Tc production is based on movement of the object. Movement of the object is based on Td. Td is based on force. Force is based on effect. Effect is based on supply. That's why whatever the value shown by the pointer will be approximately equal to, ideally speaking, equal to the given value, we can say. That's what the actual point. This is the total operation. This is the total operation. But be clear, people are asking us generally, sir, in my laboratory, I have used so many times the device, oscillations were not there. Means in your laboratory device, damping torque is already given, produced, a structure is given by manufacturer. That's what very, 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 very important thing is this one. But if you see the textbook, in a textbook take deflecting torque, moving the pointer from zero position, controlling torque, opposing force. That's it. After that, both are equal. Stop. Damping torque for stopping the oscillations. But which is the first one? What is the order? I explained step by step clearly. Very, 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 very important operation. Clear? Now we need to take deflecting torque, how it is produced, based on which one. See, deflecting torque is based on the force. Force is based on the effect. So therefore, we need to concentrate on which type of effects are there in our entire electrical field, that is electrical measurement point of view, etc. That's what the point. Clear? Right. Sir, based on this entire thing, what I'm writing here, essentials. I'll tell you, deflecting torque, controlling torque, damping torque. Don't worry, sir, give me the full form, give the definition, everything I'll give you. Only introduction I gave you. Now I'm taking, so three torques are there, deflecting, controlling and damping torque. So what is deflecting torque? Here, the deflecting torque is, which one here? I told you, it is electromagnetic torque we can say. I told you why? Here, due to the electrical supply, due to the electrical supply, due to the magnetic effect, generally called as electromagnetic force, that itself is deflecting force. This is other name. Right? The pointer starts from zero position due to the produced deflecting torque. That's why I told you the deflecting torque moves the pointer from its zero position. Yes, the pointer starts from zero position due to the produced deflecting torque. Due to which one? The produced deflecting torque. Right. It is also called as operating torque. Why? It is starting its operation. It is moving the pointer. That is the reason why it is also called as operating torque. This is a simple definition and corresponding introduction. Okay, sir. How the deflecting torque is produced means correspondingly effects. Why? Check it here. Sir, deflecting torque means deflecting force, but depends on the corresponding effect. Sir, what are the effects we are having? The effects are magnetic effect, already we have taken. In that magnetic effect, permanent magnet will be there, electromagnet will be there, and electrostatic effect will be there, and thermal effect will be there, piezoelectric, like that. So many effects will be available. One by one effect I'm giving clearly. One by one I'm giving clearly. Right. So damping torque is produced based on TC or TD, means according to which force it is produced. Be clear, kindly concentrate. Damping torque is not based on TD, not based on TC alone. Come on here. These two are equal. These two are equal. Then only oscillations will be there. Then only damping torque is required to stop the corresponding object. That is the reason what I told you. I'm repeating again, sir. First TD, then moment, then TC, then both will be equal. The moment these two are becoming equal, oscillations will be into picture, thereby the damping torque should be produced, will be produced automatically. The designing is like that only. But this is only the requirement. According to this requirement, now we need to construct the devices. That's what the point. Right? Now, sir, here, essentials. Okay. Now, deflecting torque. As I told you, electromagnetic torque, pointer starts from 0 position to the deflecting torque. And here, operating torque. Okay, right, sir. Here, sir, deflecting torque will be produced by which effects? So many effects will be there. Only introduction point of view, I have taken magnetic effect, but not only magnetic effect here. Deflecting torque can be produced by magnetic effect, electrostatic effect, induction effect, thermal effect, chemical effect, and Hall effect. See, these three are there in the measurement subject. In the measurement subject, that is what we are going to discuss. Magnetic effect is there in PMMC, MI, EMMC. Electrostatic effect is there in the electrostatic voltmeter, separate device. Induction effect is there in the energy meter, like that. This is our measurement subject. Okay, and concentrate. Those who are ESC students and those who are instrumentation students, sir, these will be generally coming in your other topic. Thermal effect, temperature effect. Those who attended my transducers IM students, they can know. Heating effect. But ESC people, after this session, after this entire subject, ESC objective, ESC prelims related to that transducer will be taken later, no need to worry. Transducer will be taken later, but presently I'm taking measurement only. And Hall effect also in that. That's why so many effects are there. But according to our subject, according to our electrical measurement, which type of things will be there means these three will be used. So this is the simple introduction regarding damping torque. After that, very, very simple, sir. Magnetic effect. Everyone knows that. Can you look at me? Look at me in the video, not the screen. Can you look at me? Whenever a current carrying conductor placed in the magnetic field experiences a mechanical, that is everyone knows. But sir, what is electrostatic force? Means two plates. Everyone knows this. It's basic point. Two plates, right? Given with supply. One is with positive, one is with negative. Okay, positive, negative. Both plates are placed like this. Definitely, one is positive, one is negative, means opposite polarities attract with each other. Attract each other. I am making this as a fixed body. I am making this as the moving body. What is that? This is slowly getting attracted like this. So my question is, the moment we give the supply, based on the electrostatic effect, movement has been taken place or not? Yes. Why? This is slowly coming like this. Movement has been taken. So therefore, what we can say, deflecting torque is produced. Sir, why? Here in this, I told you, what is that? The moment we give the supply due to the effect, what is that? Force. Therefore, the movement is being started. Yes, that only I'm giving here. So electrostatic effect. Okay, induction, they're going to take clearly, but induction motor is there for electrical people. Same principle here also. The moment we give the supply, it gets rotated. They're rotated induction. Here, movement is there or not? Yes, movement is there. Induction effect. In the same way, these three are just for idea purpose. I'm giving these three names, but our topic is this one only right now. Clear? Right. Now let us take one by one effect. So what is magnetic effect? Concentrate here. So the magnetic effect is here. Alright, just I told you, this is there in the permanent magnet moving coil PMMC instrument and MI and EM. Just I told you, I'm writing everything. This complete thing is introduction topic. What is it? So in the magnetic effect means in the magnet type of structure, there are two magnets. One is permanent magnet, one is electromagnet. Sir, if you use one permanent magnet and one coil, current carrying conductor placed in the magnetic field. What is it? Current carrying conductor placed in the magnetic field experiences a mechanical force. This principle used in a device called PMMC. Why? Sir, why? Permanent magnet moving coil. So PMMC we can say. This is one device. But Don't get confused, like, sir, how I'm not getting the picture? Picture will be taken later. No need to worry. We are going to take PMMC, instrument construction, operation, mathematics, and numerical question. Many things we are going to take. Don't worry. But where we are using, which we are using is the matter. Permanent magnet moving coil instrument, PMMC. So therefore, permanent magnet is used. Moving coil means current carrying conductor placed in the magnetic field. It experiences a mechanical force. That's all the point. Next, sir, electromagnet. Two types of magnet. No, one is permanent, one is electro. Sir, in this electromagnet again, there are two types. Electromagnet and iron piece. Very simple. The childhood days we have played one magnet, one small iron piece, some nail, etc. Yes or no? If suppose it is a nail, for example, it is a magnet. Yes or no? Now, if you are placing near to each other, definitely the nail will be getting attracted towards this. The nail is getting attracted. The moving iron piece is getting attracted. Means the iron piece is getting deflected. The moment we say iron piece is getting deflected, automatically what we can say? Okay, force is produced. Thereby the movement is being started. Which force? Deflecting force only. That is deflecting torque only. So this type of device is called as moving iron type. Nothing but in this coil is made as fixed one. This coil iron piece is made as a moving one. Therefore, iron piece is moving. People are asking that, sir, if iron piece is fixed, coil can move. Oh, yes, but instrument name is moving iron. So therefore, coil should be fixed and iron piece will be keep on getting attracted towards. Suppose like this is there. Yes, getting attracted like this. Suppose like this is there, getting attracted like this. So that is what moving iron piece is moving. Second thing is in the electromagnet only one electromagnet, one more coil. Nothing but here one permanent magnet and one coil. Here instead of permanent magnet, electromagnet is placed. Nothing but indirectly what we can say, electromagnet is also a coil. Moving coil is also a coil. Electromagnet, coil. Moving coil also coil only. Yes or no? So therefore, in this third category, means in this B second category, two coils will be there. If two coils are being taken, very simple. Complete discussion, structure, everything will be taken later. Suppose if you have two coils like this, one and like this, two coils, for example. If two coils are placed near to each other, the flux will be linking with each other. The moment flux is linking, automatically what we can say, sir, current is flowing through this coil. Current carrying conductor placed in the magnetic field, it experiences a mechanical force. Therefore, it gets rotated or it gets deflected, we can say. When I take this as a fixed coil, this as the moving coil. Purely electrical principle only, electrical machine principle only. Is that no? In your all types of machines, one is fixed coil, stator we say, one is moving coil, rotor we say. Automatically, yes, what is that? Current carrying conductor placed in the mechanical, so placed in the magnetic field experiences a mechanical force. Same principle here also. This is EMMC. EMMC we can say. Now I'm asking the question. Everyone should respond for this question. Sir, out of these three devices, which one? PMMC, MI and EMMC, which devices you have seen? Which devices you have seen in your laboratory? Which devices you have used in your laboratory? Tell me. Used out of these three, which you have used? Right. Majorly people are saying that, sir, PMMC, MI. Only few people are saying that all. Okay, one student said that only PMMC. Okay. Few people are saying that only MI. Okay. Two students have given that all. Paul Warren. Paul Varun, did you complete your BTech? Are you pursuing BTech? Paul Varun, are you pursuing BTech? Don't mind, just I'm asking because you told that I have not used anything. None of them you told. Means are you not going to laboratory? Come on. Many people told that. Many people give the answer PMMC and MI only. Come on, come on, come on. Okay, everyone, MI and PMMC only. MI and MC, but don't know how to identify EMMC. Okay, clearly definition given. Mubin, okay, right. All digital only. All digital used. Okay, okay, okay. That is what the nowadays problem actually. Right, right, right. Right, very good. See, almost everyone, those who are not you, those who are using digital, except them, I'm giving almost all the people have used all these devices. I can say every student has used all the, but people are able to recollect that PMMC. This is called as MC instrument, MI instrument, sir, EMMC. I have not heard the name. People are saying this, nothing but this EMMC is also called as dynamometer type device. Dynamometer type. Now people say that dynamometer, I use people say actually dynamometer type instrument. Dynamometer name is the normal name. Normal. What is it? Casual usage name, but technical name is EMMC. That's why in your laboratory of machines lab, generally all the devices you use generally. PMMC, where I'll give you DCR AC, etc. MI DCR AC. Right now we don't know. I will tell you. EMMC also. What is that? Dynamometer type instrument, for which purpose and all we are going to take later step by step. But kindly concentrate. You have used all these three devices, excluding what is that? Except digital instrument. If you are using digital, that is okay. But generally, we use this type of device in the laboratory. That in the electrical machines laboratory, yes, all these devices are generally used. Okay, right. Second one, electrostatic effect. So what do electrostatic? Just I told you, two plates will be there, right? Two plates getting attracted means the moving plate is moving towards the corresponding fixed plate, not completely touched, but this keep on moving up to. So therefore, electrostatic effect, two plates, the device is called as electrostatic instrument. There is no other name. If this type of effect is there, that is called as PMMC. This is MI. This is EMMC. But if this type of effect is there, directly the name is given as electrostatic instrument only. Electrostatic instrument only. Right? These two are the two effects. Okay. Next, other effects. Right? Induction effect. Induction effect. Only introduction only here. Complete everything will be taking later. Two current carrying coils will be there. How many? Two coils will be there. So two coils means, sir, earlier thing also two coil. Yes, in this two coils, one is acting as moving, one is acting as fixed one. One is acting as moving and one is acting as fixed one. Yes or no? Therefore, concentrate. Difference is there. In this, two coils are fixed coils only. Two coils are fixed coils only. Sir, if two coils are fixed coils, no one coil is moving, how can we say deflecting torque is produced? How can we say deflecting torque is produced? Means we are using some other material, that is aluminum disc. This is a moving type of device. This is a moving type of device. Clear? Right. Next, heating effect. Sir, just idea purpose, just for rough idea purpose, heating effect. Examples: RTD, resistance temperature detector, thermometer, thermistor, hot wire instrument, true RMS meter. In all these, heating effect will be there. In all these, heating effect will be there. That too in the ESC objective paper. ESC objective paper, you may be getting match the following model. Left side effects will be given. Right side instrument may be given like this instrument. You need to match the corresponding things. That's what the simple logic on this topic. Right? Now, these are the examples. But be clear, Sir, example for this one is EMMC. Example this one is MI. Name of the instrument only. Example for this one is EMMC. Here electrostatic. And here in this, all these are the examples of heating effect principle. But those who are IN students, they understand that based on the heating effect, voltmeter, pointer, etc. deflected. Yes, simply heating effect, some operation will be there. ESC prelims people, ESC people, yes, you will be studying the transducers later, no need to worry. But gate people, gate electrical people, don't worry. This is just idea purpose only I'm giving to you. Right? Okay. Resistance temperature, RTD means resistance temperature detector. Resistance temperature detector. Okay. Right. Next. What is that? Chemical effect. The chemical effect will be available in DC ampere hour meter. But in the internally, chemical energy will be there. That will be converted into electrical energy. Simply battery concept we can say. DC ampere hour meter. The energy will be stored in the chemical form. That will be converted into electrical form. So therefore, automatically DC ampere hour also will be, that is chemical effect. And a Hall effect. In the Hall effect, example, just recently 2-3 years back also, based on this direct question was in the ESC objective. Right? Hall effect examples are Poynting vector meter or Gauss meter. In that examination, Poynting vector meter has which effect? Some options will be given. Hall effect, heating effect, etc. Answer is Hall effect only. Or Gauss meter also coming at this. All these are the effects. All these are the effects. All these are the effects. Okay. For moving the pointer from 0 to corresponding position. Right. Pointer is at 0. I'm coming again. Pointer is at 0. Right. Current carrying conductor placed in the magnetic field experiences a mechanical force. With that movement, pointer will be moving. Yes, deflecting torque. Iron piece getting attracted by the electromagnet. So iron piece starts moving, pointer will be moving. Here, coil will be moving. Yes, different pointer. Like that, the corresponding movement will be available. That itself is simply yes. Clear? Right? This is the total discussion regarding which one? Deflecting torque method. Okay. Now, right, sir. Next one is controlling torque. Sir, what is controlling torque? Definition I gave you already, means I told you already, but I'm giving the definition. Sir, what is the definition? Controlling torque. It is to stop the pointer at the required final value. Be clear. It is to stop the pointer at the required final value means people are taking wrongly. Sir, oscillations are nullified. No. Oscillation will be nullified by next method. That is which method? That is a damping torque method. That's why controlling torque purpose is what? It acts in opposite to the TD and it will try to stop the pointer at the corresponding given position, required position. That's why clearly definition I gave you. It is to stop the pointer at the required final value. And controlling torque acts exactly equal in opposite direction to the deflect. That only told you is both are what is it? Equal and opposite direction. Therefore, small movement will be continued as it is having bearing type and smooth arrangement. So therefore, the pointer gets oscillated for few duration of cycles. That can be nullified by separate method. Next method is damping torque method. Next method is damping torque method. This is a simple introduction regarding the controlling torque. Right? Okay. So now the controlling torque is produced by two methods. That is spring control method and gravity control method. Spring and gravity. Very simple. In this, the controlling action is by the spring. The first one, the controlling action is by the spring. So therefore, spring control we can say. Gravity control means controlling action is by the gravitational force. Controlling action is by the gravitational force. That's what is called as gravity control method. right? This is a simple introduction. Now, very important thing is, so what is spring control? Construction, operation, mathematical discussion, gravity control, construction, operation, and mathematical discussion. Then we can conclude this entire controlling torque, because in the deflecting torque only basic operation, how the pointer is moving and all. But in the controlling torque notation, where the pointer has to stop, and where it has to be moved, etc. Therefore, what is that? The opposing force, how the opposing force is produced. That's what the simple point I'm taking now. Clear? Okay. Before that, people are having one general doubt. Sir, like this is the 0 to full scale value. Okay. What I told you, from this TD is there, from this TC is there. What is people doubt? Sir, TC becomes TD means the pointer has to be here only. The pointer has to be here only. How can we say pointer moves to full scale value, or sorry, final position and all? This is a general question asked by the students. Can you tell me? Now asking the question here. Sir, you told that TC equal to TD. If TC equal to TD, pointer has to be stopped at 0 only. Why it is coming up to this and it will be stopped? Tell me. Come on. Right. Okay. People have given the answer. Right. Clear? Right. Okay. So many answers people have given. Yes, correct only. Right. What we need to consider, in order to understand this, what you have to understand here is, right, be clear. First of all, what is this force? First of all, what is this force? This is opposing force. One student clearly typed the answer. Very good. Sir, this is the opposing force. Sir, opposing force will be into picture with the body movement or without the body movement. Come on, guys. The opposing force will be into picture physically with the body movement or without the body movement. With the body movement only. That's why. Be clear. Concentrate. I told you that's why clearly. Sir, supply is given. First effect, force, TD. After the TD, movement will be there. The movement is there, then opposing force will be produced. That's why the pointer is at 0. There is no question of controlling torque production at all, because the controlling torque will be produced when the pointer has the movement. The pointer has to move. So therefore, then only opposing. Simple logic. I'm sitting here. Can I say opposing force is acting on my body, etc.? No. Suppose one force is acting on my body from backside, for example, like this. I'm keep on moving. If I'm keep on moving, automatically, what are the friction I'm facing and all, that will be opposing my corresponding backwards. That is the reason why unless and until the movement is there, we cannot expect the corresponding opposing force at all. That's why simply controlling torque at the time of origin or starting will not be there. That will be 0. We can say. Clear? Right. Only this one I told you. Other topics I have not given, I'll give you. Okay, right, sir. Now coming to the controlling torque. Okay, right, sir. What is it? I'm coming again. Sir, pointer is here. The pointer is getting the force like this. It has to be stopped, means the controlling torque has to be produced. The controlling torque has to be built up gradually. How and all, everything with the clear circuit diagram, construction diagram, everything we are going to take. Okay, right, sir. Let us take the corresponding instrument now. Which one? Spring control method. The first method is which one here? Spring control method. Right. Concentrate. I'm explaining the corresponding things clearly. So kindly concentrate. Sir, here. In this, whatever this vertical rod is there, no, this one, that is called as spindle. In our machine's language and all, we can say that that is a shaft, we can say, but in our measurement that is called a spindle. The two, observe the spindle here, sharp edge is there, sharp edge. Here also sharp edge is there. Sir, why means simple logic. If the sharp edge is there, can it rotate smoothly or not? Definitely it can rotate easily, smoothly. Therefore, indirectly the friction can be minimized. Friction can be minimized by making like this sharp arrangement. Okay, one thing. And mention here, sir, this is spindle. Okay, right. Sir, these are, I have given pivot, I gave you. Pivot means bearings, we can say. So therefore, these are called as pivot bearings, we can say. Sir, what do you mean bearings? The bearings are for the purpose of smooth rotation. The bearings are for the purpose of smooth rotation. That's what. Already sharp arrangement plus which one here? Correspondingly bearings are used. Yes. What is it? Generally we use jeweled bearings. That is corresponding type of bearing is jeweled bearing. Okay, right. Sir, on this entire rod, on this entire, right? How many springs will you place? Generally means two springs will be placed. One is at the bottom, one is at the top. Actually, this spring has to be placed here, but in the figure normally I'm showing like this. Therefore, this is the lowest spring, lower spring or lower position spring. This is upper spring. Like the two springs will be there. Okay, right, sir. And here spring I gave, this is also spring. Right. After that, pointer will be there. Yes, this is the pointer, and this is the scale. These are simple construction regarding spring control method. Clear, guys? Construction regarding spring control method. Right. Any confusion? Can you let me know? Is there any confusion? Can you let me know once? Up to this, only up to this. Right. So only construction I have given. I have not started the operation. Don't get tense. As the question only regarding construction is clear or not. That's what the point. Right. We are providing the notes. We are providing the notes, PDF notes. Kindly concentrate. Kindly concentrate. We are providing the notes. Sunil, what is your problem? Right, concentrate. So this is the only construction I have taken. Only construction. Right. Only construction I gave you. You did not miss anything. If net problem was there, might be there, etc. No need to worry. I have not explained any operation. Only construction. And people are saying that, sir, what is that? Here, bearing purpose, jeweled bearing is a type of bearing. That's it. Enough. After that, bearing's purpose is to have the smooth rotation. Bearings purpose is to have the smooth rotation. Means here, this is a spindle. Look at me, look at this is spindle. I will spend almost 15 to 20 minutes plus on this topic. Don't worry. Just now started because I need to spend much time on this to give the complete concept. Don't worry. Sir, this is spindle. Like this one bearings are there. Like this also one bearings are there. In this bearing, it has to rotate properly. It has to rotate smoothly. Therefore, the bearings are for the purpose of to have the which one here? Purpose of having smooth rotation. Purpose of having smooth rotation. That's it. The bearing itself indicates smooth rotation blindly. Okay, after that. Other than that, I told you sharp arrangement is also there. That is also giving the smooth rotation. Why means suppose I'm taking like this. It has to rotate. It has to rotate. In which case the less friction will be there means second case. Why? Sharp arrangement is there. It can be rotated smoothly. But here, more friction, more inertia. Therefore, automatically, what is it? Losses will be more or friction will be more, we can say. Clear? Right. Now, I'm starting the operation. Be clear, guys. Be clear. Sir, how many springs are placed? 2 springs. Sir, why? First question. One spring is here. Actually, the spring is generally here, but normal top is I'm showing. One is at the top and one is at the bottom. Sir, why? I'll come to that. So, what is the spring purpose? Spring control. Spring purpose is to control. Yes or no? To control the movement of the pointer or to produce the controlling torque. Okay, right. So, controlling means what I told you in the introduction. Opposing. This is produced from the opposite direction I told you. So, my question is here. Concentrate. If this is a spindle, if I take only one spring on the top like this, only one spring, what is it happening here? Based on the rotation, based on the revolution, the spring either contracted or expanded means the spring gets disturbed. As the spring is getting contracted, expanded, due to the spring, the force is exerted on the spindle or not. Different. That is what the principle we are going to use. That's why one spring at the top, if you're top place, if you're taking, right? Due to the rotation, the spring will be getting contracted or expanded based on the position. Okay. Suppose if the spring is getting contracted, can we say, sir, from its equilibrium position, we have disturbed the spring? Yes. If any spring is disturbed from the initial position, what is it here? As it is keep on getting contracted, what happens here? This spring will produce the force in the opposite direction to the rotation. That is what I told you, spring control method, opposite force. Okay, that's why if I keep only one spring on the top, what happens here? Here opposing force will be proper, but this end is little bit free, not much, but little bit free. Therefore, here, what is it here? Some mechanical vibrations may be chance. That is the reason why one top and one bottom, 2 springs. Sir, it is creating the opposing force. It is creating the opposing force correspondingly. Therefore, yes, the system will be rotating properly. That's what the first. That's why 2 springs are required means to get the better opposing force, to get the better controlling torque throughout the entire object. That is what 2 springs are used. Okay, right. I'm showing this just idea purpose clearly. Concentrate. This entire spring is connected in this direction like this. It means clockwise rotation, for example. Here, like this. Okay. So my question here is, sir, in the instrument point of view, how the deflecting torque is produced? Which direction? Right? Here, deflecting torque is always, what is it here? Right side only. What do you say? Clockwise direction only. That is what our instrument, no need to worry. Reverse movement, we'll see that later. But what is that? Deflecting torque is produced from the forward direction, produced in the forward, nothing but clockwise direction. Okay. If it is rotating clockwise, what does it mean? The spring is getting rotated. The spring is getting rotated in clockwise. The spring is rotated in clockwise direction. So no, spindle and all. Now, sir, if the spindle is rotating in the clockwise direction, sir, what will happen to this? It will be expanded or compressed. It will be expanded or compressed. Tell me the answer. By taking this as 1 and this as 2. Which will be compressed and which will be expanded. If you understand this physical thing, not measurement thing, physical thing, my topic is very clear. First one compressed, second one expanded. Okay, few people are giving exactly reverse answer. Okay, all different combinations of answers I'm getting. Okay, okay, okay. Stop typing, stop typing. Right? Okay, don't type anything still. Right. Many people give the first one as compressed. Jayant, what do you mean by double two answer? Right. See, I'm drawing the figure separately. Double two means, is it compressed meaning, Jayant? Don't play in the class. If you don't have interest, kindly leave the session. Jayant, especially. Right, very good, very good. Right, I'm giving now. Sir, I place the spring like this. Right? I place the spring like this. This is the equilibrium position. Equilibrium position. This point is connected to the spindle. Okay. Now, if the rotation is in clockwise, consider if the rotation in clockwise means if you're rotating in clockwise, it will be expanded or contracted. It will be expanded or contracted. Concentrate. If you see this figure, already it is wound in this direction. If it is rotated in clockwise, so automatically what is it here? It will be expanded continuously. It will be expanded, not contracted. It will be expanded. Right? Yes. Now you are understanding. Okay, very good. See, in this, the thing is, it's coming like this now here. So automatically, what is it here? It is getting expanded when the rotation is being started. Okay, second one. Sir, if I place the winding like on and place the spring turns like this, if I rotate this in clockwise, try to understand the see the figure and try to rotate this in the clockwise. What happens? It will be compressed. Nothing but we say this is tighten up. Earlier one loosen up we can say, but that will become loose means expanded. Here it is becoming tighten. But my question is either expanded or compressed, either expanded or compressed, definitely springs are getting disturbed from its original position. Yes or no? Springs are disturbed from its original position. Why? Spring is normally there. Yes or no? Equilibrium position. No expansion, no contraction, nothing. It's only one thing. What is it? Equilibrium position. If I apply the force in our instrument, TD is there, no? Yes, clockwise force is produced. On the clockwise, on the clockwise rotation, what is it here? Spindle gets rotated in clockwise. As the spindle is getting rotated in clockwise, the springs placed on the spindle are getting disturbed from its equilibrium position. One I'm keeping as expanded mode, other I'm keeping as compressed mode. Okay, now people are asking that, sir, why not both expanded? Why not both compressed? You can, but if I take both in the one way, people are thinking that, sir, what about the other? What about other way? If I'm taking in the other way, both are same. People are asking that, so if two are different, what happens? See, whatever the position you take, either clock or anti-clock, either expanded or compressed, no problem. Are both expanded or both compressed, no need to worry. But what we need to understand here, the moment supply is given, effect is induced based on the earlier topic, deflecting torque is produced. Okay, the moment deflecting torque is produced, the pointer moves from corresponding zero position. The moment it is moving, which direction? Clockwise. Therefore, the spindle gets rotated in clockwise. The spindle gets rotated in clockwise. As the spindle is getting rotated in clockwise, whatever the spring, whatever the springs placed on the spindle get disturbed from their original position. Now tell me, once the spring is disturbed from its original position, does it create opposing force on the main force or not? Does it create opposing force on the main force or not? Definitely. That is the reason why. What is that? Spring force. Spring force, we can say. That is what I told you. The spring force is opposing force. So automatically, kindly concentrate here. TD is there. From this, which is there? TC is there. How can you say that means? TD clockwise, opposing will be anti-clockwise only. Okay, but concentrate here. Concentrate. Sir, everyone try to understand this number. I spent a lot of time in this. No need to worry. Each and everyone should understand each and every point. Then only my next topics will be clear. What is it? Sir, supply is not given. Pointer is at 0. What is the effect? 0. What is the TD? 0. What is the movement, a rotation of the spindle? 0. What is the disturbance in the springs? 0. What is the TC? 0. Clear? Okay, sir. Supply is given. What is that? Effect will be there. Force will be there. That is, TD will be there. This TD will be acting in this TD is acting in which direction? Clockwise direction. That is what our instrument. So therefore, this spindle getting rotated in clockwise rotation. Nothing but like this. The clockwise rotation will be there. Okay. The moment this is rotating in clockwise, the springs which are already placed by the manufacturer, are getting disturbed. From their initial, or we can say equilibrium position. One is getting expanded, one is getting contracted. In this example, or both may be expanded or both may be compressed as based on the placing. Okay, sir. The spring, that's what I told you, the springs are getting disturbed. Once the springs are getting disturbed, concentrate. Once the springs are getting disturbed, automatically springs will create the opposing force. The springs will create the opposite. That's why opposing force is coming into picture. Now visualize this. Sir, controlling torque, nothing but opposing force, comes into picture when spring disturbance takes place. Spring disturbance takes place when spindle rotated. Spindle rotated with respect to TD. TD with respect to effect. Effect is with respect to supply only. So everything according to the supply only working out. That's what the simple idea. Right? Clear? Right. See, kindly don't give any suggestions right now. I'll ask. You give the suggestions then. Right? Don't worry. In the PMMC topic, I'm going to show the video also, which is made by me, recorded by me. I will give that. First, try to understand. Without understanding, sir, show the video. It's better. Go to YouTube and watch the videos. If you ask that, I'll say like this. Otherwise, listen my class carefully. I only show the videos related to the topic correspondingly. That's why I told you to listen this first. I told you to listen means listen this. Don't ask any other questions. Okay, right, come on here. Now the question here is, sir, at the time of starting means concentrate here. The moment the pointer is coming to this position, right? How much disturbance is there in the spring? Small movement, small rotation, small displace, small disturbance, small TC. Okay, right, sir. Here, suppose if the pointer is moved with some considerable displacement, what is it here? More displacement, more rotation, more displacement, more rotation. More rotation means more disturbance in the spring. More disturbance means more force. That's why now tell me, everyone, it is very, very, very important. I can say very common possible question in the practical examples. So what is it? Sir, the controlling force is 0 at the time of starting. First point. The controlling torque is gradually built up. The control torque is gradually built up as the rotation is happening. Clear or not? So that's why I told you. Suppose the TD is 10 Newton meter, for example. the pointer is moved here. The pointer is moved up to this. The spring force may be small disturbance. Okay, it may be 2. So 2 cannot stop 10. Again, pointer will move. At this point, right, more disturbance. The opposing force may be 8. So 8 cannot stop 10. Again, moving up to this point, for example, at this point, the disturbance is giving the 10 Newton meter force, means 10 and 10 both are equal and stop. So therefore, this position is called as final position of the pointer. This is what the way of taking the total discussion of corresponding springs and all. Clear? So that's why be clear case. Be clear, sir. How the corresponding controlling torque is produced means controlling torque value is suddenly not produced. Controlling torque is gradually built up until its value is equal and opposite to the deflecting torque. Suppose according to the given value, yes, at this point both are equal. For example, what is this? Theta. At this position I can write TC is equal to TD. So this is the complete operation of what is it? Control, spring control method. Complete operation. Supply to pointer has stopped. Everything I gave you. But in this, what you have to understand clearly, the TC is not produced suddenly. What is it? As the pointer is moving, spindle is rotated, the springs are getting disturbed. So TC increased, gradually built up, finally equal to TC equal to TD. Finally is equal to TC equal to TD. Then it will be stopped. So angle of deflection made by the pointer is theta. This is a complete working or operation of the spring control method. Okay. Again, I'm explaining one more time with the mathematical discussion. What is that, sir? Whatever the theta took place by the pointer depends on TD or independent of TD. Definitely, displacement taken by the pointer will be dependent on TD. Definitely. What is that, sir? More TD, more displacement. More TD, more theta. And less TD, less theta definitely. Therefore, it is dependent. So therefore, what we can write, sir, theta is proportional to TD. Theta is proportional to TD. One thing. Second thing, sir, whatever the controlling torque we are getting in the instrument, that depends on, concentrate guys, this is very important. The controlling torque produced or magnitude of controlling torque is getting produced is depending on springs disturbance. Springs disturbance depends on spindle rotation. Spindle rotation depends on pointer movement. Pointer movement depends on TD. So indirectly, TC also based on TD. TC is also based on TD only, but both are acting from opposite direction. TC also proportional to TD, but both are acting from opposite. That's why I written TC proportional to TD. After that, sir, theta proportional to TD, TC proportional to TD. Therefore, TC proportional to theta. This is what very important formula in spring control method. But, sir, TC and theta acting from opposite or same direction. Theta is taken from this direction. TC is taken from this direction. Therefore, opposite only will be there. Opposite only will be there. But TC proportional to theta only we write. Now here, by using the mathematics, people are saying that, sir, we should write minus sign, sir. No, TC itself is opposing force. If you're writing minus of opposing force, it gives aiding force. TC aids the TD or opposite TC, opposite TD. Opposite TD. That's why don't keep minus sign at all. The TC itself indicates opposite. If you're keeping negative, negative of opposite becomes positive, not at all acceptable. Clear? Okay. Now mathematics. So if you remove the proportionality constant, Kc will be coming. What is Kc? Spring constant. Spring constant. In the ESC, objective question, sir, what is the unit of spring constant? What is the unit of spring constant? Right? That is here Kc equal to Tc by theta Newton meter per radian. But no one should say spring constant. Constant means no unit, no year, no. Based on the corresponding context, yes, unit may be there. Yes, Tc by theta unit is there. Newton meter per radian. Okay. Sir, what is Kc? What is Kc? Concentrate. The Kc is, this is empirical formula. This is the experimentally given formula. Experimentally and empirically given formula. This is Kc is equal to EBTQ by 12L, geometrical physical strength, right? Now, this is the general formula. Kc is equal to spring constant Kc formula. Now people are getting confused, sir. Kc formula, this is correct or this is correct, means both are correct only. Sir, why? R is equal to V by I, correct. R is equal to rho L by A, also correct. Therefore, this is technical formula. This is geometrical formula. We say same thing here also. What is it? This is technical formula and this is geometrical formula. K is equal to EBTQ by 12L. Where here B is breadth of the spring or width of the spring, we can say. Width of the spring. So what do you mean by that? Sir, I am placing the spring like this, manufacture, or spring like this. Like this. Sir, both are having 1-2 tons only. Both are having 1-2 tons only, but occupying width is different. So based on this also, the contraction force or expansion force will be dependent definitely. That's what spring constant. Okay. Now, second one. T, thickness of the spring. Thickness of the spring. What is the thickness? This is one spring and other spring is like this. Do we get same contraction expansion in both the cases? Do we get same contraction expansion in both the cases here? No. Why? It is more thickness. It is less thickness. Definitely no same contraction expansion. So therefore, that also will be taken care of by the manufacturer according to the capacity required by the operator. And the next one is L. Length of the spring. Length of the spring means here I am taking only like this, but I'm taking like this. Do you get same contraction expansion? No. So that's why before designing the structure, the manufacturer will do all these analysis. How much is required? 0 to 5 ampere current ammeter structure customer is required. In that, how much length of spring, how much thickness of the spring, how much width of the spring, everything must be checked first before design. That is called as manufacturing stage of the corresponding thing. So therefore, yes, all these also playing the role. Now, so what is E? E is Young's modulus. Young's modulus. Young's modulus or modulus of elasticity, all are same only. What is the formula generally? Stress by strain. I hope everyone knows. Young's modulus formula, stress by strain, stress, force by area, strain, delta L by L. Delta L by L, no unit. So therefore, force by area, Newton per meter square. So based on all these three parameters, yes, we are going to have the corresponding spring control method mathematical discussion. Clear? Okay. So what is it? TC proportional to Kc theta. Okay. Now I'm taking small assumption. Now I'm taking small assumption that is a universal assumption. No need to worry. Sir, what is it? TC proportional to Kc theta. But my question is, sir, after designing the structure, Kc is constant or variable. Means after designing, Kc is constant. Why? Means check it here, sir. After designing, we cannot change the material, we cannot change the length, we cannot change the thickness, and we cannot change the width also. That's why after designing the corresponding device, all these are constant. So automatically Kc is constant definitely. So that's why I'm taking here Kc is constant. Therefore Tc proportional to theta. That only we have got directly by the operation. Again, experimental I proved it. Okay. Okay. Tc proportional to theta is the final value we require. But sir, here If TD is proportional to I, sir, why only you are taking I? No problem, you can take I square or something you take. I'm taking if TD proportional to I. Sir, why you are taking assumption means what I told you in the corresponding TD explanation. PMMC may be there, magnetic effect. MI may be there, EMMC may be there, electrostatic may be there, any type. But do we know the type of the device here? Which type of device? We don't know. It may be PMMC, it may be MI, EMMC, electrostatic or induction, anything we don't. That's why in each and every device, TD setup is different. Deflecting torque is different. That's why I'm assuming some assumption. If TD proportional to I, at final position, TC equal to TD. What is TC? Theta. What is TD? I. So theta is proportional to I. This scale is called as which scale here? Linear scale. This scale is generally called as linear. Why? Theta proportional I means Y proportional to X model, linear scale of the corresponding device. This is a total construction and operation of spring control method. What is it? Kindly look at me. Look at me. Kindly look at me and visualize. First, everyone, look at me. Supply is given. The moment supply is given, effect is produced. Which effect? Magnetic, electromagnetic, electrostatic, or induction and chemical, heating, Hall, any effect. We don't know right now. Okay. Due to any one of those effects, what will be there? Deflecting torque is produced. First, due to the deflect, kindly look at me. Don't think anything. Just visualize. Due to the deflecting torque, the pointer will be moved. As the pointer is moving, spindle gets rotated. As the spindle is getting rotated in the clockwise, the springs which are already placed on that gets disturbed. Gets disturbed means either compressed or expanded, contracted or expanded. Okay. The moment the springs are getting disturbed from their own position, the springs will create the opposing force. So therefore, based on the moment, opposing forces keep on getting built up. Though that opposing force will be equal to deflecting force when the point at the time the pointer will be reaching the corresponding given 5 is given 5, 10 is given 10, 20 is given 20 like that. Clear? So this is the total operation and corresponding mathematics already have taken complete mathematics. Clear? Right? Okay. One more thing. Right. Very good question, sir. Here, I'll be taking that. See, the springs are designed such that maximum expansion by this or maximum contraction by this will be giving the full scale value accordingly. That's why I told you here. That's why I told you zero in my earlier topic. I told you 0 to 5 ampere is the customer requirement, so that how much thickness of the spring, how much width of the spring, how much length of the spring, and what type of material, everything will be decided. So that's why be clear, guys. Kindly, if the spring is getting maximum contracted or maximum expanded, then the pointer will be stopped at full scale value. In that way, the corresponding designing. That's why according to the customer designing only, the length, the width, and correspondingly thickness, everything will be taken. Clear? Okay. Now, sir, gravity control method. The next one is gravity control method. Sir, what is that gravity control method? What is the gravity control method? Right. See, okay, one more doubt, general doubt, this general doubt. Sir, as it is getting compressed like this, width is getting changed. No, concentrate here, concentrate. Width is getting changed based on the operation. That is what we require. But what I'm saying, if he has given this much of width, by the manufacturer this much of width, after taking that, opening that, and you're making the same spring width like this, is it possible? Then it will be producing different contour. That's why I told you, what is it? After designing, whatever the equilibrium thickness, nothing but width, equilibrium position, length, all those cannot be changed at all. That is the reason why we can say that all values are being constant. Yes, so KC is constant. Good question, sir. Width will be changing, no? Width should vary during the operation according to the supply given. But my meaning of constant is this is the width he has given. Before starting the device, we are changing the dimensions. Can you change the dimension? No, by making like this. If this is given, can you make like this, sir? Never. If it is done, wrong answer. That is not the point. Clear? Right. Mechanical losses will be common. One more student is asking, sir, width and thickness. Just now I told you, width and thickness means here, this is the width. This is the width. Nothing but width of the spring means space occupied, area occupied by the corresponding spring, we can say. But thickness of the spring means thickness of the spring material. Here, one spring and one more spring. Here, small thickness spring, but here, more thickness spring. This is called as different thicknesses. Clear? Right. Very good question. Very good question. Yes, yes. Concentrate, concentrate. Sir, that's why I told you. That's why I told you. Simple logic here. Simple logic. Here, I'm asking one question. Here. Sir, suppose one motor is there. One motor is there. Right? This is the shaft. This is the shaft. Motor or generator something. You want to measure the speed of this shaft. Sir, if you want to measure the speed of the shaft, you will be using one tachometer arrangement like this. So my question is, sir, if it is making 1200 revolutions per minute, it will show 1200 revolutions per minute. How does it know? How does it know? Means this will be designed by the manufacturer by the experimental and testing process. Here also, people are asking that, sir, this much of thickness should be there, or this much of thickness, or this much of thickness. How does he know? I mean, he is a manufacturer here. He is having the complete analysis, like, so this much of width. That's why that is called as mission designing subject. Mission designing subject, one subject will be there in the BTech for electrical, but unfortunately in most of the universities that mission designing subject is not there. That's what the problem. While you are taking the mission designing, some standards will be there. This much of width, okay, it is used for 0 to 4. This much of thickness, 0 to 4. This much of length, like that. Some experimental results will be there. Based on that, they will design. That's why as you are preparing for GATE and ESC and competitive exams, kindly, what about the construction standards and all? Not required. That you will do after the MTech in the PhD research. You can do. Kindly don't worry and don't get tensed about those. So this is the total thing related to. That's why how does it know means, yes, it will be designed according to the corresponding operation. That is called as calibration of the device or designing of the device, we can say. So this is the total discussion regarding entire spring control method. One thing, sir, people are asking one more question, general question, sir. Here, why two springs are in opposite? I did not say opposite only. No, you can keep both like this. You can keep both like this. Right? You can keep one like this, one like this, as you wish, as you wish. But generally, on figure point of view, I'm showing one in the corresponding one direction, other in the all will be equally working, no need to worry. Which is best also, people are asking. All are equally working, no need to worry. That's why one of the things I'm showing, that's it. So this is the complete discussion regarding spring control method. Clear? Right. Assumption as you wish. So can we take TD proportional to I square? You can take, no problem. But according to my assumption, I'm taking simply TD proportional to I only. Can be only I. And people are asking that, sir, can we use 3 springs? Not required. Not required. Why? This is the rod. Here one spring. Here one spring. Sufficient you're getting. No. Why to keep one more spring at the center? Means complexity will be there. Extra cost, which is not required. That's why experimentally proved and analyzed and decided only 2 springs. Only 2 springs. Clear? I'm giving the break. Don't worry. Clear, guys? Right. This is a total discussion. Yes. Take the break and come back. Right. Yeah, just I want to clarify these because after the break I'll be going for gravity control. That's why I've concluded this entire thing. by clarifying your doubts. Okay, take the break and come back. One more thing, 15 minutes break, and after 2 hours, one more 15 minutes break will be there. Finally, 8:30 closing today. Okay, right, 15 minutes break. Come on, guys. Ravi Kumar, correct. You are right. Okay. Now, concentrate here. See, very simple. Yeah. And generally topic doubts will be there here. Concentrate, sir. People are getting one small doubt here, sir. One is expanding, one is contracting. Both will nullify. Come on here. Both will not be nullified here. Here, expanding and contracting is looking like reverse, but expanding, what is that? Spring is disturbed from its initial position. Contracting, spring is disturbed from its initial position. Don't think like, sir, one expanding, one contracting, nullifying. No, here, no, no. These two are combinedly opposing the corresponding TD. So that's why don't get confused. Expand and contract, both are nullified. What is the use? Not like that here. Both are disturbed from original position. Both are disturbed from original position. Combinedly giving the corresponding opposite force to the deflecting torque. One thing. Second thing. Other people doubt is, sir, why not only one spring at the center? Why not only one spring at the center? All I told you, based on the designing and experimental analysis, the better method they have proved experimentally is one spring at the top and one spring at the bottom. But you may be thinking that, sir, if I keep one spring at the center perfectly, yes, but compared to this, this is better. This is better comparatively. That's why always two spring method only given practically. Two spring method only given practically. Right? And Vishnu, Ajit, all I told you, both can expand, both can compress. One can expand, one can compress, but figure point of view, one of the figures I have shown already. I told you, one of the figures I have shown. No need to worry. You can keep, all I told you, you can keep both. Just now I told you, you can keep both compressed. You can keep one this and one that also. No need to worry. For figure point of view, I'm showing one of the figures. That's it. Second thing, sir, here one more doubt, sir. TD proportional to I. Sir, if I take TD proportional to I square, it will become non-linear, no? Yes. Right here. Yes, but our conclusion, my conclusion with this assumption only I'm taking. Let me take one example. Based on that, I'm giving one conclusion. If you take something else, other will be the conclusion. So no need to worry. No need to worry. Right? UF means uniform scale. UF means uniform scale. Right. See, springs will produce TC, not TD. Springs will produce TC, which will be opposing to the TD. Come on, guys. After the listening of so total story, you're asking, springs are producing TD. Come on here. Springs are for which purpose? Controlling torque purpose. Springs are producing the TC. Both springs are producing the TC. That is equal to TD. At the time, the pointer will be stopped over here. Clear? Right. Clear, guys? Okay. This is the thing I'm repeatedly saying. Whatever the thing I have not explained, don't ask the question, but still you are doing the same thing. Okay, right. Next. Sir, gravity control method I'm taking. I did not say controlling torque is completed. No, spring controlling method is complete. I did not say spring controlling method construction Working principle, mathematical discussion over when the supply is given. But one more thing is there, when the supply is switched off, when the supply is removed, right? Then what happens? I'll tell you later. I'll tell you later. Second thing, without completing the entire topic, sir, spring problem. What is this? Come on here. I'll be giving advantages and drawbacks later. Let me explain the concept one by one. Sir, coming to the gravity control method. Coming to the gravity control method. Sir, gravity control method means the entire controlling force by the gravitational action. Very, very simple, right? This is gravity control method. Gravity control method. Sir, here, so far we have taken spring contraction, spring expansion, or both contraction or both expansion, anything, no problem. But now, sir, gravity means based on the gravitational force, we are going to get the controlling torque. Very, very simple, sir. At the time of starting, when the pointer is at initial position, this is one weight, this is one weight. These are the two weights, two rods, we can say. One rod and one more rod. Two rods are, we can say, two weights, we can say. Okay, as I kindly concentrate. Supply is given, effect is induced. Based on that effect, TD is produced, but PMMC, MI, EMMC, electrostatic, etc. we don't know right now. Only what we know, TD is produced, we know. That's it, we know. Very, very important, but a simple point. Spring control method is a somewhat lengthy topic to understand, but gravity, very, very simple. Sir, what is happening? Supply is given, effect is produced, deflecting torque is produced, pointer is moving like this. The moment the pointer is moving, come on here, whatever this small circle is there, no, that is spindle. Means as of now, I have shown the spindle like this. I have shown the spindle like this. Now I am showing the spindle like this. That's it. Only view is different. I have shown spindle like this so far. Now I'm showing the spindle like this. Only one dot. Only one dot or one circle will be there. Only one dot or circle will be there. Okay, fine, sir. To the spindle, one weight and one more weight is placed. Initially, at the time of starting, when the pointer is at 0, this weight exactly vertically, this weight exactly horizontal. This is the position I'm taking. Okay, so my question is, sir, supply is given, pointer is moving, spindle is rotated. So automatically, this weight moves like this automatically. So therefore, what happened? As it is keep on moving, one weight come over here, one weight come to this. Means this weight coming here, this weight is going here. Yes or no? Again, further moving, one weight here, one weight here. Further moving, exactly like this. Finally, means with the movement of the corresponding pointer, the weights will be correspondingly moving. Why? These two weights are fixed to the corresponding spindle. Okay, right, sir. Among these two weights, concentrate very small, crucial point, small but crucial. Sir, among this and this two weights, which one among these two weights, which one gets, or which one moves which one moves against to the gravitational force? Which one moves against the gravitational force? This one is moving against the gravitational force. So that's why, what is that? Gravity, our control method. So that's why this vertical rod is called as control weight. This vertical rod is control weight. But this rod is just for the purpose of balancing purpose only. Physical system, one is moving like this, etc. means some balancing is required. That's why it is called as balance weight, we can say. One rod is balance weight and other rod is control weight. Sir, why it is control weight? Why it is control weight? Means the control weight is moving against the gravity during the operation. If any object, very simple, if any object is like this, if any object is moving against the gravity, come on guys, if any object is moving against the gravity, automatically it experiences a gravitational force. Therefore, gravitational force is opposing the body movement. But in this way, TD is there. In this way, TC is there. Now tell me, TC, which one? Gravitational force. Gravity is our control. Therefore, TC opposing the TD. This only generally we write over here. That's it. Generally, we write like this, TC. Clear, guys? Very simple. There, contraction, expansion means people got confused. Why not two same contraction? You can. Why not two same expansion? You can. One contraction, one expansion, you can take it. One thing, sir, spring material, everything I'll give you. But there, what is that? Contract expansion means some more visualization is required. That's why I spent a lot of time. But here, very simple topic. Control rod is like this. It is keep on moving like this as the supply is given. So therefore, it is moving against the gravity. Automatically, it will experiences a gravitational force. So on this weight, control, what is it? Gravitational force is acting in this direction. So automatically, what will be there here? Suppose, concentrate. It is there like this. Concentrate, it is there. Suppose TD, 10 Newton meter is there. It is moving like this. Sir, if it is moving up to this, for example, on this gravitational force will be there. Assume the 3 Newton meter, for example. My, what is it? Deflecting torque is 10, but gravity is only 3. Will it be stopped? No. Again, more. Sir, more against the gravity means more gravitational force. Suppose 7, but TD is 10. Suppose at this point, suppose gravitational force is 10, TD force is 10. Automatically, both are equal and opposite. That position is called as TC is equal to TD over. That is what the simple point. Clear? Right? So this is the operation regarding which one here? Gravity control method, the simplest method. Spring control is somewhat lengthy because complicated, strictly speaking, complicated. That's why I spend a lot of time. But here, simple logic. Yes, it is keep on moving. Yes, gravitational force is there. Keep on moving, gravitational force. Whenever the gravitational force equal to the corresponding TD, it will be stopped. It will be stopped. Thing will be done. Clear? Right. Now, sir, whatever the deflection made by the pointer, that is simply called as theta. That's simply called as theta. Right? Okay. Advantages, disadvantages. I'm not explaining right now. After this, I will explain. Okay. Right. Now, see, continuation I'm giving. See, same structure. I'm explaining with the corresponding figure after having the movement and all. Sir, this is the corresponding scale. This is at 0 position. This is at full scale value position, right? And what is this? This is the angle of deflection, theta. Okay, sir, this is the starting position, 1 and 1 starting position. After having some operation, this is 2 and 2 position. Isn't it? Therefore, what we can say, this position is called as which one? Final position. TC is equal to TD. In this TD, in this direction, TC. Here, I have not shown the second position. Here, I'm showing, yes, at which point it will be moving. It will be coming over here. It will be coming over here. That's it. That is what? Simply gravitational force. Right. Here, kindly don't worry about the which way it is more and all. All I told you just now, designing stage related questions not required. That is called as research oriented questions. Sir, which way it is more, which way it is less, that depends on its construction, operation. That is not required for us. No need to worry. Okay. Right. After this, I'm taking the mathematics now. I'm taking the mathematics. Sir, what is it mathematics? Be clear, guys. Be clear. Sir, here, this is the spindle. This is the starting point of the weight. What is it? Control weight only I'm taking. Control weight. Sir, after some time, the control weight is reached over here. Control weight is reached over here. Sir, if this is angle of deflection theta, can I say this also angle of deflection theta? Yes, right? Starting point of the weight, starting point of the pointer. Final position of the weight, final position of the pointer. So automatically both are same. So therefore, I can take this as theta. Okay, right, sir. On any inclined body, there are two axes, physics based. What is that? One is horizontal axis, one is vertical axis. One is horizontal and one is vertical axis. Okay, sir, the length of this rod, the length of this weight is L, and weight of this entire rod or corresponding structure is W per unit length. I'm coming again. Whatever the weight I have taken, what is it? W per unit length. W per unit length, something. Okay, control weight. So therefore, sir, W per unit length into length. So what is the total weight of the rod? Now question is, sir, after designing the structure, total weight, after designing the structure, total weight will be constant or variable? After designing the structure, total weight will be constant, because as an operator, we cannot move, we cannot cut that, we cannot add something, etc. Therefore, WL is constant. Okay, right. So this is WL. Okay, from here to here. Okay, now, sir, what will be the value of this axis? What will be the value of this axis? Sir, this axis is horizontal to this. So therefore, what is it? WL cos theta. I hope I know you people know. Horizontal means cosine, vertical means WL sine theta. Okay. Now the question here is, sir, the TC means gravitational force, that is controlling force in our topic, proportional to which one? Proportional to which one? Be clear. Proportional to W1, proportional to WL sin theta, proportional to WL cos theta. Means simple logic. Sir, in which direction gravitational force is acting? In this direction, first one. In this direction, second one. In this direction, third one. Which direction means? Always, what is it here? The body is moving inclinely up. Body is moving inclinely up means the body is getting the gravitational force in which direction? In this direction. Kindly concentrate. This is the hand, right? This is the weight. It is keep on moving like this. As it is keep on moving like this, gravitational force will be in this direction, in this. So therefore, WL sine theta. Therefore, TC proportional to WL sine theta. All I told you, WL is constant. So therefore, what we can write here? TC proportional to which value? Sine theta. TC proportional to sine theta. Now, I'm taking same assumption what I have taken in the earlier thing. What is that assumption? If TD proportional to I have taken one assumption. Based on that assumption, I have given the corresponding example. Immediately, people are asking, so if square is a relation, it's automatically changing. No need to ask that question. If the square is there, will it be called as still a linear? No, no need to. That's why I try to understand my statement. For this assumption, this is the logic. And same assumption I'm taking to compare spring and gravity control method. To compare spring and gravity control method. That is, if TD is proportional to I. If TD is proportional to I. And I already told you at final position. At final position. What is that? TC is equal to TD. Okay. What is TC? Sine theta. What is TD? I. In our assumption, I. So therefore, theta is proportional to sine inverse I. Now tell me, is it linear scale or non-linear scale? Is it linear scale or non-linear scale? Right? It is obviously non-linear scale only. Obviously non-linear scale only because it is cosine based. Cosine based, nothing but sine and sine family we can say. So therefore, this is what is a non-linear scale. So therefore, what is it here? Simply this scale is non-linear or non-uniform. Means, sir, for the same assumption of TD proportional to I and TD proportional to I here, TD proportional to I here, what is the assumption? So what is the assumption? TD proportional to same assumption. Then what is the relation here? One is linear, one is non-linear. Therefore, which is operating properly with this assumption? I'm talking with this assumption. What is it? Spring control method is operating properly, but gravity control method is not operating properly. Sir, why? Concentrate. Sir, TD proportional to I means the deflecting torque is produced based on the current, but deflection is produced based on the sine inverse of current. Means displacement is not following the deflecting torque. Concentrate. Displacement is not following the what is the deflecting torque properly. I'm coming again. based on the TD, movement should be there. But here, TD based on current, if I take, movement is not based on the current, based on sine inverse of current. Therefore, gravity control method is not working properly. But sir, here TD proportional to I means whatever the deflectant torque is produced, that is proportional to I. Therefore, here theta produced also proportional to I means theta proportional to I means theta indirectly proportional to TD only. Yes, more the TD, more the theta is working properly. That's why this assumption I have taken. Suppose if you take the I square also, no problem. So TD proportional to I square, theta also I square means TD based on the square of the current, displacement is also based on the square of the current, working properly, even the non-linear working properly. But if you come to this point, sir, if I take like this, still TD proportional to I square, but theta proportional to not I square, sine inverse of I square, still difference is there. So that's why on the overall way, which method is best as of now, operation wise, which is best here? Spring control method is best. Clear? Second thing, sir, among these two, which is suitable? Now I'm comparing here. Among these two, which is suitable for both horizontal and vertical position of the instrument? Means instrument is there. I can keep the instrument like this. I can keep the instrument like this. Means which one here? Spring control method. We can keep this spring control method device. I can keep in the vertical way. I can keep in the horizontal way. Any way I can keep. That's why spring control method is suitable for both horizontal and vertical positions. But sir, what about gravity control? Sir, gravity control weight is like this. Everyone, this control weight I'm showing, this one, this control weight is like this. Yes, it is moving like this. Yes, moving against the gravity. Yes, gravitational force will be there. Controlling force will be there. I told you. Okay, but say the same instrument, I'm keeping horizontal like this. I'm keeping horizontally. Yes or no? If I keep this horizontally, how does it move? Like this it moves. Means it is moving horizontally. If the control weight is moving horizontally, does it get any gravitational force? No. Gravitational force is not there means gravity control is not there. Means controlling torque is absent. If controlling torque is absent, what I told you, the pointer directly goes to full scale value always. Wrong reading. That's why this gravity control method is suitable only for vertical positions, but spring control method is suitable. Spring control method is suitable for both horizontal and vertical positions. That's what the point. Now we can conclude now. So spring control method we prefer or gravity control method we prefer. Can you tell me which method we prefer? Spring or gravity control method? Means spring control. Why? I'm giving two. I'm given to spring only. Why? Means the spring has the proper operation with respect to the produced TD plus the spring control method can be operated in either horizontal mode or vertical mode or inclined mode, any mode. But gravity control method is always in vertical mode. Yes or no? That's why mostly, what is it here? Gravity control method is generally not preferred due to this problem. Which one? Vertical problem is there, and operation wise also theta not following the TD. If theta is not following TD, wrong operations only. That's why we don't prefer this. One thing. Second thing is concentrate. Sir, here, this is there. See, I can keep this entire scale like this. I can keep this entire scale like this. Means pointer is at this point, starting. Right? Spindle is rotating like this. Means the pointer can be moving throughout the scale. Yes or no? Means 180 degrees scale position is also possible in the spring control method because there is no problem of any rotational because it is keep on getting contracted in the circular motion. Yes, the pointer may be moving 180 degrees. I can say 360 degrees also possible, but reverse scale I'm not taking. Reverse. So therefore, 0 to 180 degrees scale is possible when spring control method is there. But it will not be clear that much. Now, I'll tell you. Second point. In the gravity control method. Sir, in the gravity control method, the movement should be only for 90 up to 180 also possible. Means only 90 because concentrate. Now you can understand, sir. These two are starting positions. Okay. Suppose this is coming over here. It is coming over here. Okay. Next, again rotating. Now, what is it here? Balance weight is here. Control weight is here. Balance weight is here. Control weight. How much rotation? 90 degrees rotation took place. Okay. So even after this, if you want to operate it continuously, will it be operating properly or not? No. Why? Means after 90 degrees of rotation of the system, what happens here? This balance weight, this control weight, now it is still rotating. For example, control weight move over here, balance weight come over here. Therefore, after 90 degrees, both balance weight and control weight are moving against the gravity. Therefore, on the two bodies, the gravitational force will be taking place. Thereby controlling torque will be disturbed. That's why the gravity control method operation is limited operation up to which one here? 90 degrees operation only. 90 degrees operation only. I'm coming again. Concentrate. Kindly visualize. Sir, this is the starting position. Okay. 1 ampere, 2 ampere, 3 ampere. Something is given. Flowing. Okay. Some current. Okay. At one place, it is coming over here definitely. So after this, we need to, means manufacturer should take this position as the full scale position. Manufacturer should take this position, the full scale position. Suppose if he has not taken this as the full scale position, what does it mean? Okay, something else is there. What do? Okay, we will give some more current. Okay, if you give some more current, it will be coming over here. So therefore, balance weight is moving against the gravity. Control weight is also moving against the gravity. But what do we balance here? Balance means only for the purpose of balancing, not for the production of torque at all. Why? Means half of the journey, one weight is taking care. Next half of the journey, two weights. Come on, how can we do? That's why the gravity control method is applicable or restricted for only, what is it, 90 degrees of operation. Only 90 degrees of operation. If you see like this, all are drawbacks available for gravity control method. All are drawbacks only. What is the thing I have taken? What is it? First one, the operation is not proper. Theta not following the TD perfectly. Second one, that's what I'm writing this exam non-linear. Second example, it is suitable only vertical positions. Third one, the scale will be limited, restricted for up to 90 only. But these are not problems in the PMA. What is it? Sorry, spring control method. Yes, advantage only. At least now also we can say, yes, generally we prefer spring control method only. That's why whatever the device you used in the laboratory, PMMC, MI, EMMC, or for any type of meter, generally for current, voltage and power measurement devices, which only are spring control method only used. Spring control method only used. Clear? Clear, guys? So that is the reason why we need to know about the instrument which is with gravity. You should place vertically only. Which is with spring, you can play with that. You can place any one position, no problem at all. That's one the point. Right? Advantage and drawbacks. Okay. But people are asking, sir, don't you have any advantage in gravity? Yes, advantages are there. Simple construction. Simple. Why? Pointer, spindle, and two rods sufficient. But in the spring control method, what is it here? Two springs are two. Fine construction. Certain width must be maintained by the manufacturer. Certain thickness, certain material, everything. That's why complex construction. Complex construction, spring, and gravity, simple construction, a robust, rugged construction. And as the springs are there, automatically temperature effect will be there too. Fine construction means very, very small. What is it? Sensitive elements will be used. Therefore, temperature effect will be there. There, temperature effect is less. And here, due to the spring nature, what is it here? After some years, what we can say? After some years or after some time, we can say, what is that? Aging problem will be there. Yes, therefore, more aging effect in this, less aging effect in the gravity control. That's why advantages are there, disadvantages are also there. But still, what we prefer? Still, spring control. Why? whatever the drawbacks are there. What are those drawbacks? Complex in construction. What is it? Complex in construction, but not possible. I'm saying complex, no problem, because more advantages are there. Temperature effect is little bit more compared to, what is it? Gravity control. Aging effect is also little bit more compared to gravity. No problem at all. Why? It is having plenty of advantages compared to gravity control. That's why we can go for spring control. Generally, we prefer spring control method. But if I ask the question like, if any instrument is given to you which is designed with gravity control method, means that must be placed always vertically only, not horizontally. Right? What is aging effect? Lifespan. Yeah, lifespan. As these are fine in construction, contraction, expansion, contraction, expansion, contraction, expansion. Automatically, what is it? Operation will be continuously happen, means the expiry date we can say that will be there. But in that large way, robust structures will be there, keep on moving like this. But here, spring fine construction, so therefore aging problem will be available here. So this is what the total discussion regarding what is it? Spring as well as gravity control method. Right? Okay. People are asking that, sir, in the gravity control method, balance weight, we are not taken in the mathematical discussion. What is our topic? Control. Control. I'm repeating control. Among these two, which is control weight? This one only. That's why I told you. This is only for physical balance. Only for physical, that is mechanical balance purpose. People are asking, sir, if mechanical, this is not there, mechanical balance will not be there. This will not move properly. This will not operate properly. That's why mechanical balance purpose, we are using the balance. If this is not there, definitely instrument will not have the proper mechanical balancing. Therefore, entire operation will be disturbed. This is what the complete discussion regarding what is it? Spring and gravity control methods. Clear? Right? In this theta, only control weight, not the balance weight at all. Why? Control weight moving from its initial position and moving back. So theta with respect to control weight only. Control weight only. Clear? Right. Now, finally, I'm repeating the last point. Sir, why TC proportional to sine theta? Kindly look at this figure. Look at this figure just in the phase opposition. Right? This is moving like this. Which one? Yeah, this is moving like this. As this weight is moving in this direction, gravitational force will be acting inclinely downward or vertically downwards. Inclinely in this direction only, gravity will be there. That I'm going to show now. Concentrate. Sir, in this way, the body is moving. In this way, the body is moving. In which direction the gravitational force will be there? Means in this direction. Which direction? In this direction it is there. What is the direction? This one. That's why WL sine theta. Vaishnavi, clear? Right. So damping I have not started. Srikanth, damping we have not started. That is later. Control. See, everything will be given by manufacturer. Right? Okay. See, people are asking, sir, this is given by manufacturer. What you are asking, electrical people, sir, you are studying the machine. You are asking like, sir, rotor will be given by manufacturer or not? Stator will be given by manufacturer or not? What is this? What is that question? Clear, guys? So this is the total discussion regarding which one? Construction operation of spring and gravity control method. Spring and gravity control method. Clear? Right. And sir, this W into L is not length here. W into L is weight of this entire length. That's why I have given the arrow mark like that. This is not length. What I told you, L is length, W is weight per unit length. So total weight is this. Understanding purpose, here to here, weight is there. This is only axis. This is only axis representation point of view. I have taken like this. Clear? Now let us note all the advantages and disadvantages clearly. Let us note all advantages and disadvantages. Clear? See, I'm giving the notes. Everything, no need to worry. Okay? Right. Now, see, I will not miss any note point in the notes. What I'm providing as a PDF, don't worry. I did not say, I don't give, sir, give the notes, give the notes, give the notes. And 4 days over, are you not understanding my way? Yes or no? I'm giving the notes. I'm giving the note, kindly wait. Here, spring control method, all the summary points, what are the thing I have taken here. Sir, whatever the springs we use, generally called as hairspring used provide to control, used to provide the control. Hair springs are, we can also say that, the name of the spring, we can also say that those are simply spiral springs. We say spiral springs means the corresponding corresponding contraction expansion happening in clock and anti-clockwise notation. So that's why spiral springs we can say. Okay, right. Kindly, very important point, but only note, I have already kept the star mark. This will be more clarified when I start PMMC and MI, but be clear. In the moving coil instrument means in the PMMC, for example, here springs are connected in series with the moving coil. Springs are connected in series with the moving coil. That is, springs are carrying the current into the coil and out of the coil. Means in the PMMC, the coil and spring both are connected in series. Sir, why? I'll tell you later in the PMMC. Okay, but in MI instrument, there is no physical contact between the coil and spring. That is, spring is not carrying the current. In which one? Moving iron instrument. Sir, why? I'll tell you clearly when I start the corresponding PMMC and MI elaboratedly. PMMC 2 to 3 hours discussion. MI 2 to 3 hours discussion. Like that, every device I am spending much time to give all the details clearly, but when the time comes, I will discuss. Okay, but as it is related to spring, no, here only I'm giving. Springs are connected with the coil, right? In PMMC, springs are not connected with the coil, in the corresponding MI instrument. Okay, right. Kindly leave these two. I'll tell you later, but as a notice to be when I give it. Spring is made up of, people are asking the material. Kindly kindly give some time to breathe. Here, the spring is made up of phosphorus bronze. Whatever the property, what is it? Spring should have proper contraction, proper expansion. Means spring should be of good elastic in nature. Then only a contraction, expansion will be happened properly. That type of thing is available. Phosphorus bronze or phosphor bronze, we can say. This is ESC paper objective question. For other people, all the people, concept point of view, you have to follow the material also. Spring is made up of phosphor bronze material. Okay, and other than this, here can be suitable for which one here? Both horizontal and vertical positions. Can be suitable for both horizontal and vertical positions. Aging effect, temperature, but these two are not a big problem. Simply effect will be there. That's it. Okay. In the same way, now gravity control method. Everything I'll give you. Have patience, kindly. Gravity control. Sir, what is that? Weights are used to balance the motion of the pointer. Their spring, here weights. Their spring, here weights. That is gravity control method. Right? Okay. These must be placed in vertical directions only. Vertical directions only. Right? Next. This method will give non-linear scales. Why? You take I square, anything, sine inverse of I square, sine inverse of I cube, anything you take, directly non-linear will be there. So that's why this method always give non-linear scale. Next, last point, very important to review. Controlling torque can be only up to 90 degrees. What is that? After this, controlling torque will decrease. Why? The controlling torque is produced with respect to control weight as well as balance weight. It will be divided, so automatically effect will be there. That's why up to 90 only. That's what I told you, like this position is there initially, so final position is up to this only. Suppose if you still continue, control weight is moving against, balance weight is also moving against, so whatever the gravity is happening will be dividing in these two. Therefore, what is the controlling torque will be disturbed. So therefore, up to 90 only. Up to 90 only we have to use. That already explained. I'm giving as a note. Clear? And what is the advantages here? Simple construction and temperature effect is there, but less. There little bit more. Here less, there little bit more. This is the complete construction operation mathematics and advantages, disadvantages, and what is that? Comparison, which is generally preferred. Also, I gave you. Now all your doubts are clarified. People type that some material, some advantages, everything. People ask, no, yes, this is what the complete discussion. Clear, guys? Right? So this is a total discussion regarding controlling torque. Right. Just now I told you, sir, how the controlling torque is decreased after 90. Just now, within just 1 minute back only I told you. 1 minute back only I told you. Kindly concentrate. Lakshmi Kiran, kindly have minimum common sense to type the message again and again and again. Don't make me to say these statements in the class, kindly. Right? Okay. Now, see, I'm repeating this point. This is the starting position. This is the final position. After 90, both are moving against the gravity. Therefore, whatever the gravitational force is there acting on both means divided into two things in the structure, automatically the control weight is keep on getting decreased. That is the reason why up to 90 only we will operate the corresponding structure. Up to 90 only will operate the corresponding structure. Right? See, almost 540 people are listening the class clearly, step by step they're understanding. But only 4 to 5 people are continuously typing. That's why I'm mentioning sometimes. Other people, yes, good, very good. Asking the good question, relevant doubts only, very good. But be clear, guys. Before going to the damping torque, very important question, important topic here is concentrate. Sir, so far we have taken supply is given. Kindly look at me. Supply is given. Effect is induced. TD is produced. Concentrate, yes. TD is produced. Pointer is moving. Spindle is rotating. Springs are disturbed. Therefore, opposing force is produced. Opposing force is built up gradually and both are becoming equal. The pointer will be stopped at one place. That is what spring control method operation when the supply is given. Okay, coming to the gravity. Sir, supply is given, right? Effect is induced. TD is produced. Sir, once the TD is produced in this direction, the control weight has to move against the gravity. Control weight has to move against the gravity. Once any body is moving against the gravity, we'll get the gravitational force. That is opposite to the main body movement. That's why opposing force, controlling force. And as the body is keep on getting moving like this, gravitational force will be built up. So automatically both will be equal. Then correspondingly pointer will be stopped. This is the universal explanation. Again, I have repeated. Okay, right. Now, the point here is, sir, you explained only when the supply is given, what is the operation you explained. But, sir, when the supply is switched off, what will happen? When the supply is switched off, what will happen? Don't get confused. Don't get deviated for 2 minutes. Very important conclusion. See, instrument must be completed only when supply is given and supply is switched off. Both the things must be studied. Supply is given over. Now the supply is switched off. Sir, I switched off the supply. Supply is switched off. Sir, supply is switched off immediately in your laboratory. What did you observe? Pointer has reached back to zero. Okay. But my question is, don't answer, I'll answer. Don't answer. Kindly concentrate. Sir, when the supply is switched off, the pointer comes back to zero position due to TD absent or due to TC present. Don't answer, I'll answer. Just I'm asking the question. Here, once the supply is switched off, pointer is coming back to zero position. I'm coming again. When the supply is switched off, pointer is coming back to zero position due to the presence of TC or absence of TD? That I'm asking. That I'm asking. Srinivas Kunta, I told you not to respond. I will explain. I will explain. Be clear. Sir, absence of TD or presence of TD? Absence of TD or presence of TC? That's what the question. Both I have not given as the option. Both are not given as the option. Be clear. Many people, if I ask the question, many people undoubtedly say that, sir, supply is off. Effect will be zero. Effect is zero. TD is zero. If TD is zero, pointer has to come back like this. But be clear. Be clear. Based on the you are missing small physics here. So TD is zero. Okay. TD is zero. Okay. But the pointer is not coming back to zero because of absence of TD. No, the pointer is coming back to zero because of TC presence. Sir, how? Simple logic. Simple logic. Here, sir, the moment TD is zero, the moment TD is zero, what we can say, which is zero? Whatever the force which is disturbing the springs, which disturb the springs so far is becoming zero. I'm coming again. Try to understand the terminology. Terminology is very important. So supply is off, effect is off, TD is zero. TD is zero, which is zero. Try to understand. Whatever the force which is disturbed the springs so far is zero. So once the applied force on the springs is zero, automatically springs will be trying to go back to their equilibrium original position or not. Yes, that's why springs will be acting in the reverse way compared to the earlier operation. Therefore, as the springs are operating reversely, for example, here, as you said, I'm taking two things like the two are same. So as a supply is given, these two are contracted so far operation is done. Now what happened? Once the supply is switched off, TD is zero. Once the TD is zero, on the springs, contracted force is zero means the springs will be expanded. The springs will be trying to expand back. Means what is my point? The springs will be trying to go back to their original position. That is the reason why. That is the reason why the corresponding entire system, spindle and pointer, moving back to zero, moving back to zero. That's why once the supply is switched off, automatically the pointer comes back to zero due to the presence of TC, not due to the absence of TD. In order to move like this, it has to experience some force. Which force? Whatever the stored energy is there in the springs, that will be released now. Therefore, the pointer is coming back to zero position. But don't say, sir, TD, so far TD is moved. Okay, TD moved that one, but TD is zero. It will not come back to zero. Why? In order to come back to zero, it should have some force. Otherwise, it will not come. That's why that force is from springs. Means springs are trying to go back to its original equilibrium position. Yes, pointer is coming back to zero position. One thing. In order to understand this furthermore, I'm giving you, sir, springs are not there. Springs are damaged, something. Damaged. Sir, I have given the supply. Concentrate. I have given the supply. If I have given the supply, springs are not there. What happens there? Supply is given, effect is there, TD is produced, but springs are not there. If springs are not there, the spindle is free to rotate, no opposing force. Therefore, pointer is going, and pointer reaches to full scale value. Already told you. If opposing force is not there, pointer is going, and finally reaching to full scale value. Wrong operation. Okay. Sir, once the pointer reaches to full scale value, when the springs are absent, for example, okay, pointer is at full scale value. Okay, leave it. Now, switch off the supply. Sir, if I switch off the supply, pointer comes back to zero or will stay back there only. Pointer comes back to zero or will stay back there only means will stay back there only. Why? Means so far only this side of force is there. Okay, pointer has stopped over there. Now I am removing this force. But it has to come back to zero means in this direction, force must be exerted by this. Definitely. But In this, springs are not there. If springs are not there, can we say that springs are trying to go back? Springs itself is not there. That's why as the spring force is not there, what we can say here, simply pointer will be staying back there only. There only where? Full scale value only. Clear? This is the complete operation. Few people asked also, sir, supply, if supply is switched off, what will happen? I will explain everything. Kindly wait. So this is what the complete explanation related to what is a deflecting torque. Deflecting torque is very simple. Controlling torque somewhat lengthy. What is it? Spring control and gravity control method. Elaboratedly, construction, operation, mathematics, advantage and disadvantage. Finally, comparison, everything is been taken. Clear, guys? So this is the total discussion. And I have written all the points also. All the points also. Clear? Right. Finally, before going to take the numerical questions and all, right, people's general doubt is, sir, how the scale is designed. How the scale is designed, that is called as calibration. Calibration. How means, I told you in the starting topic of today only. What is it? The point is, sir, in order to design these devices, reference will be taken from which one? Yeah, primary. Reference will be taken from primary standards where manufacturing industries. What they do from this primary standard, they will take 2 amperes current. Okay, they will give that. Pointer was here. The pointer is stopped over here. It is given as 2. Okay, they will take 3 amperes as the known standard value. They will give that. Pointer will be stopped over here. 3. Okay, they will take 4 amperes. Yes, pointer will be 4. 5 amperes, for example, 5, one like that. That is called as, what is it here? Designing. That is called as calibration of the device. I told you indirectly. I told you, now I'm giving the direct explanation. What is it? By taking the reference from the primary standard, that is national level laboratories, they will take 1 ampere, they will apply. It will be stopping over here. Okay, this is a scale 1. And 2, like this, we are going to design the corresponding. But don't worry, in my entire measurement, total subject, I'll be taking two to three times, especially to talk about the corresponding scale designing separately. No need to worry. But I explained everything, but it will be repeated. It will be repeated continuously. No need to worry at all. Clear? I hope it is clear, because elaboratedly, clearly I have explained everything. But one thing you have to understand as a student, of course, as a student generally, that what is it? Enthusiasm, feeling, belief, that is common. I'm not pointing out you for that. But see, after the class, I'm requesting everyone to come prepared. To come prepared. Every day I'm saying this. Of course, almost 95% people are doing that, I hope. But only few people, right? The point here is, see, after the class, after the session, you need to practice the entire thing what was taken by the faculty as it is. Don't think like, okay, I attended the class, I understood, okay, happy, but don't leave it and don't go to other questions and all. No, what you have to do here, same thing, same concept what I have written, same mathematics what I have taken, same numericals what I have taken. Prepare those only. Again, after that, you will get the 100% subject. Yes or no? If I explain now, it will be clear. Yes, people are saying that, yes, okay. Few people are saying small doubt. I'm clarifying. After that, you are saying yes, but that is not final yes. That is only 80% yes only. You should say 100% yes, means after the class, all the things must be studied as it is. First, notebook, what are the things I have written? What are the questions I have solved? Follow that. After that, take extra questions and all. Clear? Right? Now, let us do some questions on this. Just one question on this topic. Right. Srinaya, thank you so much. Try to understand like this, right? The thing will be there. You can rock in any exam, ESC or GATE or etc. Any exam related to my measurement subject will not be clear if you follow me. But intentionally, you may be feeling like this also, that openly I'm saying, sir is getting irritated. I'm not getting irritated. Intentionally, I'm pinching you. Intentionally pinching you, not all, only 2-3 people. If I don't pinch now, this habit will be continued of disturbing the faculty. You will face the problem. My intention is you should not face the problem in future. That's why intentionally I'm saying that, listen first, go back, like that. Intentionally I'm saying, but that is not to everyone, only for that particular candidate. He can understand. Who wanted to disturb me, he can understand, or she can understand. Other people, don't worry at all. Kindly follow me, things will be clear. Okay. And people are asking, sir, tell me about you. Tell me about you. I will tell you. So many things are there. We need to have the journey. Electrical measurements is there. Electronic measurements is also there. Yes, lengthy journey is it. I'll tell you. No need to worry. Right? Right. These type of questions are present in the GATE as well as ESC prelims. These are present. Right? Okay, now I'll solve this. Just give me the final answer. That's it. So here, what is the given data first? Deflection torque of an ammeter varies as a square of the current passing through it. Square of the current passing through it. So that's why I told you, explanation purpose I have taken TD proportional to I. It may be I square also. Yes, question is given like that. Yes, what is that? TD proportional to I square. He only mentioned. Okay, leave it. Sir, 5 amperes of current produces 90 degrees. 3 amperes of current produces dash degree. That's what he's asking. Okay, but when the instrument is spring controlled as well as gravity controlled, so that I'm making 2 columns here. Sir, one is spring, see I'm writing S6 spring control, and here GC gravity control. Sir, in the spring control, what is the TC formula? TC proportional to theta. Here, TC proportional to sine theta. Okay. After that, sir, at final position, TC is equal to TD. TC is equal to TD. Sir, what is the spring control TC? Theta. In this question, what is TD? I square. So what we can write now? Theta 2 by theta 1 is equal to I2 square by I1 square. Okay, now here, sir, TC is sine theta proportional. TD in the question is I square. So therefore, what we can write? Sine theta 2 by sine theta 1 is equal to I2 square by I1 square. Now, at least substitute all the values, find out theta 2, find out theta 2 in 2 cases. Aishwarya Venkatesh, kindly check it here. Right. Pragati, Abhijit, and Saumitri, Prasad, right, correct. Gurudatta Behera, correct. Angle he has given degree means you should keep it in degree only. No need to ask that. No need to get confused. Kindly, Shreya, don't worry. He has given degree, no, here. Yeah, you need to keep in degree only. Few people give the 250 degree. No. Right. I'm giving the answer. In this, the answer here is 32.4 degree. Theta 2. Here, theta 2 in this is theta 2 is, what is that? 21.1 degree. These two are the answers in this question. Simple mathematics only. Yes, very good, very good. Yeah, almost everyone has given the correct answer. 160 to 250 people are giving different answer. Very good, very good. Okay, I'm not mentioning your name, but almost all are correct only, but only 1 or 2 people give the wrong answer. Just calculation mistake. Check it. Okay, now I'm giving the homework question. Repeat the previous question. Repeat the previous question with TD proportional to I. This is a homework question. Yes, yes, everyone correct only. I gave the answers. No need to worry. No need to. Right, I'm saying that this is the homework question. Repeat the previous question with TD proportional to I. Right, this is the total discussion regarding spring and gravity control. I hope you are having some visualization like how the pointer is moving and what are the torques and all. Don't worry, after this I'm going to start PMMC. There I'll be showing some video also what I made already in the academy. No need to worry. Now let us go for damping torque. The third topic is damping torque. And I told you definition. So what is a damping torque? Here, simple logic. What is that? Without damping torque, the pointer makes oscillation with respect to final value. Means if 4 is given 4, at 4, it will be oscillating. 5 is given at 5, it will be oscillating. Yes or no? So therefore, the point here is without damping torque, the pointer makes oscillations with respect to final value. Therefore, damping torque is required to eliminate these oscillations. This only I gave you already. Okay, right. See, gravity control, people are asking, sir, please calculate. Already have calculated and I gave the answer 21.1 degree. I gave the answer. This is correct only. Okay, right, sir. Damping torque is also again provided by 3 methods in this. Very simple method. One is air friction damping and fluid friction damping, eddy current damping. 3 methods are there. Air friction, fluid friction, eddy current damping. 3 dampings are available. 3 damping torque methods are available. Simple that. All the definition I gave you, I'm giving the note completely and types of methods: air friction, fluid friction, and what is it? Eddy current damping torque method. Pallavi, see, each and every point I'm writing and noting down everything like this. So no need to worry about, sir, give some time to write the important every point I'm writing, every point I'm noting down. No need to worry about to take the notes in the classroom because we made PDF sending procedure now. Yes, that's why kindly try to habituate it. Okay, each and every point I'm explaining, but only the thing is different types of explanations. I'm not writing so and so etc., but each and every note I'm giving, don't worry, don't get tensed at all. You're missing something like that. No, you are not missing anything. Everyone don't feel, right? Okay, now what is air friction? But before going to that, very important point is very important point. Otherwise you'll get confused. 100% guarantee you'll get confused. Concentrate, sir. When we are talking about the damping torque, where is the pointer position? It is starting at full scale or at final position? Means at final position means if you're talking about the damping torque means supply is already given, deflecting torque is already produced, controlling torque is already produced, both are equal already. Now the pointer is making oscillations. Then we need to talk about the damping torque. Are you getting my point or not? Damping torque should be coming into picture only when the oscillations are taken by the pointer. Oscillations are taken by the pointer only when TC becomes TD. TC becomes TD happened only when TC is produced. TC is produced only when, what is it? Either spring or gravity method. When TD is given. TD is produced when effect is there. Effect is there only when supply. That's why if you're talking about this torque means, what is it? TD already given. TC already given. So that I'm talking about damping torque means the pointer is about its which one final position. But my question is, sir, pointer is at 0, full scale value, right? Supply is not given. Supply is not given. Do you need to worry about the damping torque production in this? Supply is not given. So how the damping torque is there? What the damping torque will do? Do you need to worry here? No. Why? Supply is not given. No effect. No TD. No TD means no movement. No movement means no disturbance in the spring or gravitational position. What is it? Control weight position. And there is no TC. There is no TC means TC equal to TD will not be there. TC equal to TD is not there means oscillations are not there. Oscillations not there means damping torque not there. That's why always, all I told you, supply, TD, TC, then damping torque. This is what the order. This is what the order. Clear? So therefore, we need to provide the damping torque. Okay. If you are not providing the damping torque, what happens here? The pointer will be taking continuous oscillations. It may be died out, but after longest time, it died out. That's why it continuously oscillating. If it is oscillating not like this, only like this, but even if it is oscillating like this, can we take the value properly over there? We cannot take it. That is the reason why. So we need to find out, we need to apply which one here correspondingly answer. Right, we need to provide the damping torque compulsory. Okay, now that damping torque is provided by 3 methods. Air friction means concept of fluid and concept of which one here eddy current. Now still people are asking, sir, what is the cause of oscillations? All I told you here, two equal and opposite forces are acting on the pointer suddenly, where the smoothly moving bearings placed body is moving. It will not get stopped instantly. It will be making oscillations based on the what is it? Frictional concept. So therefore oscillations will be there. Okay. Now air friction damping torque method. Air friction damping torque method. Sir, here, what do you mean by air friction damping torque method? Concentrate here. Very simple. Sir, scale I have taken. Where is the pointer? At a final position. Where is the pointer? At a final position. Okay. Neither 0 nor final. Some position it is there. Okay. Now, what is it here? TD already produced, TC already produced. Now the pointer is trying to make oscillations like this. If it is keep on oscillating, we cannot observe 4 or 4.1 or 4.2 or 3.8. We cannot observe. That's why what we are using. Very simple topic, sir. As it is making oscillations continuously about its final position, right? The pointer is oscillating means spindle also getting oscillated. Clock, anti-clock, anti-clock, anti like that. So therefore, what we do here, we will connect one spindle. We will connect one piston type arrangement. This is the piston. This entire thing is piston. So therefore, sir, as this pointer is getting oscillated, spindle is getting oscillated, thereby this piston tries to come down, tries to go up, tries to come down, tries to go up. So therefore, this entire chamber is enclosed, closed chamber. In the closed chamber, if any object is moving down, up means, suppose if it is coming down, the bottom side air is pressurized. Okay, and if it goes up, this top side air will be pressurized. So therefore, due to the development of pressure, what happens here? This piston gets the force from all the directions. Thereby that pressure will stop the corresponding piston. That pressure will be stopping the piston. If the pressure is stopping the piston, spindle will be, what is it? Static now. Spindle is becoming static. Thereby it is connected now here. Thereby spindle gets stopped. Thereby pointer also gets stopped. So therefore here oscillations of the pointer stopped by what is it? Friction of the air. Pressure developed due to the friction in the air chamber. That's why this effect is called as air friction damping method. That's why I have given here air chamber. Clear? But one universal $1 million question will be there. I will clarify that later after these three topics. Universal conclusion. After giving that only, I will be going to next topic. No need to worry. What is it? Here, sir, you have taken pointer at this position, right? It is oscillating. Spindle is oscillating. Due to the pressure development in the closed chamber, piston will be stopped. Means the chamber purpose is to stop the piston movement. The chamber purpose is to stop the piston movement. Okay. But what people are asking, sir, actually, pointer is at starting. It's starting. The pointer has to move. So as the pointer is moving like this means spindle is rotating like this means the corresponding piston will be moving down. As the corresponding piston is moving down means so pressure will be developed. Yes or no? Therefore, that pressure will stop this piston, no sir. If the piston is stopped, the pointer should not move, no sir. I'll tell you what is that. That's why I told you already. Start from the position where the pointer is making oscillations. Where the pointer is making oscillations. That is what I'm explaining in English only. Don't question the same statement. Sir, is this force to stop the oscillations? What is the statement here? What is the damping torque statement? Here. Without damping torque, the pointer makes oscillations with respect to the final value. Damping torque is required to eliminate these oscillations. What is it? Yes, whatever the force is produced, that is, we are calling that as damping force to stop the oscillation. Thereby, what is it? Piston will be stopped, spindle will be stopped, the pointer will be stopped over there. So this is the stopping of pointer or elimination of oscillations of the pointer due to the friction of air. That's why that is called as air friction damping torque method. Clear? Okay. Advantages, drawbacks, everything I'll give you. But let me take here fluid friction damping first. Let me take fluid friction damping torque first. Right? Fluid friction damping. Sir, in this fluid friction damping torque, very simple. Yeah. Here, this is one type of arrangement made like this. This type of arrangement is made like this. This is the disc, or we can say piston. This is a disc or piston. Okay, sir. Right. See, our topic is damping torque. Let me explain the damping torque first. Okay, right, sir. This is the instrument spindle. Spindle, right? So this pointer, everything is common, but I'm not showing all those. So pointer and everything is common. What is that? Pointer is making oscillations. As the pointer is making oscillations, what happened here? The spring will be, the spindle will be getting oscillated. The spindle will be getting oscillated. As the spindle is getting oscillated, what happened, due to the oscillations of the spindle, whatever the piston we made like this, whatever the piston is attached there, that will be getting oscillated. But this piston is already placed in the piston or piston disc arrangement like that, placed in the high viscous material, that is damping oil, we can say nothing but grease. I hope everyone knows about grease type of structure. High friction, or sorry, high viscous materials will be placed. High viscous means what? Oil type content, or we can say grease type of content. Now tell me, if grease is placed over here, does the grease allow any object to move freely like in the water? In the water, we can move freely like this, but can we move with the same freeness in the grease type of arrangement, etc.? No. Why? Grease means almost, what is it? High viscous material. That's why. What is it here? Due to this entire viscosity, this viscous oil, viscous material tries to stop the oscillations. Therefore, it will be fixed. Spindle will be fixed automatically. Corresponding pointer is also stopping its oscillation. Therefore, here also, sir, oscillations will be stopped by friction of the fluid. That's why it is called as fluid friction damping. Okay, right. Next. Here also same thing, same question. Sir, why only you're talking about this? Why not this? I already told you, I will explain that later. I will explain that later. Our duty is to stop the oscillations. Oscillations are not there throughout the journey. Oscillations are there, which one? Yeah, about its final position. All I told you, pointer is moving, PD is there, opposing force is there, pointer is getting oscillated, where at this position, that position may be 4, 5, 6, according to our given value. So that's why, in order to stop those oscillations, automatically, what is it here? We need to produce some force, that is force by the air friction damping method. Second one, fluid method, fluid friction damping method. Okay, right. Now let us compare these two. So among these two, right, I'm going to air friction damping method. So air friction damping method is simply clean system. By air is the medium, air is the material, so automatically clean system, not dirty, not etc. Because it is not the oil content, air content, clean. Next, less cost. Definitely air corresponding structure means correspondingly less cost, less maintenance means always cleaning etc. not required because air content, less maintenance. Finally, sir, as it is the air type of chamber, can be placed horizontally only, vertically only, or horizontally vertical means anything. Why? It is an enclosed chamber, so that it can be placed in either horizontal or vertical, no problem. That's why suitable for both horizontal and vertical positions. Suitable for both horizontal and vertical positions. This is about which one? Air friction. Now I'm taking fluid friction. Sir, what is this fluid friction? Sir, automatically system is not clean because oil type of content, viscosity materials itself is oil grease type of contents, so therefore not clean, automatically not clean. That means more maintenance. Plus here, suitable only for vertical positions, suitable only for vertical positions. Why? People are asking, sir, why not horizontal and vertical? Why only vertical? Means two things are there. This is the oil content, this is the complete thing is oil content, nothing but grease type of content. Okay, first placed horizontally, again moving to vertical. Suppose again I'm changing to horizontal, like that. If you are using it for both, what happen, as you're moving horizontal position to vertical position, what is it? This is not the solid, this is what the liquid type content, but fluid, we can say. Fluid means not perfectly solid. Therefore, as you are keep on carrying the device or horizontal, vertical, like that, you're saying inside this entire tank, what are here? That oil will be getting shaked like this. Due to that oil disturbance, automatically piston will be getting oscillated, spindle will be oscillated, pointer will be more oscillated. But our intention is not to increase oscillation. Our intention is to, what is it? Reduce the oscillation. That's why it is always wall mounted or vertically mounted or panel board mounted, we can say. Once those are fixed onto the wall as it is, therefore there is no shift in the, there is no movement in the oil, there is no extra disturbances at all. That's why very important point is, what is it? Panel board mounted. That's why these are suitable only for vertical positions, not for both. Horizontal and vertical means what should be required? Horizontal and vertical means what should be required here? The material should not disturb the main operation. But here, this is the oil content type of material, disturb the main operation. So that we don't prefer this for horizontal. Okay, now with respect to these two, now kindly answer which is highly preferred. Yeah, that's what I'm talking. Which is highly preferred? Anurag M. Kashyap, always you are typing before my explanation. I don't want to say many number of times. Okay, right. Now answer my question. Which is highly preferred? Obviously, air friction only, because all are advantages only. Okay, right. Air friction damping torque, right? So therefore, order of preference. What is it here? Air greater than fluid. What does it mean? Air friction damping torque method is more preferred than the fluid friction damping torque method. Okay. Second question is, sir, among these two, second question, among these two, which is more effective, means which is more strong or which is better which is giving better results, or we can say accurate like that, which is more effective, which is more effective, obviously without any second thought, obviously which in here fluid friction, not oil friction here, fluid friction. Why means air, the space between the molecules of air is more, that much tight force will not be there. But fluid means the space between the molecules is less, so therefore tight force will be there. That simple physics concept, not my measurement. Based on that, what we can write here, fluid is greater than air. Fluid is greater than air. Very good, very good. Finally, you give, everyone give the correct answer. Okay, so this is the total discussion regarding which one, air friction damping torque method, advantages and corresponding drawbacks, and fluid friction damping torque method and corresponding conclusion. Okay, both are good, but one is effective and one is more preferred. According to our requirement, we can use it. Now the third method is, very, 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 very important, purely related to the electrical concept, purely related to the electrical concept. What is that? Eddy current damping torque method. Eddy current, very simple. Sir, where is the pointer? See, don't try to research in the classroom kindly. Research should be after doing the MTech, not in the classroom of any subject. Okay, right, eddy current damping. Sir, eddy current. See, one thing I would like to ask you one thing here. Suppose in your mission subject, one second. Here, see, machine is like this. This is rotor. Okay, rotor. If I show some other way, this is stator, this is rotor, like this. By the concept, you should visualize. Sir, visualize by drawing that, visualize by drawing this. Come on, yeah. If you are facing the problem in my topic, that is a very simple topic, how can you understand the electrical machine subject? That is very much difficult to visualize. Means the moment you close your eyes, the in front of your eyes, what is it here? The machine should rotate. In that way, you need to visualize. You need to visualize, right? If you are unable to visualize the fluid friction, if you're unable to visualize this, how can you visualize your machine's topic here? Very, very difficult. People are asking, sir, simply this is what the thing. 0 full scale value in this TD, in this TC. Here TC is equal to TD, right? Pointer is oscillating, spindle is oscillating like this, and piston is oscillating. Due to the high viscous material, what happens, sir? It will be stopped. Right. I have explained air friction damping torque method 2 to 3 times and fluid friction damping torque method 2 to 3 times. I hope it is clear now. Right. Now I'm going to the corresponding eddy current damping torque method. Very, very simple. Sir, eddy current damping torque method, right? Where should be the pointer? At any one position. Don't say middle or center, etc. Anyone. Sir, TD already produced. TC already produced. Here, TC is equal to TD. TC is equal to TD. Therefore, what is it here? Pointer is getting oscillated. Pointer is getting oscillated. Okay, very, very, very important. So pointer is getting oscillated. Sir, the spindle gets oscillated. The spindle gets oscillated. But be clear. To this entire spindle, vertical one, vertical, this rod I give you. To this spindle, we are going to keep one aluminum disc like this. One aluminum disc. Sir, how to visualize this? Concentrate, sir. Simply take one CD. I don't know whether you have seen CD or not. See CD, because nowadays pen drive is very popular. That's why CD or DVD. Okay, like this will be there. No, yes. Take one pen, right? Insert that CD like this. Pen is our spindle in this case. Whatever the CD is there, that is our aluminum disc. In that way, the corresponding CD will be placed like this. CD will be placed like this. Nothing but aluminum disc will be placed like this. Okay. Now, sir, due to the oscillations of the pointer, due to the oscillations of the pointer, spindle gets oscillated, aluminum disc also gets oscillated. Definitely, spindle is oscillating, aluminum disc also oscillating. Now, this aluminum disc is placed such that it is cutting some magnetic field. Nothing but that entire aluminum disc is designed and manufactured such that, suppose this aluminum disc, there's like this magnet will be there. Means it is keep on getting oscillated like this. Means it is cutting the flux lines. So therefore, concentrate here. Due to the oscillations of the disc, the flux lines will be cut. Due to the flux lines are cutting, what happens, sir? According to Faraday's law, what will be induced here? EMF will be induced. Which one here? EMF will be induced. Which one? I'm coming again. Due to the oscillation, means oscillating force is the main origin of our topic. Due to these oscillations, spindle gets oscillated. Aluminum disc gets oscillated. Due to these oscillations, the aluminum disc is cutting the flux lines. Therefore, EMF will be induced. Okay. Sir, which type of EMF? One second. What is that EMF called and everything I'm giving? Sir, EMF will be induced. EMF will be induced at which point? At which point or on which plate? Means aluminum disc only. The corresponding EMF will be induced. On the aluminum disc, EMF is induced. Okay, why? Simple logic. Whenever a conductor, which is a conductor? Aluminum disc. Otherwise, I will write here. This disc is, which one here? Aluminum disc. Okay. And as the aluminum disc is cutting the flux lines, what is it here? EMF will be induced. Where? On the disc. Therefore, the first step, EMF will be induced. But, sir, this is the EMF induced on the disc type structure, plate type structure, and we can say core type structure. We can say core. Why it is core? It will be coming later. It is a core type structure. So that's why if any EMF is induced on the core material, that is called as eddy EMF. Electrical people already know about this. Instrumentation people in the transducers, I told you eddy current. So everyone knows this eddy current basic principle already. That's why I'm repeating. Eddy current or eddy EMFs are the values produced or induced on the core type structures or plate type structures. Core type structures are plate type structures. So therefore, EMF eddy is induced. Sir, wherever and whenever EMF is there, definitely it will produce its own current. Yes, which will be produced? Eddy current will be produced. Eddy current. Now, sir, on the aluminum disc, current is there. Which current? Eddy current. Is or not? Now, can we say that, sir? Now the aluminum disc becomes current carrying disc. Now the aluminum disc becomes current carrying disc. Sir, whenever a current carrying disc placed in the magnetic field experiences a mechanical force, isn't it? Therefore, this current carrying disc placed already in the magnetic field. So therefore, force will be produced. Which force? Mechanical force. Now here, $1 million question and 100% confusion. Sir, our duty is not to increase the oscillations. Our duty is to reduce the oscillations. But you are saying that, sir, whenever a current carrying aluminum disc is there, that is cutting the corresponding flux. So therefore, what is it? Current carrying conductor placed in the magnetic field experiences a mechanical force. So that force will be increasing the oscillations. No, that force will be reducing the oscillations. How? Means after this force will be reducing the oscillations. How? Means very important point. Concentrate. Complete note I'm giving. Sir, EMF is induced based on which principle? Faraday's law of electromagnetic induction. Faraday's law of electromagnetic induction, which is there, first EMF is induced. Wherever the EMF is there, current will be produced normally. Okay. Sir, current carrying conductor placed in the magnetic field experiences a mechanical force. Which law? Lorentz force equation. Lorentz force principle. Lorentz force principle. Okay, sir. After that, finally, sir, on the aluminum disc now, two forces are there. One is main force. One is finally produced force due to the eddy current. Sir, in one system, two similar parameters are there. One is the cause and one is the resultant. One is the cause and one is resultant. According to Lenz's law, whatever the force produced on the aluminum disc, that will be opposing this oscillating force. That's why what is it here? Correspondingly, what is it here? It will be opposing. So therefore, which law? Lenz's law. Clear? So therefore, on this, whatever the force is produced, that force is opposing the main oscillating force because of Lenz's law. What is Lenz's law? The resultant should always oppose the main cause producing it. Yes, main cause is oscillating force only. Therefore, oscillations will be stopped over there, nullified over there. Clear? Right. Now, I'm coming again. Concentrate. Sir, first, here, kindly look at the screen. I'm repeating. Sir, first, due to the oscillations of the pointer, spindle gets oscillated. Aluminum disc gets oscillated. As the aluminum disc is getting oscillated, flux is being cut by the aluminum conducting disc. EMF is induced due to Faraday's law of electromagnetic induction. Okay. After EMF, after EMF induced on the disc, that is eddy, current will be produced automatically because corresponding resistance will be there for the aluminum disc and current will be there. Sir, now the moment current is produced, the aluminum disc is called as current carrying aluminum disc. Okay. Now, the current carrying aluminum conductor or current carrying conductor placed in the magnetic field experiences a mechanical force. Okay. That is due to Lorentz force equation. Okay. Sir, on the disc, produced force is there. Main oscillating force is also there. That's why this resultant force opposes the main cause producing it. Opposes the main cause, that is oscillating force. So automatically, what is happening here? Yes, this produced force opposes the main oscillating force. Therefore, automatically, oscillating force is reduced, means oscillations will be reduced, nullified, we can say. Finally, we can say Lenz's law acts and opposing that. So simply, what is it? It will be nullifying the corresponding oscillations. In this, there should not be any confusion with mechanical terminology because all terminology is our branch. Of course, IN also. Electrical branch basics. Electrical engineering basics only. I have combined, that's it, and a corresponding operation. Okay. Now tell me, what are the advantages of this? What are the advantages of this? What are the advantages here? Advantages are clean system, of course, current-based, clean system, less maintenance, can be placed horizontally, vertically, anything. So therefore, now tell me, it is also having major advantages clearly. Okay. And here, with all these discussions, now tell me, here I've written here, Fleming's, Lenz's law, etc., etc. I'll come back to that. Sir, here now, where the eddy current damping comes into picture. Here or here or here. That's what the point. Now, first principle is eddy current damping torque is highly preferred even compared to air also, because in the air, that air chamber must be shielded, like that maintenance is required, corresponding pressure must be available in that air chamber. But here supply is given, eddy current is instantly produced. That's why fastest operation. The two very less maintenance compared to air chamber also. That's why, what is it here? Yes, eddy is highly preferred. Okay, which is effective obviously here. What is that? In the air friction, what is it here? Here, what is that? Frictional losses will be there, of course, definitely. In the fluid friction, frictional losses will be there. But here, purely electrical current based principle. Therefore, no frictional loss and or in this current related. That's why which is giving best effective force means automatically those two are mechanical concept. Here, electrical concept. So automatically eddy is highly preferred than the corresponding other two things. Clear? So this is what the complete discussion related to corresponding three damping tasks. But be clear, eddy is highly preferred, highly effective. Air is highly preferred than the fluid, but fluid is more effective than the air. That's why according to our requirement, according to our suitability, we can use any one of the things that will be taken step by step in the instruments later. But before concluding this topic completely, sir, which type of magnet it is? I will give you everything. Don't get confused. Which type of magnet? Will it be permanent magnet or electromagnet is okay? Means it is always permanent magnet only. Survive. Suppose if it is electromagnet, concentrate. If it is electromagnet, magnetism is varied with the electrical supply. As the magnetism is varied, as the magnetic flux is varied, automatically EMF will be varied. Yes or no? Current will be varied. Force will be varied. This force should oppose the main force that will be varied. Therefore, this force may not nullify completely, may nullify completely. We don't have a guarantee. That is the reason why always what we require, constant force we require. For that constant current we require. For that constant EMF we require. For that purpose, which one here? Constant magnetism is required. That's why permanent magnet is used. Which one? Permanent magnet. For which one here? For getting the constant magnetic field that I'm writing here. Permanent magnet is used to have strong and constant magnetic field. Electromagnet means keep on varying. We cannot nullify that perfectly. We cannot nullify that perfectly. That is the reason why you need to understand that which type of magnet means permanent magnet only used. So this is the step-by-step operation of air friction damping torque separately, fluid friction damping torque separately, eddy current damping torque separately, and comparison of these three, and finally taken the corresponding conclusions. Okay, but the very important, very important doubt, important point also is, sir, if the damping torque is already there, if the damping torque is already there, right, sir, how the instrument is operated? Very important here. Concentrate. See, don't miss it here. Whatever the discussion I've taken from 2 o'clock to so far, right, I'm giving conclusion within 2 minutes of time. Simplest shortcut. It's conclusion. What is it? Here instrument is there. Sir, supply is given, some current. Effect is there. Okay. Idea purpose I'm showing some coil means deflecting torque production, and some spring and all controlling torque production. Some damping chamber. Example, air friction, something I'm taking. Okay, right now, sir, already told you in the starting of indicating instrument expansion, damping torque must be provided as small as possible, as large as possible, as means small only by the pointer is making oscillations for small displacement. Therefore, to stop that, small force is sufficient. I told you, no, yes, I'm using that now. What is the people's $1 million question here is, sir, supply is given, effect is there, force is produced. Okay, TD is there. Okay, sir, if you want to move the pointer with the TD, the spindle has to rotate, yes, and piston has to move, but this piston is already placed in the air chamber or fluid chamber or eddy current, something, damping chamber, damping rotation, but damping chamber purpose is to stop the piston. No, if the piston is stopped, what is it? Spindle will be stopped, pointer should stop. Pointer stop means there is no operation, no sir. This is what very important question. That's why be clear. What is the damping force? What is the damping torque? Very small only. That's why at the time of starting, TD will be dominating the damping torque. TD will be dominating the damping torque, and pointer will be moving In that way only, the damping chamber capacity is taken as very, very, very small capacity. Okay. Now, sir, damping torque overcomes the, deflecting torque overcomes the damping torque opposition. Your damping torque effect will be there, but very small. But this is depends on 5, 4, 6, etc. Different cut. That's why deflecting torque dominates the damping torque. Therefore, pointer moves. Now point is, so pointer is moving means springs gets disturbed. Spring gets disturbed means controlling torque is produced. Sir, very, very important conclusion. Sir, it is keep on getting disturbed, keep on getting built up. But now, sir, once it is reaching final position, TC is equal to TD means what is the resultant force on this strictly? Almost zero. That's why oscillations are coming out. Then this damping torque will be dominating to stop the oscillations. Then this damping torque will be dominating. Why? Means that's why I told you damping torque comes into picture only when TC becomes TD. Why? So far in this entire journey, TD is there, some considerable value. TC is the opposite. Okay. The moment it is reaching about its final position, now the damping torque will be into dominating. That's why now this will be stopped. Therefore, its spindle will be stopped. Therefore, pointer will stop. There will not be any oscillation. That's why starting point I told you at any cost, TD comes into picture first. TC comes into picture later, gradually built up. At one moment, both are almost equal. Resultant force will be almost zero. Then damping torque action will be dominating. Then that will be stopping the piston. Either air friction or fluid friction or eddy current, aluminum disc will be stopped. Therefore, the pointer will be stopped over there. That's why I'm repeatedly saying this point means TD always first. Then moment, then TC built up gradually. Finally, once the corresponding oscillations are taking place, at that point only damping torque comes into picture. Very good. Lakshmi Kiran, correct. Clear, guys? Then only it. But don't think like damping chamber will not be there. Damping chamber will be there, but effect will be negligible. In this journey, this effect is negligible. In this journey, the effect is negligible. This effect is dominating when the pointer is coming over here. That's why, what is it? The moment supply is given automatically TD first, TC later, finally damping torque will be coming into picture. This is the complete operation of an indicating instrument. I have spent almost 4 hours of time on this topic because this is very, 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 very crucial role in the coming instruments also. That's why I have taken each and every point clearly step by step. I gave the note also, each and every note I gave you, right? Even after the class, kindly go through all these things compulsory. Clear? Right. And see, very good question. That's why I told you, sir, people are asking, sir, in this permanent magnet is there, this damping magnet does not affect, means all I told you, whatever the damping setup is there, that capacity is negligible. Therefore, this damping setup will not affect the TD much. Small will be there. That is what error. So that's why damping will be having the effect, but not considerable. That's why I told you damping chamber comes into picture only at this time. That is what the thing. Nayan Sanjay Kalkas, it is clear. If TD is very low, yes, I'll come to that. Final damp torque will add mass. Yes, correct. So is damping cause? Definitely. Error will be commonly there. Error. See, TD or TC or damping torque will not be 100% perfect in the practical. If all these are 100%, error analysis chapter need not to take. That's why explanation wise I'm taking, all are working perfectly, but practically drawback. What is it? Error will be, that is what the error. Right. Heat error, every error will be common. I did not say error will be zero. I said operation is proper only. I never said error is zero. Don't think say error will be there. That's why you have taken the earlier chapter before starting the instruments. Right. Manoj Shanmugam. Very good. Now it is clear, sir. Thank you. Thank you. Even after the explanation of these many times, right? Kindly, at least kindly get it clarified. Get it clarified. Right. Okay. Next. So damping will affect only force due to oscillation. Yes, correct. Actually, don't say like that. Damping will affect only force due to oscillations. That is correct. But small effect will be there on the TD, but not considerable, negligible. That's what the thing. Okay, clear, sir. Okay, sir. Yeah. At starting, can we consider damping torque as least small error? That is what? Overall way error will be there. Yes, yes. Paul Varun, I'm very happy. I'm very happy. Your class is becoming interesting day by day. Very happy. Yeah. Yeah. At any cost, you should understand the topic finally. That is what the thing. Right. Aishwarya Vishnu, thank you. Okay, okay, right. Yeah. Yes, aluminum disc. Why means lightweight. Aluminum disc. Why means lightweight is there. Yes. So what is the effect of different types of dampings? All I told you, one is more effective, one is less, one is etc. That is only right. But Govind, because TD equal to TC plus T damping, we should say, but T damping is negligible. That's why we write TD equal to TC only. I'm requesting no need to mention damping. If mention that, no problem, but no need to mention. Okay. Varsha, thank you. Right. Right. Fluid chamber will be opened or closed. If it is opened or closed, it doesn't matter. What is that here? The corresponding oil content should not be moved. Otherwise, what is it? The difference will be there, etc. Right. Srinivas Punta, yes, I'll come to that. That is the next topic. At every value you can take 4, 5, 6, 7, 8, 9, 10. Every value will be operated properly only. Right. See, I will give the break. All I told you, after 2 hours, I told you I started the class at 6:20. So I'll give the break at, sorry, 4:20 I started. No, 6:20 I'll give the break. Kindly in my class, don't message like, not only in my class, to any faculty. Sir, break. If you type like that, faculty will feel like class is not clear. That is a general human being tendency. So kindly. Right. See, graph is not there to understand TD and TC. Right? There is no graph, don't worry. Right. Damping torque never dominates the deflecting torque. If the damping torque dominates the deflecting torque, operation will not be there. Where also I'll tell you. Right. If you stop typing the questions, I can go to the topic. Right. Now, finally, what you are taking, you are missing small thing. I told you the operation, but people are giving that. So temperature will be there. Sir, temperature effect will be there. Damping effect will be there. Error will be there. Without error, we don't have any practical device. But while explanation itself, it is wrongly operating. If I say, you will feel like instrument is waste. No, it is perfectly operating. That is concept. But Practically speaking, yes, due to the effect of damping at in the deflecting torque, small error will be continuously there. That is what the error. That's why all these are errors will be practically present. That is the reason why. That is the reason why we have studied various types of errors. Now in the instrument, due to which concept, due to which parameter errors are there, we are going to study and all. No need to worry. Okay. Now, final point. Before concluding. Yes, Charishma could be right. We can write. Right. TC always opposing the corresponding TD. That's what TC, other name itself is opposing torque. Now, finally, people are asking this question. Very good question. Concentrate. Here, sir, pointer is there here, right? Spring is there. Spring I'm taking generally. And just for showing purpose, I'm showing air chamber like that. It may be fluid, it may be eddy current also. Assume that, sir, damping torque is having X capacity. Okay. People are asking that, sir, where the damping torque dominates the deflecting torque means generally no need to take, but people are asking you, sir, this is 0 to some number 10 is there. 1, 2, 3, 4, like that is there. Suppose I'm giving the supply of 0.0001 ampere, for example, means 0.0001 ampere is very close to 0 here. Isn't it? Means due to this current, how much torque will be produced? How much torque will be produced? Very small. If you are going to very much closer to 0 value, then this TD may not be sufficient to overcome the damping, then the pointer may not be moving. That's why I hope you face this problem in your laboratory. You give the supply, still the pointer is not moving. Sir, why? Means this is one of the chances. Means you might have given very negligibly small current, almost 0 you can say. Okay, that's why I'm taking 0.00001 like that. If you are giving that, due to this current, some torque will be produced. That torque may not compulsory, may not be sufficient to overcome damping torque. Therefore, this damping torque stop the piston. Spindle will be stopped, pointer will be stopped. That's why I told in all the cases, in the linear type of scale instruments, go towards the full scale value. Error will be as low as possible, I told you. And square law scale type of devices, take the middle of the scale to get the lesser rate. But not any instrument operated towards 0, I told you. That's why towards 0, generally we don't operate. If we operate towards 0 like this type of problem may be there, not compulsory, but maybe there. That depends on how much current you are giving. That's why always middle of the scale for square law, towards the full scale for linear scales and all. Right? That is what the corresponding point. So this is a total discussion regarding all types of torques. Right. See, fluid friction is preferred. Then why not gravity control? Good question. So fluid friction is preferred. Why not gravity? You're missing something. In the gravity control method. TD proportional to I. Theta proportional to sine inverse of I. TD proportional to I square. Theta proportional to not I square. Sine square means operation itself is not proper. But fluid, operation wise good. Strong torque, strong damping torque. That's why we prefer fluid only, but not gravity at all. Gravity control at all. Good question. Pratyush Panipur, right? Thank you. What happens to TC when we give full scale value of input? TC will be maximum, yeah. TC will be maximum when we give the full scale value. Right. Sir, if the full scale value is 20 and the input is also 20, then will there be controlling torque? Come on here. Without the controlling torque, we cannot. But you can ask like this also. Sir, without the spring also it goes to full scale. But the full scale value, the maximum disturbance in the spring will be there. The maximum disturbance in the spring means maximum movement will be allowed. Therefore, the pointer will be reaching the full scale value. At the time it tries to make the oscillations, then also whatever the damping provided by the manufacturer stops the oscillations. Damping torque will be there, otherwise it will oscillate even at full scale value. So Janya, clear? Right? Right. See, only one point here. Don't get any question unnecessarily. Right? Gravity control ruled out. We don't prefer. If you want to prefer, even though you want to get these losses, you prefer. That's it. Simple logic. Right? Okay. Now, continuation. Sir, applications. Sir, where we use all these. These are the practical applications. Just take as a note. Eddy current damping torque method used in PMMC and energy meter. We are going to take everything again. Air friction damping torque method used in MI and EMMC. Fluid friction damping torque method is used in electrostatic instrument. These are the practical applications. Practical applications. Clear? Right. See, very good. Jitendra Latwal. See, sir, you told that 180-degree scale is possible, but why do we take means human being convenience? Suppose, good question. Sir, I told you 180 degrees is possible for the spring control method like this. So why not exactly like this? Means actually you need to turn your head like this. Head like this means human being convenience point of view. Only the things will be given. That's why theoretical topic to practical construction related few limitations will be there. That's why your device will be like this. This is the scale. Even though 180 degrees is possible, but 180 means you have to see like this. You have to see like this. So automatically disturb. That's why always convenient to the operator. That's why simply we can show like this. That's nothing more than that. Right? So this is the total discussion. But before starting the other topic and before giving the break, sir, which type of dampings are there? Which type of dampings are there? Sir, you know this also. What is it? 3 types of dampings will be there. General damping introduction I'm giving. Sir, here, this is the position called which position? Final position. Okay. Sir, concentrate here. Pointer is moving. Concentrate. Pointer is moving, reaching the final final position, making oscillations for long time. And this is called as which one here? Under damping nature. Second point. If the pointer is slowly, if you give supply today, it will give the value tomorrow. The very, very lethargic system, lazy system, for example, that is called as over damping. If the pointer is quickly reaching the corresponding final position, that is critical damping. This is everyone knows damping. But my question is, say, 2 questions I'm asking. I will answer. Try to understand, sir. Among these three, which we prefer in our measuring instrument? Which we prefer in our measuring instrument means critical damping, or ideally speaking critical, practically speaking near to critical damping, because we don't want to have any oscillations. Which is not having oscillations. One is critical, one is over. But over damping is very lethargic system. Simple fun way I want to give means is give the supply today, tomorrow come and take the reading. Means very lethargic system. That's why over damping not at all preferred in our measuring instruments. Isn't it? That's why critical damping is preferred. This is what the first point. Second one. Sir, which type of damping is generally, which type of nature of the pointer is dash generally? What is the nature of the pointer generally available practically? Under damping or critical damping? Under damping. Why? The pointer always tries to make oscillations, but our duty as a manufacturer, stop these oscillations to make the pointer to read proper value. That's why indirectly we can say that indirectly we not manually control, it is already manufacturer based control. So that is the reason why, see, I want to give my measuring instrument example only, not your control system example. Control system example approach and everything is different. Measurement pointer movement, sir, pointer is oscillating. Yes, under damping pointer should not oscillate, means critical. So what we require? Under damping to critical damping we require. So that is what oscillations are nullified, stopped by providing the damping torque. Thing is done. That is what the complete thing. Actually, this is not required, but to have the practical system comparison, I'm giving. Now everything is clear because so many people are critical over, under. So many times you have typed, I will explain each and everything. See, this is the 5th day. Still you are not confident on me. Means it's very difficult. I give everything clear. Whatever I give, take it first. Whatever I have not taken at this moment, don't worry, that will be later. Definitely, don't worry. Right? So this is the complete instrument explanation. I'm saying openly, in the textbook generally standard language will be there, even though Sahani or any textbook, what will be there? Okay, supply is given, TD will produce, TC will produce, dampen over. But how? Step by step, explanation I have given. I hope everyone is clear with this. Okay, now let us stop here. Stop means only break. Take the break and come back, and we'll start the instrument PMMCMI and etc. etc. Clear? Right. Take the break and come back. Yes. Welcome back. Right. On this topic, let us take one question. One second. Wait for 1 minute. One second. Can you wait for 2 minutes? Some file has struck. Can you wait, be online? Right. Yeah. That's what happened. Thank you. Right. Try this question. Come on, try this. Right, Pragati, correct. Right. First of all, what is the given data? The PMMC ammeter, the PMMC ammeter A in the adjoining figure has a range of 0 to 3 milliampere. When the switch S1 is opened, the pointer of the ammeter swings to 1 milliampere mark, returns and settles at 0.9 milliampere. Means here, suppose when the switch is closed, if the switch is closed, the current will be flowing. If the switch is closed, the current will be flowing through this only. There is no current flow through the ammeter, right? Okay. Sir, when the switch is opened, means the total current will be flowing through this only. What is given? When the switch S1 is opened, so switch is opened, the pointer of an ammeter swings to 1 milliampere mark, swings to 1 milliampere mark, returns and settles at 0.9 milli. So therefore, what is the first step now? Here. Right here, the pointer will be swinging to 1 milliampere and then returns and settles at which one? 0.9 milliampere. Like this, it is settled. After some time, we don't know. 0.9 milliampere. Now tell me, what is the current flowing in the circuit? One is flowing or 0.8 means here. One is not flowing, 0.8 is flowing. Yes, right. All the people already gave the answer. Very good. Sir, which is the current here? 0.9. Why? One only just it is. Went and again oscillated, come back, and he has given that returns and settles at 0.9 milli. Returns and settles at 0.9 milliampere. Okay, right. So therefore, current in the circuit is 0.9 milliampere. Okay. But this type of nature is going to one, coming back and settling it. 0.9 means under damping or critical damping? Under damping. Therefore, critical, these two are wrong. Under. Okay, but which is correct? Now let us find out the resistance. What is that? V is 1.8 equal to current is 0.9 into 10 power minus 3. Resistance R meter plus 1.8 kilo ohm. So therefore, if you are simplifying this, you'll be getting REM is equal to 200 ohms. That's very, 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 very simple. So therefore, under damping correct, but 100 is given. So finally, under damping 5. Fifth option. What is a 200 ohm? Yes, many people give the D answer correct. So these are the topic related questions in this, right? Okay. Now, sir, next one. Let us take the instruments now. Right? Instruments are connected instruments. Which type of instruments are there here? PMMC, MI, etc. Instruments are there. Okay, right. Now, so far we have taken basics chapter, error analysis chapter, right? Ankuryam Kashyap, you search in the previous question papers. Okay, right. Now, sir, instruments I'm taking. With all the basics of basic measurement first chapter, next error analysis, and then with respect to basics of instruments, all the thing, whatever we have taken so far, with all those discussions, I'm entering into instruments chapter. That is, first I'm going to take PMMC instrument, MI instrument, EMMC instrument, and electrostatic is not specially mentioned, but I will take it. Right? Electrostatic instrument. These are the 4 types of device are there. This is the next chapter. In this chapter, topic by topic I'm taking. But one device, it will be taking 2.5 hours, 3 hours of time only for one device. Construction, operation, mathematics, and then correspondingly conclusions. Everything will be taken one by one. The 2 questions are possible from all these topics. Okay, right. Now, first one. PMMC. What is that? Permanent magnet moving coil instrument. Permanent magnet moving coil instrument, PMMC instrument. Okay, right, sir. What is this PMMC instrument? What are the things available and all I'm giving now? Every time, first I will give you every instrument. First I'll give you which type of torques are to be required. Just now I told you what are the essential torques to be required in the instrument means here deflecting torque TD. Deflecting torque TD. We require definitely. Controlling torque TC. Is it no? And damping torque also we require. Damping torque. Sir, in the PMs, all I told you in the starting, deflecting torque, PMMC, permanent magnet and moving coil, magnetic effect, I told you. So therefore, deflecting torque setup is permanent magnet will be there and one moving coil, but current carrying coil is movable. That type arrangement, PMMC arrangement will be there. Okay, controlling torque. What will be there? Controlling torque. Spring control will be there. Obviously, I told you spring is generally preferred. I told. Next, so damping torque, which one? Just now I told applications. Which one? In the applications, I told you eddy current damping torque is used in PMC. Why means, sir, eddy current damping torque. What we require in the eddy current damping torque? Permanent magnet is required. In the PMMC also, permanent magnet is already there. That's why no problem. So that is the reason why we are going to use which one here? Eddy current damping torque. Eddy I'm writing. Clear? This is a simple introduction. Okay. Now, very important task here is here. Concentrate here. Suppose permanent magnet is there. Okay. Is it strong magnetic field or weak magnetic field? Permanent magnet, strong or weak? Permanent magnetic field, strong or weak? Obviously, strong magnetic field. Everyone knows that. Come on, few people are giving weak. No, yeah. Permanent magnetic field, strong, independent, and constant field. That's always strong only. Yes, one student give that very strong, very good, right? It is not dependent on anything. It is not dependent on anything. It is strong only, not weak at all, not weak at all, not weak at all. Kindly concentrate. The permanent magnet itself is strong, but many people give that weak. Come on here. No, permanent magnet. What is it here? Constant magnetic field. Constant magnetic field and independent magnetic field. Okay, and we can write strong magnetic field. Those who are having the wrong thought on permanent magnet, kindly concentrate. Permanent magnet is the strong magnet, even compared to which one? Electromagnet. But you might have one doubt like this. What is that? Suppose here, so in our machine's point of view, our faculty told that permanent magnet is there. We cannot increase the magnetism. That's why we will go for electromagnetism. But I don't want to increase or decrease. I want to talk about permanent magnet, electromagnet. I don't want to increase or decrease. I don't want to vary. I want to, which one here? Concentrate on which one? Available magnetism, which is strong. So that is the reason why this one, permanent magnetism is strong. But in your machine's point of view, you need to increase the magnetism, but it is not possible here. That's why you go for it. In our measurement, we don't want to increase the magnetism just like machines, etc. So that's why simply we need to talk about constant magnetic field, strong magnetic field, right? It is generally made up of all-nickel material. Aluminum, nickel, cobalt combination, all-nickel material. So this is the thing. Okay, but sir, this is permanent magnet based. Okay. And one more thing also we can write. Constant magnetic field, we can also write unidirectional magnetic field or bidirectional magnetic field. Uni only. So therefore, unidirectional magnetic field. unidirectional. Means if north is there, always north. It will not become south. But in the electromagnetism, suppose if I'm keeping like this, suppose this is plus minus is given, right? Plus is this side, suppose north. This is south, for example. If I reverse this, if I reverse this, automatically north and south, that depends on supply. So therefore, electromagnetism means magnetism based on the electrical supply. But here, permanent magnet means always unidirectional supply. North is there, always north until its lifespan is being completed, until its aging is over. As it will be having north is north only, south is south only. Those are permanent magnets. Okay, sir, as we are using, as our topic itself is related to permanent magnet. So my point here is, sir, as the permanent magnetic field is there in the instrument, this permanent magnetic field is not varying with respect to the supply voltage. Therefore, it is suitable only for DC, suitable also for AC. That's what the very important question. Crucial point also. Permanent magnet moving coil instrument is applicable only for DC, we can say. Only for DC, we can say. Sir, why means people are getting confused? Sir, why not AC and all? Why not AC and all? People are getting confused. So that's why concentrate here. The permanent magnetism does not get varied, does not get varied with respect to the supply variations. Supply variation. Why? Whatever the supply you give, DC you give, AC you give, anything you give. Suppose here permanent magnet is there, right? Coil is there. To this coil DC you give, or to this coil AC you give, this magnetism is always same. But electromagnetism is based on the supply, it gets varied. That's why my question is, so permanent magnetism does not vary with the supply, does not follow the supply variation. That's why it is supply independent magnetic field. So that's why whether we give DC or AC, it is always unidirectional magnet. That's why this is suitable for only DC. Why means even though you are given AC, positive is their cycle, positive of cycle or negative, or positive or negative. It doesn't sense at all. That's why no use of giving that. That is the reason why as the permanent magnetism is independent of the supply variations. This is only for DC, not for AC at all. Only for DC, not for AC at all. So therefore, I'm giving a very important note. Applicable only for DC. Applicable only for DC, not for AC. Applicable only for DC, not for AC, we can say. That's not the point actually. Okay, right. If this is clear, our instrument construction operation very simple, numericals. But how it is, why it is only DC? That is one point. Second thing, sir, it is measuring average value or RMS value? Means it is not at all suitable for AC. Where is the question of RMS? Where is the question of instantaneous, etc.? No, that's why what we can say, that is it always measures it always measures DC only. It always measures DC only, right? It is independent of supply. It is independent of time. It is independent of everything. It has its own magnetic field by design itself. That's why it is called as permanent magnet. The name itself is permanent magnet, right? Now, this is very important topic in my entire PMMC chapter, I can say. Now, kindly let me know, is it clear or not? Is it clear or not? Can you respond? See, if this is clear, I can go to the next topic. Continuation in this only. Kindly let me know. right? Okay. Now, sir, Yugasri, sir, you told for supply both AC and DC. Which one? Which one I told? Yugasri? Supply both for AC, DC. For which one I have taken? Right. I'm repeating this point because this is the crucial point in my entire PMMC. If you understand this simple concept, construction, everything is simple. See, permanent magnetism always same. All I told you, if this is north means north, south means south. Whether you give DC supply or AC supply to the entire circuit arrangement, anything you give north and south, see me, it doesn't get changed. It does not get changed with respect to AC you give or DC you give. That is the reason why. That is the reason why permanent magnetism is independent of the supply variations. Independent of the supply variations. That is the reason why this is not applicable. This is not applicable all for the corresponding AC supplies. Because AC, what is it? Positive and negative means as the AC supply is given based on the current direction, magnetic field should be there. But here it is not there. It is not there. And people are asking, sir, if you neglect the AC direction, can we measure? What is the question? Electrical engineer should not ask Sai Charan Reddy. AC means itself is direction. You are saying that, sir, vector I'm taking, but I'm neglecting the direction. How can you say that? Clear? So that is the reason why be clear with the terminology. This is only for DC, not for AC. The two DC, the two which value it always measures which value? Average value only. Average value only. This is the simple introduction to start my entire subject. This is a simple introduction to start my subject. In my topic, material is not at all the matter. Any permanent magnet you can use. Example I gave you, all nickel. Okay, you don't get question like why not that material? That is your wish. Any material, one of the materials is all nickel. I told you. Clear? Right. Now I'm taking the construction operation, everything. Be clear. Actually, operation already we have taken. What is it? ED first. EC later, and then finally damping torque. That's why in order to understand the working principle of PMMC, MI, EMMC, electrostatic, I have taken TD setup separately, DC setup separately, and damping torque setup separately. Elaboratedly, I spent lot of time. That's why now you will feel this topic will be easy because the thing is same type of operation. Same type of operation. Clear? Right. So it is applicable only for DC, not for AC. If you give AC, what happens? I'll tell you. I'll tell you if you give AC, what happens. But simply DC only preferable. Okay. Lot of discussion is there. Only introduction is this. Okay. Right. Now I'm taking the figure of this one. Kindly concentrate. One second. One second here. This is the figure of permanent magnet moving coil instrument. Right? In this two figures are there. In these two figures are there. Means two different views. This is one view up to this top view and front view like that. Kindly concentrate. In this, what is there? North pole, south pole, permanent magnet. North pole and south pole. You guys kindly wait. I'll show the video. No need to worry. after this topic, because I need to explain the concept. Then I will show the video. No need to worry. Almost 10 to 15 minutes of video, complete step-by-step animated video is I'll tell you. Here, North Pole and South Pole, permanent magnet. Yes. Sir, this is the coil. This is the core. On that core, corresponding coil will be taken here. Okay. And then pivot and corresponding bearings, top and bottom. In the figure, I have shown only top spring, but actually bottom spring also will be there. But it implies top and bottom will be there, but only one place I have shown. Means, okay, spring is there, etc. And sir, this is the pointer and corresponding scale. And I told you, below the scale, what is it? Mirror arrangement. For which purpose here? For avoiding the parallax error. Simple logic, nothing more than this at all. This is what the corresponding one view. If you are looking from other side, sir, this entire thing is permanent magnet. Concentrate here. This entire thing is permanent magnet. Means this and this permanent magnet. And in this, whatever this turns are there, that is spring. And on this only, this outer circle is core. On the core, this box is there, coil. Means the coil is placed like this. The coil is here, moving coil. Clear? After that, pointer and corresponding scale. Both are same instrument only, but different figures and show different pictures. For having the visualization, so far I have not started the instrument, only constructional parts one by one I have taken. Now I'm taking the complete construction part. Okay, fine. For clarity purpose, more and more clarity purpose, I'm taking one more figure also. I'm taking. Like this. Sir, here, this is north magnet. This is south magnet. Okay. Between those two. See, cylindrical type structure, that cylindrical in nothing but aluminum core. Here I have shown this like a box type I have shown, but it is a cylindrical type, but only one of the views I'm showing. Core type structure. On this aluminum, this box is there, this one. That is coil. Means if it is a cylinder, like this, the winding is placed like this. Rectangular position, winding is placed. That only I am showing like this. After that, here I have given this is the spindle, top spring, bottom spring. Top spring and bottom spring. After that, this entire thing, north to south combination, one outer structure like this. One outer structure will be there. Pointer, scale is common. Okay, and I mentioned that this entire thing as the coil, that is moving coil. Okay, right. Different views I'm showing. Now, whatever may be the structure, from now onwards, same principle. That is the reason why I spent a lot, I'm repeatedly saying, I spent a lot of time in the basics of instrument. That is, what is TD, what is TC, etc. Now we are going to combine all the three. So for TD, TC, damping separate. Now we are combining all the three. What is that? Let us see. Sir, anything. Supply is given to the coil. What happens now? The current will be flowing to the coil. Current carrying conductor placed in the magnetic field. Which magnetic field? You see here. This is the coil placed in the magnetic field. Experiences a mechanical force. Therefore, which law? Lorentz force law. Lorentz force law. Or Lorentz force principle, we can say. Okay. Sir, the moment the force is produced, in which direction the force is produced? Don't forget the earlier one. Same thing. What is it? Yes, in this direction, which is there. TD will be there. Okay. Sir, immediately observe this. Sir, three-dimensional picture. The moment it starts rotating, springs whichever we placed, that is it here, getting disturbed. Getting disturbed means automatically, yes, TC will be in this direction. Okay. And the moment the point is reaching over here, the moment your pointer is reaching over here, what is it here? This entire coil is placed on aluminum cylinder, right? The aluminum cylinder is a lightweight cylinder. Aluminum is a lightweight. That is the reason why eddy current damping also told you, like aluminum. Why I'm saying that lightweight? Is no lightweight, very thin material will be used. So therefore, the moment the pointer is coming over here, it is trying to make oscillations, but already aluminum cylinder is getting oscillated. Getting oscillated means what is it here? Flux is linked by the aluminum on the aluminum cylinder. Eddy EMF, eddy current, and force. That force will be stopping this corresponding oscillation. Therefore, the corresponding what is the oscillation will be stopped. Pointer will be stopped. That's why I spent each and every question clarification also I have done in the what is it previous topic. That's why overall principle is very simple. TD add that, TC add that, damping torque add it. One instrument is over. That's what the point. But here one again same question. Already clarified that, but people generally get that out. Sir, aluminum cylinder, aluminum cylinder. Suppose pointer is here. It is moving means as it is moving means aluminum cylinder is rotating. Yes, sir. As the aluminum cylinder is rotating throughout the journey on the aluminum cylinder, eddy EMF will be there, no? Yes. Eddy current will be there, no? Yes. Due to that eddy current, force will be there, no? Yes. That force should opposite eddy? No. Why? I told you, damping torque setup is as small as possible, which is designed by the manufacturer to have the proper concept. That is why, even though aluminum cylinder is continuously rotating, yes, 0, 1, 2, 3, etc., continuously cutting the flux lines, yes, but due to that aluminum dimension and all, cutting flux, a DMF, a D current, everything will be there. But what I told you, at the time of starting and during the journey, at the time of starting and during the journey, TD dominates the damping torque. In that way only, the dimension of aluminum cylinder will be taken by the manufacturer. That's why undoubtedly TD first, TC later, damping torque later, effectively. Same principle. No change, nothing, no change at all. Right? If you come to this view also, same thing, sir. Supply is given, it is getting rotated. If it is getting rotated means yes, TD is produced here. Isn't it? And then springs getting disturbed. Yes, in this TC is being produced. But sir, throughout the journey, suppose pointer is like this. Throughout the journey, aluminum cylinder is also cutting the flux lines. Aluminum cylinder is nothing but eddy EMF. Eddy EMF means eddy current. But that eddy current damping force or torque will not be sufficient to stop the or oppose the deflecting torque at the time of starting or during running. When will it be coming into picture? When will it be coming into picture means when the pointer reaches about its final steady state position, TD and TC both are almost equal, then damping torque effectively comes into picture. That's the point. This is the total construction operation. Clear? Right. If it is clear, I'll be taking the mathematics. What is that? Deflecting torque. Right. In the 2 days back class, I told you PMMC instrument has the linear scale. I told you. Many people ask that, sir, how? Many people ask that. Yes. Now I'm going to show the corresponding entire mathematics. So what is it? First of all, sir, it works on which principle? Lorentz force principle. Okay, right? Lorentz force. What is the force formula according to Lorentz? What is it? F is equal to BIL sine theta. Generally, sine theta assumed to be 90 to get the maximum force. In that way only, the corresponding force will be taken. Otherwise, technically what we can say, no, radial magnetic field will be there. Radial means 90 degrees notation. So automatically sine theta only take. No one should get the question afterwards. So why sine theta is not being taken means in our entire thing, the designed such that the theta will be 90 degrees notation. That's not the point. Okay. But my question is, sir, this is the formula for one conductor or multiple conductors means for one conductor only. That's why force per conductor. But in our case, how many will be there here? One complete ton, second ton, third ton, fourth ton, fifth ton, like that. Okay, so therefore, if I want to get the total force, total deflecting force, what I'm getting here, BIL into N I'm taking. Why? Total number of tons in the coil, what we used in this structure is N number of tons. Earlier only one conductor, but N number of tons means total coil you are taking. This is the total force produced. Yes, I'm writing so many Newton. Okay, right. Let me take one by one. Sir, we don't want the linear force. We want the angular force, that is torque. So therefore, what we can say, torque is equal to force into perpendicular distance. Force into perpendicular distance. Our subject is measurement, so deflecting and making no problem. Okay. So what is force? B-I-L into N. But sir, what is a perpendicular distance? Sir, simple logic. Length of the conductor, sorry, length of the conductor L I have taken. What is the perpendicular distance to the length of the conductor? Breadth of the conductor. That only I have shown here clearly in this. One is length, one is breadth. Why means on the cylindrical structure. On the cylindrical structure, how do you place the winding? Which shape? Rectangular shape of the coil only. So therefore, what is that here? Length of the coil is L and width of the coil is what is it here? Simply B I'm taking breadth or width as you wish. So therefore, B I N into length into breadth of the coil. So simply TD is equal to B I N into A. B I N into A. Clear area of the coil. So many Newton meter. This is the torque formula based on these questions were there. We are going to see. And sir, therefore, TD is equal to B I N into A. B I N into A. Okay, sir. In this, for a designed instrument, area of cross section of the coil we cannot change. Number of tons of the coil we cannot change. Yes or no? After designing. Sir, what about the B? Flux density is constant or variable? Flux density is constant or variable? Come on. Come on. Flux density is constant or variable? Constant. Why? Permanent magnet. So therefore constant. Now tell me, therefore TD is proportional to I. Now tell me, is TD proportional to I by assumption we have got it, or by the complete constructional operation base we have taken here? Yes, very good. Constant. Okay. So therefore, TD proportional to I, conceptual based only we are taking. Okay, right. After that, which type of controlling we used? Spring control we used. Spring control. Okay, right. So what is spring control? TC proportional to theta, or TC is equal to Kc into theta. We have taken already the spring control method. Now, sir, at final position, TC is equal to TD. Already we have taken. What is TC? Theta equal. Otherwise, TC equal to formula, that is right. Kc into theta. What is TD? Bin into A. Okay. Therefore, theta is equal to Bin into A by Kc. Bin into A by Kc. Okay, right. Now again, sir, A is constant, N is constant, B is constant, Kc also constant for a designed instrument. Therefore, finally, theta proportional to I. Now tell me, linear or non-linear? Linear. Uniform or non-uniform? Uniform scale. This only in the starting error analysis chapter. Linear scale, y proportional to x. Linear scale, PMMC. I told you. Why PMMC linear? This was the complete discussion. Each and everything, step by step mathematics, everything I've taken. Right? And still people are asking, sir, why theta is 90? The instrument is designed such that, whatever the PMMC instruments are there in the practical world with you in your college or anywhere. All those are designed with radial magnetic field only, radial force only. Automatically, theta will be 90. I am not making any assumption. The practical constructions, what is it? Criteria itself is sine theta equal to 1. That one I have taken. Yes. Now tell me, PMMC instrument is linear by assumption or by the constructional operation? Means by constructional operation only, not by assumption at all. Not at all by assumption. It is by constructional operation only. Right? So this is a total discussion regarding from basic point to slowly corresponding constructional figures and then mathematics. Clear, guys? Right. Now, sir, in this, let me take one small simple question. Let me take one simple question here. Just I'm giving the data directly. Just data directly I'm giving. B means breadth. No need to mention this. That implies length into breadth area. Length into breadth area. B is breadth of coil. L is length of coil. Right? Now, so a PMMC has right here. One second. Not like that. A 0 to 10 ampere PMMC is connected to a 0 to 10 ampere PMMC is connected to 4 amperes AC 50 hertz sine wave. 50 said sine supply, sinusoidal supply. Right? Then the pointer dash. Then the pointer dash. This is the question. For idea purpose, I'm giving options like, sir, simply, if AC is given, what is it here? Sinusoidal supply. So positive half cycle will be there, negative half cycle will be there. Okay. Only current is reversed, but flux value is not reversed. So therefore, sir, TD is equal to, what is it? B into I into N into A. Okay. N and A, dimensional parameters, leave it. Sir, here AC is given. AC, positive half cycle, negative half cycle. Positive will be there, negative will be there, AC current. That is what? Our supply. But permanent magnet always constant, always positive, means always positive field only. So therefore, sir, B always, suppose I'm taking always positive, for example. Always positive. Sir, during the positive half cycle, positive current, positive flux density. What is the torque? Positive. So therefore, torque will be in this direction. Okay. The moment negative half cycle comes, what is it? B is always positive, but current is negative. Negative into positive, negative. The torque will be like this. How much time? How much time means based on the corresponding supply time. So therefore, what we can say, it is making oscillations. It is making us by for positive half cycle tries to move in this direction. For negative half cycle tries to move in this direction. Therefore, with this concept, simply we can say, okay, pointer is not continuously moving in the forward. Pointer is making oscillation. That's what the simple point. Clear. Now I'm giving the options. Okay, so many people already gave the answer. Okay, right. Sir, what is it? Means options. Only half explanation only I gave you to give the question. Only half of the explanation. What is it? Pointer is, yes, oscillating. Okay, but option oscillates around 0, oscillates around 4 because I have given 4 amperes supply rate, oscillates around 10, Next, oscillates between 0 to 4, 4 to 0, 0 to 4, 4 to 0, like that. Oscillates 0 to 10, 10 to 0, like this. Oscillates 4 to 10, 10 to 4. 6 options I'm giving. No one should answer. I will answer. I will answer. Just I'm giving 6 options. Okay, many people give the correct answer. First thing, sir, we don't know anything regarding this. If you don't know anything properly, come in the reverse way. Try to eliminate the options. What is that? Sir, how much supply is given? After all, 4 amperes. Sir, if we are giving 4 amperes, is there any possible to have? Is there any possible to have the pointer going beyond 4 up to 10? Beyond 4 means 4.1, 4.2 oscillate. That is okay. But 4 to 10, is it possible here? Never. So that's why which options we can remove blindly? Here, 4 to 10, 10 to 4, not at all possible. Because 4 is given going up to 10. So therefore not possible. Next, 0 to 10, 10 to 0 also not possible. Yes or no? Next, oscillations around 10 also not possible. Okay, now the doubt with oscillates around 0, around 4, 0 to 4, 4 to 0. Okay, right, sir. One more concept. Sir, what we have taken in the earlier discussions, TD is proper, TC is proper, then the pointer goes to, what is it, final value and get oscillated. TD is proper, TC is proper, then the pointer goes to final value and gets oscillated. But here, TD itself is not proper. TD itself is not proper. Listen, why? TD trying to move immediately backward, immediately forward, backward means TD itself is not proper. If the TD itself is not proper, how can it go? How can it go up to 4 and oscillated? No. So therefore, yes, 4 is also possible when the TD is healthy, TC is healthy, etc. TD itself is not healthy. Yes, not possible. Now people are getting stuck up with 0 to 4, 4 to 0, 1, around 0, 0 to 4, 4 to 0, around 0. Here, very, very important. Finally, we end up with 2 options. Okay, sir, which is correct? Means simple logic, sir. What is the supply frequency? 50 hertz supply. Okay, time period T is equal to 1 by F. 1 by 50 means 20 millisecond. Okay, sir, this 20 millisecond, 10 milli and 10 milli will be there. 10 milli and 10 milli will be there. Yes, and now the question is, sir, the current is changing its direction 10 milliseconds of time means, sir, first 10 milliseconds forward torque is produced. Means like this, in this direction. But the moment the pointer tries to move, come on here, will not move. The moment the pointer tries to move, what happens here? Negative half cycle will come. Negative half cycle will come. The moment negative half cycle is coming, what is it? Backward means forward. Torque is forward, but pointer will not move forward here. Why? The pointer has its own inertia. Pointer has its own dead time and dead zone. Pointer has its own weight. Of course, light weight only, but it has some weight. That's why pointer tries to move, but by the time negative half cycle will come, immediately it will come back to, it will tries to move back. Again, tries to move forward, tries to move back, tries to move forward, forward, back, etc. Therefore, pointer tries to oscillates around 0 only. It will not go up to 4 also. Why? In order to go from 0 to 4 means the forward torque should appear for some time, but no, forward, backward, forward, back. Why? 10 milliampere means very, very fastest time. So that's why, what's the answer here? The pointer, what we can say? The pointer oscillates around 0. Pointer oscillates around 0. That is, sir, pointer oscillates around 0 with how much time? With how much time here? Pointer is oscillating around 0 with how much time? 10 milli, 10 milli, 10 milli. With our human being eye, can we observe that oscillations here? No, that's why what we say, oscillates around 0, that is reads 0. That's what the ultimate point, reads 0. This is what the answer. Now, sir, if AC is given, pointer is showing 0, okay. But be careful, be careful. Sir, which type of AC we have given? This type of AC we have given. Yes or no? Why? 4 amperes sinusoidal 50 hertz supply. This one. Sir, what is the average value of this? What is average value? 0. What is the value shown? 0. That's why what you have to say, PMMC reads always average. Whether you give DC or AC, PMMC reads average value only. But immediately one question comes, sir, AC is given to PMMC. It is showing average value. Why did you say AC it is not applicable? Means, come on guys, AC means we don't want to measure average. We want to measure RMS value. Because AC voltage means RMS. AC current means RMS only. I hope everyone knows this electrical basic. Suppose if I say 230 volt AC is there, means undoubtedly this is RMS value only. But in this case, which is measured here? Average value. That is the reason why. What you have to say here? Yes, it is oscillating around 0, reads 0. That is also we can say, what is it here? Reads average value. Reads average value only. Check it. So average value of given sine wave is 0. A shown value is also 0. Automatically, yes, PMMC always suitable only for DC. Means PMMC here PMMC reads 0. PMMC reads average value. Okay. Srinivas Kunta. Student is asking us. That is, student is asking that, sir, PMMC not applicable for AC. Why? How it is oscillating? That only I told you. Not applicable for AC means all I told you. AC should not be even. I did not say what I told you. It is not applicable for AC. Means what is it here? AC means RMS value we require, but it is unable to measure RMS value. It is measuring average only. But AC means what we expect as a practical operator. That is the meaning of it is not applicable for AC. I told you in the first point also what I gave you, applicable only for DC. That is always measures average value only. It means okay, RMS value it is not measured. That it is not measuring the RMS value. That is what the complete discussion regarding PMMC basics and introduction and construction, operation, and with numerical question, how the PMMC reads always average value. Always average. That's what the point. Right. Valupalli Srikanth. Why permanent magnet is given with not given with supply? Why do you give supply to permanent magnet? Come on, come on. Come on here. Why do you give permanent supply to permanent? The permanent magnet moving coil instrument itself is permanent magnet current coil carrying coil. Then only this is called as PMMC. Don't change its own basic point. When the device is called as PMMC means permanent magnet moving coil separately given with supply. Then only that is called as PMMC. Right? Anil Kumar, operation clear ga cheppandi sir. Once again, I have explained the operation TD almost 10 times. TC controlling torque, that is spring and gravity, almost 10 times I explained. Damping torque also almost 10 times I explained. Combine all those three. Combine all those three. That will be equal to PMMC operation. If you want to repeat, yes, I'm repeating. Supply is given. Supply is given to the coil. Which one? Magnetic field. Current carrying conductor placed in the magnetic field. I told, now also I told while explaining mathematics. Current carrying conductor placed in the magnetic field experiences a magnetic, what is that? Mechanical force, TD. Then springs are getting disturbed, TC. Slowly moving and moving and moving. At one point, it gets oscillated. Then damping into picture. That's why I told you before starting only. I told you I spent lot of time because to understand these instruments within short time, easily to understand. That is what the thing. Clear? I'll tell you. I will tell you. This is what the main. Okay, I don't want to answer those questions. Right. See, don't do this. Don't say that, sir. If you want to measure the AC, we want to change the B. How can you change the B when the permanent magnet is there? No, that's why in your statement, small correct one is, if you want to measure the AC, the magnetism must be time varying magnetism. That is electromagnetism. That is there we are going to study in the moving iron instrument. Very good, good statement, but small modification. Balakrishnan, correct. Right. Right. See, if it is a rectangular structure, if length is this, breadth is this, I hope everyone knows that simple common idea. Yes, perpendicular distance is breadth only. But people are asking, sir, can you explain once why the breadth is taken as perpendicular? Come on here. For the length, what is the breadth? Perpendicular distance only. For that purpose only I gave you. I told you already, length and breadth. Length and breadth. One thing you require, one thing you have to understand, if network failure, if you were chit-chatting with your family members, etc., after doing that, don't come back and don't ask the doubt. Video is there available to you. Kindly go and watch after the class. Those who are listening without missing even a single minute, if they don't understand, they can ask me. I'm openly saying, right? If any network problem is there, kindly we are placing the recorded videos, you go for it, no problem, right? Right. Sir, as both the fields are constant, then how the cylinder is moving? Bhavani, which fields are constant? Which fields are constant? Means if it is a DC machine, DC supply, means DC motor should not rotate according to your statement. What is it here? Motion is required when, motion is possible when current carrying conductor placed in the magnetic field automatically, yes, correspondingly we can get the motion. That's it. Clear? Right. So this is the total discussion regarding which one here? Correspondingly, PMMC instrument construction, operation, everything. Now, people are asking, I will explain here. I will explain. I'm keep on saying that Chandan Chetri, almost 3-4 times you typed this message. If you don't want to attend the class, don't attend. Okay, I'm openly saying, not only you, 2-3 people also. Right? Right. I gave the question for 50 hits. Did I speak anything regarding other frequencies? Let me explain them. 2-3 times I ignored, but you 2-3 times you are messaging. Because of you people, I'm missing the sincere students messages, sincere student questions I'm missing because of you people. Okay. Even if you feel bad, I don't mind. I don't mind. Right. So kindly concentrate. Continuously I'm saying that let me explain. Still, if that is there, this is there, etc., whatever the thing I'm explaining, first take that. See, I am not here to impress you. I am here to give the subject to you. Even if you feel bad about me, even if you give negative things about me, I don't mind. My subject should be clear to you. That is what my motto. Yes or no? Okay, I should not speak with the students. They will give bad feedback about me. I don't mind. My intention is to give the subject to you. Yes or no? Though I'm not here to impress you. Yes, you are good, beta. Yes, continue, beta. No, I'm not here to misguide you. I'm not here to impress you. I'm not here to deviate you. I'm here to only to give the subject clearly in the understanding way, in the more and more easy way. But because of you type of 1 or 2 people, I don't want to miss other best students, sincere students. I'm not talking talented, sincere students. I don't want to miss those questions. That's why if any time you are typing one question, just leave it. If I'm not answering, ignore it. I will answer later. Otherwise, irrelevant question. You think of it continuously. So does it mean that it will oscillate for low frequency AC? Almost 2-3 times I have seen this message. and people are worrying about, so class is up to 9 or etc. See, kindly, Naresh Nayak, if you are not interested, you can leave now only. You have that facility, right? Simply, red color button is there, close the session and leave it. Before joining the session, kindly see the time. What is the time and all I told you, don't ask about the breaks and time with the faculty. Faculty will get deviated. Faculty will get demotivated. You will be the loser. Ultimately, I don't be loser. You will be the loser. If the faculty gets demotivated, students will be the loser. Students will be the loser. Clear? Right. So therefore, what is the point here? If the AC supply is given, I'm coming again, I'm repeating. Even though I'm saying like this, I'll repeat. Right? See, if AC supply is given, clearly I told that for positive half cycle, what happens here? Pointer moves, pointer tries to move forward. For negative half cycle, pointer tries to come back because B is constant. B is constant because of permanent. N into A, physical dimensions. I is positive, positive into positive, forward torque. Negative into positive, backward, forward, backward, forward, backward, forward, backward. Automatically, pointer oscillates only around zero. Not even point one or point two also will move. It is, that's why oscillates around zero. That is, it reads zero, reads average value. Why? The given sinusoidal waveform average value is zero. That's why the PMMC reads average value only. Right? Aniket Uttam Patil, yes. Right, thank you. Right, see, one more example. See, examples related. No need to worry. English, I'm saying, don't worry about the examples. I'm here to give as many as. हिंदी में बोल रहा हूं मैं, एग्जाम्पल के बारे में मत सोचिए. Yes, many number of questions. Tension मत लीजिए. Telugu, right? I'm saying that మీరు అసలు ఏం టెన్షన్ పడదు. ఎన్ని నెంబర్ ఆఫ్ క్వశ్చన్స్, అన్ని నెంబర్ ఆఫ్ క్వశ్చన్స్ ఇస్తాను నేను. బట్ లెట్ మీ ఎక్స్ప్లెయిన్ ఫస్ట్. Clear? So this is the total thing. Whoever told that, sir, why it is not measuring AC, I'm not clear. I have repeated this because I'm repeating again, because positive half cycle, positive into positive, positive torque. Negative half cycle, negative into positive, negative. So therefore, forward, negative, forward, negative, forward. Means supply is on, but forward, backward, forward, backward, forward, backward. Automatically, it will be showing zero only. When I have taken 50 hertz frequency, I have taken. Now I am taking the next case. I will explain everything. I am taking the next case. What is that? Suppose, sir, if frequency is 1 hertz, time period is 1 second. Time period is 1 second. Okay. So time period is 1 second means 0.5 second, 0.5 second. Now concentrate, guys. Concentrate. This is fourth, fifth time I'm repeating. Those who are not clear still, I'm explaining. Kindly concentrate. Sir, for first 0.5 seconds, forward torque is there. Okay. For negative 0.5 second, definitely backward torque only there. Why? The deflecting torque itself is not proper. What I mean that deflecting torque always in this direction only. Then TC will produce. But here, deflecting torque itself is not proper. Why? Forward, backward, forward, backward, forward, backward means not the proper torque yet produced. Okay, right. Now, sir, if we compare this question with this other question, earlier question is what? F equal to 50 hertz. Time period is, what is that? 20 millisecond. 20 millisecond. So therefore, what is it? 10 milli and 10 milli. Sir, compared to 10 milli, 0.5 second is somewhat bigger time. That's why in this case, the pointer goes to some point. The pointer goes to some point and come back to zero. But which point? We cannot answer as an operator. We cannot answer. Experimentally, we can prove it. So and so. But operators, we cannot know. That's why it goes to some point. After that, this will come. It will come back. Why means 0.5 second means 0.5 second is somewhat larger time. That's why the meter pointer, the time constant is in terms of millisecond only. But this 0.5 second, no. Yes, it will be overcoming its inertia, moving to 0.5, 0.6, 0.7, 0.1 or 1, etc. Some scale. And by the time negative cycle come back to zero. That's why 0 to anywhere 0 to 1, 0 to 1.5, 0 to 2, like that. We cannot say some value it go and come back to 0, but still oscillations only. But here we can observe the oscillations from 0 to 1, for example, 0 to 1.5, like that. We can observe the oscillation. Still, it is not measuring the proper value at all. Actually speaking, our supply frequency 50 only, but to get more clarity, I'm taking 1 hertz frequency. One more also I'm giving for more clarity. Sir, if f is equal to 0.1 hertz, right? Time period equal to 10 seconds, very large. What is that? 5 second and 5 second ultimately large. 5 second is less for the human being, but 5 second is for the electrical operated devices, large time. Okay, which one? 4 ampere supply is given. Now, definitely confidently we can say 0, 4, 10 is there. No, this 5 seconds is large time. That's why the pointer goes to 4 and come back to 0. It will not stay there. Goes to 4, come back to 0. With 5 seconds, goes to there, next 5 seconds, coming back to 0. Goes to 4, coming back to 0. Goes to 4 and coming back to 0. But still oscillations only. That's why PMMC, if AC is given, what is that? Not does not measure the value properly. Oscillating means we cannot give the answer properly. That's what. Example purpose, India supply frequency 50 I have taken is around 0 oscillating. So blindly we can say average value 0 is measured. This is what the complete explanation. Yes, I'm taking the total discrete again and again and again. I repeat it. Clear? Vashishta, thank you. Aniket, thank you. Right. Okay. Right. Now, people eagerly see. I know here. Actually, I'm saying that don't ask the irrelevant questions. I'm saying that, but generally, student means like that will be there. But that is not the good habit. I'm saying. At least try to change. Try to change. Generally, student means if one thing is clear, immediately they will asking about the second one. I kindly wait. I will explain. Now, I'm taking one more question, sir. Here, suppose I of t is equal to 8 plus 6 root 2 sine 314t amperes is given to PMMC instrument. Or PMMC simply. Find its reading. No one should give the answer. If you give the answer, you will miss my simple logic. Very best example, best way of thing I'm going to explain now. Yes, okay. Mangesh, okay. Right, sir. Right. Sir, here, what is it? Very simple, yeah. This is the combination of 8 DC content, 6 root 2 sine 314t AC content, sinusoidal content. Okay, right, sir. Here, very simple. PMMC reads average value. Already told you. Any supply you give 50 hertz frequency only. Other frequencies generally questions will not be asked. But for clarity purpose, I have taken 1 hertz, 0.1 hertz, etc. But generally 50 hertz only all the theories are built up. Therefore, average value. Okay, sir. What is its average value? I hope every electrical and IN engineers know that average value of this is 8 amperes. Okay, over. But actually, what happens conceptually, I'm explaining. Concentrate. Sir, this is some 0 to some number full scale value. Okay, to this device, here somewhere 8 is there something. To this device, which is given here, 8 plus 6 root 2 sine 314t is given. Sir, 8 unidirectional, no change. So therefore, related to 8 amperes, which is there here, forward torque is produced because 8 always constant. No positive, negative, no time variations and all. So therefore, positive. It is going up to which one? 8. Concentrate, guys. After reaching the 8, due to this AC supply, positive, negative, positive, negative, positive, negative. Therefore, it tries to oscillate around 8 because of AC supply. Why? AC means forward, So positive cycle, negative. Positive cycle, negative means what is it? Forward, backward, forward, backward. But what I told you, we cannot observe these oscillations with our human being eye because 50 hertz, 10 milliseconds of positive, negative. That's why it oscillates around 8. But what we should say, it reads 8 only. That's what the actual thing. With this, some more clarification I have given. That's why step by step, I'll be giving clarifications. This is the complete information regarding PMMC construction, PMMC operation, PMMC mathematical discussion, and corresponding numerical question. Thereby, PMMC reads always average value only proof, and with that proof, one more numerical question. This is the complete discussion. Complete discussion. Right. Very many people give the answer 8. But by which thought you were given? PMMC it's average. I know average. Okay, that is okay. But this concept is required to you. Means it goes from 0 to particular value wherever the constant value is there. After that, it gets oscillated continuously. Right. So practically we cannot give here. Practically we cannot give, but numerical question only. Govind Vikas correct. No. Practically, we won't give here. If we give all this analysis here, examination pattern itself is analysis. Simple logic here. If we go to the 10th floor and if we jump, what happens? That is only theoretical. Do we do practically? Are you getting my point? If you do jump from the 10th floor, legs will be broken. Theoretical only. Do you want to prove it? Or come on, no. That's what. What are the things are there? If we give like that, if we give this one like that, all the theoretical explanations only. Practically, how can you give? How can you combine AC and DC supplies? No. But generally, if that is there, what happens? Analysis we are taking because see, this is there. That is okay, but this is there also. What happens? This is also there. What happens? Like that, all the discussion we have to take. Right? For understanding, but the fun example I give you, at least by that you can understand that. Okay. Right. Yeah. Okay. Right. This is what the total discussion regarding PMMC instrument construction operation and so on, so on. All clear. Right. Before going to the next topic and corresponding next questions and all, I am going to show video. But before starting what I'm saying in that video, in that entire PMMC Express video, audio is not, it will not be audible to you because the sound problem was there. I have taken that. So don't worry, I will explain. I will give the audio, no need to worry. Okay, right. Kindly wait for 1 minute. I will be bringing that. One second. Audio is very low. Kindly concentrate. Right. So far, what I have told here is, right? Am I audible, right? Okay. So far, what I have told here is, we have taken construction, operation, and all, right? And now we are going to take the corresponding, what is it? Animation video with respect to the PMMC complete picture. PMMC complete picture I'm taking now. Clear? One second. One second. Right? Okay. Now, See, this is PMMC. North and south poles. And whatever this circular structure is there, that is aluminum cylinder. And this one is there, no? This is rectangular coil. Length is there, breadth is there. And whatever the red color one is there, that is spring. And this is pointer, this is scale of the coil supply. This overall thing, but one by one part I'll be showing. If audio is not clear, all I told you, don't worry, I'm giving my voice. No need to worry. Permanent magnets. Nothing but the coil is placed on the moving body. This entire thing is aluminum cylinder. The coil is placed on the moving body, I told you. Okay, right. Nice. Elaborately, I'm showing. By looking at this, don't think like permanent magnets are moving here. No, to explain, I have separated, but people are asking after the class, if I show this video, sir, permanent magnets are moving. Come on, no, yeah. I have opened the entire structure. I'm showing each and every part. But north and south, permanent magnet is fixed only. Fixed only. Aluminium core, lightweight structure. On that correspondingly, coil is placed. This I'm showing separately. Rectangular shape. Have you observed? Length into width, length into breadth. Audio is not there. All I told you, don't worry, don't worry. I'm giving my voice, no need to worry. Right. What I explain, rectangular coil, right? That is having so many number of turns, 1, 2, 3, 4, etc. So many number of turns. Okay. Right. It will be rotating like this. It will be rotating like this. But up to which point it will be rotated here? This entire coil or moving set will be rotated up to TC built up equal to TD. But in this I have shown 360 degrees. But no, here until TC becomes TD only it will be rotating. But it is moving object I have shown. Right. See, whatever this red color one in that red color one center, one steel type white color part is that is completely from bottom to top. We can say spindle that will be in the center, but I'm not showing. Spindle will be there. On that spindle, top one spring, bottom one spring. One is top and one is bottom spring. Okay. Pointer is attached to that spindle. Pointer is attached. Means the entire pointer and spindle all are connected together, and the pointer is moving over a designed scale that is called as graduated scale, we can say. scale. That is a scale. Coil, springs, everything I'm showing. Spring. Yes. I'm placing into that. Right. Every setup is set up, right? After that, you know how the force is produced. Just I'm explaining Fleming's left hand rule and all. That is simply machine's topic. No need to worry. Lorentz force equation based force is produced. I explained. Right. This is a supply. Completely coming over here. Scale. See. Pointer will be moving over the scale, I'm saying. All I told you, audio is not there properly, right? Don't say that audio is not there again. Already told you, right? Switch, supply is given. Right. Switched on. Current is flowing. Actually, only one direction, but I have shown two. One is forward path, one is return path like that, but I have shown wire current. The moment supply is passing through the coil, what happened? You know, just see. See, flux lines are north to south already there, right? Then current carrying conductor placed in the magnetic field experiences a mechanical force, right? Yes, it will be moving now. Yes, flux lines. Torque is produced. What is that? Current carrying conductor when placed in the magnetic field. What is force is produced? Torque is produced. Right. See, observe the pointer how it is moving. Up to which point it will movements until spring force equal to TD. But I have shown full scale value movement just for clarity purpose. What I'm saying is, after giving the some current, according to some current, the pointer will be stopped in between. But here, only full scale value for clarity purpose I'm showing. That's it. So this is the simple idea. Just only for idea purpose I have shown. Right. Let us come back. I don't know how many have understood that. See, voice is not there, all I told you, but still people are saying that, sir, voice is not there, check it, check it. Only for your clarity purpose, how the movements are there, how the things are happening, for that purpose only I have shown actually. Actually, while I'm playing the video, voice is not clear actually. This is placed in our deep learn platform. Deep learn means mobile phone recorded videos are there in our AC Academy. In that, I made these type of videos. So I thought to show for you people also, online live class people also. That's why I brought it and I gave it. And people are asking that, sir, send the link. Actually, that link will not be even given to the faculty. That is only shared one is there. I am playing that. So it will not be given. So don't worry. Right? Only for ID purpose means why I have given this entire thing means at least you can understand, what is the movement, how it is operating. Visualization purpose only I have taken this. I hope it is at least somewhat clear. Right. Right. People are asking, if you are that much keen, we cannot do. Sir, in the video, the coil is not looking like rectangle, it's looking like square. Means change your position like this or like this. It will look like rectangular only. Right. So this is the total discussion regarding PMMC. Just I thought to show some video. I hope it is clear. Okay, now come back. Sir, PMMC instrument, I'm giving the conclusion here in this introduction part. PMMC instrument is for which one here? DC only. If we give AC, what happens, sir? Pointer will oscillate. Where it will oscillate? Based on the given supply. If only pure sine wave is given, yes, it will oscillate around 0. Suppose sine wave with some constant magnitude is given, it will go to corresponding value mathematically, conceptually. Clear? Right. One more thing here. Sir, in the PMMC, let me take sensitivity topic. In the PMMC, let me take sensitivity topic. Yeah, even square is also rectangle, so I cannot comment on this. That student. Clear? Right. Now I'm taking the sensitivity topic. In the PMMC, sensitivity will be large or small and all. I'm taking now. Right. Okay. Now, sir, what is sensitivity? Sir, sensitivity means what is that? Delta output by delta input. Delta output by delta input. That is sensitivity. Sir, in the PMMC, let us take now in the PMMC. One second. Right. In the PMMC, what is the torque formula and all? See, theta is equal to BIN into A by KC. Okay, right, sir. In the PMMC, what is the output we have seen here? Pointer deflection only. So delta theta. What is the input current? So delta I. That is it. Supply is given based on the corresponding magnetic field. Pointer has been rotated or pointer has been moved. We can say therefore delta theta by I or approximately theta by I also. We can say no problem. Therefore, sir, theta by I is equal to what is that? B N A by KC. Sir, be clear guys, small confusion. Sir, A is constant, N is constant, K is, of course, B is also constant, but I'm giving in terms of, sir, theta by I proportional to B. Sir, B is strong or weak? B is strong by permanent magnetism. This is strong magnetic field. So therefore, what we can write now, it implies, what is it? Sensitivity equal to theta by I proportional to B means sensitivity proportional to flux density in the corresponding PMMC instrument. That too, flux density is strong or weak? Flux density is definitely strong only. Why? What is it? Permanent magnet is there. That is the reason why, yes, this is strong. That's why what we can say, as the strong magnetic flux is there, as the strong magnetism is there, so automatically what we can say, yes, sensitivity is high. sensitivity is high, we can say. Clear? So that is what the corresponding point here. So what is it now? The PMMC instrument has high sensitivity or low sensitivity, means high sensitivity only. Therefore, we can write here as the magnetism is strong, as the magnetism is strong, right? The sensitivity is high. That's why PMMC instrument, what is that? Linear scale, one advantage. One more thing is here high sensitivity is, this also one more advantage. This is also one more advantage. Clear? Right. So this is the total discussion for today's session. Only PMMC construction operation base we have taken. But after that, how do we extend it? How the connection is there? I told you, coil and spring connection. How it is there, I'll show you. I'll show you in the next class, tomorrow class. No problem. I'm stopping now. Let us have the doubt session. I'm requesting to repeat the entire topic. Don't ask me to repeat the entire topic. People are asking like that. Kindly try to understand. Yeah, that's what. Srinath, as sir, you told that springs are carrying the current. No, yes, I'll show that construction connection tomorrow. Right? Only just one idea purpose only. I'll be taking that. Right. Srinivas Kunta, sir, how eddy current damping is produced? Right? Same thing, eddy current damping, whatever we have taken over here. Same way. Here, this is aluminum cylinder. Take this as aluminum cylinder. This is permanent magnet. What is happening? Aluminum cylinder is there. I give the figures also. See, aluminum cylinder is oscillating. Oscillating means the flux is cutting the aluminum cylinder. Therefore, on the aluminum cylinder, eddy EMF, eddy current, thereby force. That force is eddy current force, stopping the oscillation. Same concept what you have taken in the eddy current method. Same thing here also. That's it. Vishnupriya, sir, can you please explain how we got 32.4 degree in problem? Come on, yeah. This one. 1 second. Yes, I'm going to that. 1 second. That calculation here, I'm not getting that part. Actually, this paper has struck something happened. Okay. See, what is I gave you? 5 amperes, 90 degrees. 3 amperes, how much? 32 points. Simple. Come on here. Here, theta 2 by theta 1 is equal to I2 square by I1 square. This is spring control method. What is theta 2? Theta 1 is 90 into I2 square 9 by 25. Vishnupriya, clear? If you simplify this, you will get 32.4. Manoj Shanmugam, thank you. Bhavani, what's your question? Show the AC with constant and pure sine wave in waveform, sir. That only I have taken here. See, constant and pure sine wave. This is given to PMMC. Positive cycle is there. negative of cycle is there, current is positive, current is negative. That only explain. B into I into N into A. B is not changing. Let me take positive. I told you. In the positive cycle, what is it? Positive into positive. Torque is forward. Here, what is it? Positive into negative current. Torque is backward. That only I told you. Forward, backward, it will be there. Yeah. It is actually square. I have given the square question. I have given that square question. Right. Good question. Sir, Sanjay Kalaskar. Sir, as the permanent magnet is used, damping torque is high, so it will affect the TD. No, because damping torque not only on the permanent magnet, aluminum strength also. What I told you, aluminum structure is designed such that as small as possible damping torque. See, strong means not very higher. Suppose if I'm taking air friction, fluid friction, what is it? Eddy current, is no, which is strong in nature. Eddy, it doesn't mean that very high. It will oppose, it will affect the TD. Not like that. Aluminum strength also depending. So that's why based on the aluminum strength, always take it for granted here. Damping torque or air or fluid or eddy, small magnitude only to stop the oscillation. But if you compare those two, if you compare those three, eddy is strong, but don't take it is very high like that. Clear? Right. Aluminum core is also getting rotated with the corresponding thing. Then only the flux cutting and everything will be there. But in the video, it is looking like constant, but it is rotating actually.
Sir?
Yeah, tell me.
Sir, TC equal to TD అన్నది అన్ని కేసెస్ లో ఈక్వల్ ఉంటది కదా సార్. అంటే పిఎంఎంసి లో గానీ
ఏ ఇన్స్ట్రుమెంట్ అందుకనే ఏ ఇన్స్ట్రుమెంట్ అయినా సరే ఇన్స్ట్రుమెంట్ స్టార్ట్ చేసే ముందే టీసీ అంటే సింపుల్ లాజిక్ అమ్మా. మీరు ఫైనల్ పొజిషన్ లో పాయింటర్ ఆగిపోవాలి అంటే టీసీ ఈక్వల్ టీడీ అయితేనే ఆగుతుంది. అంతే కదా.
సార్ క్వశ్చన్ లో మనకి ఎలా తెలుస్తుంది సార్? అంటే పాయింటర్ డిఫ్లెక్షన్ అవుతుందా లేదా అని ఎట్లా తెలుసుకుంటున్నారు సార్?
అర్థం కాలేదు, మళ్ళీ అడగండి.
అంటే మీరు ఇంతకుముందు ప్రీవియస్ క్వశ్చన్స్ లో చెప్పారు కదా సార్, పాయింటర్ అనేది ఇట్లా డిఫ్లెక్ట్ అవుతుంది, 0 to 4 అనేది కాదు, 0 దగ్గరనే డిఫ్లెక్టింగ్ అవుతుంది వెనకకి ముందుకు అని చెప్పారు కదా సార్.
అవును.
అది ఎలా తెలుసుకున్నారు సార్?
యాక్చువల్గా ఓకే, గుడ్ క్వశ్చన్. అది ఎక్స్పెరిమెంటల్ ప్రూవ్డ్ అమ్మా. మీ కాన్సెప్ట్ అర్థం అవడానికి మనము చూస్తున్నట్టు చూపించాను. బట్ ఏంటంటే మన సప్లై ఇవ్వగానే 0 దగ్గరనే అయిపోయి ఉంటుంది, అది మనకు అసలు కనిపించదు. బట్ కాన్సెప్ట్ ద్వారా ఏంటంటే ఇది మనం చూడడానికి 0 లాగానే ఉంటుంది, అంటే 0 చూపిస్తుంది. బట్ కాన్సెప్ట్ ఏంటంటే స్టడీ స్టేట్ 0లో ఉండదు, కొంచెం ఆసిలేషన్ వస్తాయి. కాన్సెప్ట్ బట్టి చెప్తారు, బట్ మనం అబ్జర్వ్ చేయలేము. అది అంటే ఏంటంటే సింపుల్ లాజిక్ అమ్మా. ఇప్పుడు మీకు మన ఏసీ సప్లై ఉంది, ఇలా ఉంది కదా, మనం తీసుకుంటూ పాజిటివ్ నెగిటివ్ తీసుకుంటాము, కానీ పాజిటివ్ నెగిటివ్ కనిపిస్తుందా మనకి? యుగశ్రీ అంటే అది సింపుల్. అంటే ఏంటంటే పాయింటర్ ఆసిలేట్స్ అరౌండ్ 0 అంటాం. ఏంటంటే కాన్సెప్ట్ బట్టి చెప్పేస్తాము, అర్థమైందా? అని చెప్తే మనము ఆపరేటర్ గా ఉన్నప్పుడు దాని ఆసిలేషన్స్ అబ్జర్వ్ చేయం, అందుకని ఇట్ రీడ్స్ 0 అని కూడా చెప్పాను. అంటే 0 ఉంటుంది, బట్ కాన్సెప్ట్ ఏం చెప్తుంది అంటే ఎగ్జాక్ట్ 0 స్లైట్ గా ఆసిలేట్ అవుతుంది, బట్ ఆల్మోస్ట్ 0 అని చెప్తాం. అది పాయింట్.
అలాంటి ప్రాబ్లమ్స్ వచ్చినప్పుడు డైరెక్ట్ 4 amps అంటే కరెంట్ మనము I is equals to 4 amps అని కనెక్ట్ చేస్తే 4 amps దాకానే ఆగుతుంది కదా సార్.
అవును.
అట్లా డైరెక్ట్ ఆన్సర్ రాయొచ్చా సార్ 4 amps అని అట్లా క్వశ్చన్స్ వచ్చినప్పుడు?
యాక్చువల్గా ఓకే, గుడ్ క్వశ్చన్. యాక్చువల్లీ మీకు ఎగ్జామ్ లో అలా అడగరమ్మా. అంటే మీకు అర్థం అవడానికి ఒకవేళ 4 amps తీసుకుంటే ఇది ఎక్కడ ఆగాలి? 4 కి దగ్గరగా ఆగాలి. అయితే అది ఎలా ఆగుతుందని చెప్పడానికి ఏమని చెప్పాను? టీడీ ఇలా వస్తుంది, టీసీ ఇలా వస్తుంది, డాంపింగ్ టైక్ లో వస్తుందని చెప్పాను, అవునా? బట్ మన క్వశ్చన్ ఏమి ఇస్తారంటే ఇది అన్నోన్ కరెంట్, అది మనం మెజర్ చేయాలి. బట్ మీకు అర్థమవడానికి అంటే ఎక్స్ప్రెషన్ ఎప్పుడు కూడా ఏంటి, ఈ వాల్యూ తీసుకొని నేను ప్రూవ్ చేసి ఇది మెజర్ చేసామని ప్రూవ్ చేసిన కాన్సెప్ట్ క్లియర్ కదా, అందుకని ఇలా తీసుకున్నాం. బట్ జనరల్ ఏంటి, ఇది 4 చూపించింది అంటే అప్రాక్సిమేట్ గా గివెన్ వాల్యూ 4 అంటాం, లేదా 4 ప్లస్ ఆర్ మైనస్ ఎర్రర్ అంటాం, అది పాయింట్. బట్ ఎగ్జామ్ లో 4 ఇస్తే 4 అట్లా అడిగారు, 4 ఇస్తే 4 వస్తుంది ఎట్లాగో అది అడిగారు ఎగ్జామ్ లో. అంటే 4 మెజర్ చేస్తున్నాము అంటే ఏంటి, ఇక్కడ అన్నోన్ వాల్యూ ఏంటి అంటే 4 ప్లస్ ఆర్ మైనస్ సమ్ ఎర్రర్ తో చెప్తాం అనమాట. అది
ఓకే సార్. సార్
ఓకేనా?
టీసీ ఈజ్ ఈక్వల్స్ టు టీడీ అన్నప్పుడు అంటే డాంపింగ్ రేషియో లాగా ఇట్లా ఆగుతది టార్క్ అన్నట్టు చెప్తున్నారు కదా సార్. అయితే
ఏంటండి మళ్ళీ
టీసీ ఈజ్
చెప్పండి.
ఈక్వల్స్ టు టీడీ అనేది డాంపింగ్ టార్క్ ఇక్కడ ఆగుతుంది అని తెలియడానికి అట్లాగా ఈజ్ ఈక్వల్ టు అయినప్పుడే మనకి ఇట్లా ఆగుతది అన్నట్టు ఫోర్స్ అప్లై అవుతది అని చెప్పారు కదా సార్.
అవును, అవును.
ఒకవేళ గ్రేటర్ దెన్ ఆర్ ఈక్వల్ టు అయినప్పుడు?
అదే అమ్మా, ఎగ్జాక్ట్లీ ఈ కోడ్ అని రాసాను నేను. కాన్సెప్ట్ ఏం చెప్పాను, ఇలా ఆసిలేట్ అవుతుంది అంటే ఆ రెండు 100% ఈక్వల్ కాదు, కొంచెం డిఫరెన్స్ ఉంటుంది. పర్ఫెక్ట్ 100% అనుకోండి, పాయింట్ ఎటు కదలకూడదు. అందుకని టీసీటీడీ కొంచెం డిఫరెన్స్ ఉండి ఆసిలేషన్స్ అవుతా ఉంటాయి అన్నమాట. అది ఆ ఆసిలేషన్ అంటే ఎంత అంటే ఇది 10 న్యూటన్ మీటర్ అనుకోండి, ఇది 9.999 అట్లా ఉంటుంది. స్మాల్ డిఫరెన్స్ అంటే ఫ్రిక్షనల్ బేస్ డిఫరెన్స్ అన్నమాట. అప్పుడు ఏమవుతుంది, ఆ స్మాలెస్ట్ డిఫరెన్స్ ఆసిలేషన్ జరుగుతాయి. ఆసిలేషన్స్ ఆపడానికి డాంపింగ్ తీసుకుంటాం అంతే పాయింట్. అయితే అంతేగాని డాంపింగ్ కొరకు ఇది ఆగదండి. ఇది ఆగిన తర్వాత ఆసిలేషన్స్ వస్తాయి, అప్పుడు డాంపింగ్ టార్క్ వచ్చేసి ఆపేస్తుంది. అది పాయింట్.
ఓకే సార్. సార్ ప్రీవియస్ పీడిఎఫ్‌లో అక్యురసీ ఈజ్ ఈక్వల్స్ టు 98% అట్లా
యాహ్! యాహ్!
ఇచ్చారు కదా సార్. ఒకవేళ 0% ఉంటే అది 100% ఎర్రర్‌కి వస్తదా సార్?
డెఫినెట్‌గా. ఆబ్వియస్‌లీ. అది ఇంకా వర్స్ట్ సిస్టమ్ అన్నమాట. మోస్ట్ వర్స్ట్ సిస్టమ్ ఈస్ 0% యాక్యురసీ అంటే 100% ఎర్రర్ అన్నమాట. యెస్.
ఓకే సార్.
సింపుల్ 100 నుంచి తీసేయండి నంబర్ ఎప్పుడు కూడా.
ఓకే సార్. అంటే 100 అంటే పర్సెంటేజ్‌లో నుంచి అయితేనేమో డైరెక్ట్ వస్తది అంతేనా సార్?
అర్థం కాలే. మళ్ళీ చెప్పండమ్మా.
ఓకే సార్.
హలో!
సార్.
మళ్ళీ చెప్పండి.
అక్యురసీలో 98% అంటే 100
ఆ!
మైనస్
అవును.
తీసుకుంటాం సార్. ఒకవేళ
హ్మ్.
పర్సెంటేజ్ దాంట్లో ఇస్తేనేమో డైరెక్ట్ ఏస్తున్నాం గదా సార్.
ఆ! ఆ! కాదమ్మా.
అప్పుడు 0 అనేస్తామా అంటున్నాను సార్.
అలా కాదమ్మా. జాగ్రత్తగా చూడండి. 98% 98% మీకు 2 రకాలు చెప్పాను. ఒకటి మిస్ అవుతున్నారు. ప్లస్ ఆర్ మైనస్‌తో చెప్పాను. వితౌట్ ప్లస్ ఆర్ మైనస్ చెప్పాను. ప్లస్ ఆర్ మైనస్ కనుక నంబర్ ఉంటే ఎర్రర్ 98% అంటే ప్లస్ ఆర్ మైనస్‌తో ఎంతైతే నంబర్ ఉందో ఆ నంబర్ ఎర్రర్. ప్లస్ ఆర్ మైనస్ లేకుండా ఎంతైతే నంబర్ ఉందో అప్పుడు ఎర్రర్ ఎలా వస్తుంది అని చెప్పానంటే 100 లోంచి ఈ నంబర్ తీసేస్తే వచ్చేది ఎర్రర్. అది. ప్లస్ ఆర్ మైనస్ ఉందా లేదా అనే దాన్ని బట్టి ఎర్రర్ వస్తుంది. మీరు అడిగిన క్వెషన్ నాకేమర్థమైందంటే సార్ ఇప్పుడు యాక్యురసీ అనేది డైరెక్ట్ గా ఎర్రర్ ప్లస్ ఆర్ మైనస్ 0% ఇస్తే ఆటోమేటిక్ గా ఎర్రర్ ఎంత 100 మైనస్ 0 దేర్ఫోర్ హౌ మచ్ 100% ఎర్రర్. అది కదా నేను అడిగింది.
ఇదే సార్. మళ్ళీ ఒకవేళ ప్లస్ ఆర్ మైనస్‌లో ఇస్తే 0నే వస్తది కదా సార్ ఎర్రర్.
ప్లస్ ఆర్ మైనస్ 0 వస్తే 0 ఎర్రర్. అందుకే సింపుల్ లాజిక్ ఏంటంటే అమ్మా, ప్లస్ ఆర్ మైనస్ తో నంబర్ ఇస్తే అదే ఎర్రర్. ప్లస్ ఆర్ మైనస్ లేకుండా నంబర్ ఇస్తే 100 నుంచి తీసేస్తే వచ్చేది ఎర్రర్.
అంటే ఇప్పుడు ఈ కేసెస్‌లో ఏ కేస్‌లలో అట్లా అవుతది సార్ 0% ఎర్రర్ అన్నట్టు
అంటే
అట్లా?
అర్థం కాలేదు.
అంటే ఇప్పుడు అంటే ఎర్రర్ ఎక్కువ ఉంది అని అంటే అంటే ఎలా వస్తే అలా అవుతుందని?
లేదమ్మా. ఇప్పుడు వర్స్ట్ కేస్ వర్స్ట్ కన్‌స్ట్రక్షన్ అది ఆపరేట్ సరిగ్గా అవ్వట్లేదు. డ్యామేజ్ ఉంటే ఎర్రర్ చూపిస్తుంది కదా! ఎనీ వెల్ డిజైన్డ్ ఇన్‌స్ట్రుమెంట్ విల్ గివ్ లెస్ ఎర్రర్. మనం మ్యాథమెటికల్‌గా ఎక్కువ ఎర్రర్ తీసుకుంటాము. బట్ ప్రాక్టికల్‌గా అన్ని ఇప్పుడు మెషిన్ ఉంది, ట్రాన్స్‌ఫార్మర్ ఉంది. మనం ఏం చదువుతాము? ఎఫిషియన్సీ తక్కువ ఉంటే మనం వాడము అని చదువుతాం జనరల్‌గా. బట్ మ్యాథమెటిక్స్ తీసుకోండి ప్రాక్టికల్‌గా వచ్చేసరికి అన్ని 95% డిజైన్ చేస్తాము. ఒకవేళ ఏదో ప్రాబ్లమ్ వచ్చి, ఏదో డ్యామేజ్ వచ్చి అది 60% 40% చూపిస్తే అది మనం యూజ్ చేయము. అది మీనింగ్ అక్కడ అంతే. తప్పితే మనకి 98 ఎక్కడొస్తుందని అంటే మనకి ఎక్కడొస్తుంది అంటే అది పర్ఫెక్ట్‌గా ఉంటే లెస్ ఎర్రర్ వస్తుంది. ఒకవేళ డ్యామేజ్ అయ్యా, లేదా టెంపరేచర్ ప్రాబ్లమ్ వచ్చా, హీట్ వచ్చేసా ఏదైనా వస్తే ఎర్రర్స్ వచ్చేస్తాయి మనకి. అది పాయింట్. అదే ఎక్కడ వస్తుందంటే నార్మల్ ప్రాక్టికల్ కేసెస్ అంతే. ఓకే.
ఓకే సార్.
రైట్. So no, actually that student asked in Telugu, that's why I explained in Telugu. No problem, no problem. For other people, no need to worry. Hello?
Hello.
Yeah.
Good evening, sir.
Yeah, good evening.
Sir, na doubt వచ్చేసి as you said in PMMC, it will not measure AC element ni measure చేయదు అన్నారు కదా sir.
ఏసీలో మెజర్ చేయదు కాదు, ఏసీకి సూటబుల్ కాదు. PMMC is not suitable for AC, means not suitable for measurement of RMS. Now you can ask the question.
ఇందాక లాస్ట్ ప్రాబ్లం లో 8 అని మెజర్ చేసింది కదా సార్ అది.
అదే
అంటే మనకి 8 amps అని చూపిస్తుంది కదా సార్ అది.
8 amp చూపిస్తుంది, బట్ ఏ వాల్యూ అది? యావరేజ్ వాల్యూ, RMS వాల్యూనా?
యావరేజ్ వాల్యూ.
మనకు కావాల్సింది ఏంటి? ఏసీలో కావాల్సింది ఏంటమ్మా?
సో ఏసీ RMS వాల్యూస్
అంటే అదే అంట. స్టేట్మెంట్ మీనింగ్ ఏంటంటే నాట్ సూటబుల్ ఫర్ ఏసీ మీన్స్ ఇట్ విల్ నాట్ గివ్ RMS వాల్యూ, ఇట్ విల్ గివ్ సంథింగ్ ఎల్స్ విచ్ ఈస్ నాట్ రిలేటెడ్ టు ఏసీ, దట్ ఈస్ RMS.
సో ఇక్కడ ప్రాబ్లం లో 8 amps అనేది కరెక్ట్ వాల్యూ కాదు.
ప్రాబ్లం అది కాదమ్మా. చూడండి, I of t equal to 8 plus 6√2 sin 314t is there. What is this supply? Is it AC or DC supply? Combination. AC. AC means I want to get AC current. Means which current I have to get? You're missing small thing. Network theory అయిపోయిందమ్మా మీకు?
RMS వాల్యూ.
నెట్వర్క్ థియరీ అయిపోయిందా
సార్?
నెట్వర్క్ థియరీ అయిపోయిందమ్మా?
అయిపోయింది సార్.
అయిపోయిందా? ఇప్పుడు AC అనేది ఉంది.
అయిపోయింది సార్.
ఓకే. Which value we require? AC means RMS value. What is RMS value of this? 10 amperes. Are you getting 10 amperes with the PMMC? No. PMMC measures which value? Average value. That's why PMMC is, see, this value is correct for this question. But if you use the PMMC, what we have proved, if you use the PMMC, it will not give the RMS, it will give something else that is not the RMS. For that proof purpose, this question is being taken. But in that question, what is the PMMC reading means 8 is correct. But what is the 8? Average. But what is this supply? AC. AC means what we require? RMS. Means 10. Are we getting 10? No, that is the reason why PMMC is not suitable for AC. Adi point. Clear? Bhavani? Is it clear? I'm giving the permission, kindly accept it.
Hello, sir.
Yeah.
Sir.
Yeah.
Sir, I have a question regarding sensitivity.
Yeah, tell me.
Sir, sensitivity in general, what is sensitivity in one statement or two statements? Please tell, sir. Then I'll ask my question.
Yeah. If any device responds for as small as possible, then that instrument is having high sensitivity. That's what the point. Yeah.
Okay.
Tell me.
Okay, sir. Sir, here we are calculating sensitivity mathematically. So what I know is changes in, I studied this, sir. That's why I'm telling. Changes in output due to changes in input.
That's what.
According to this statement. So here theta is the output, I is the input, na sir. So changes in output means change in theta by theta. With respect to true value or preference value, something should be there, na sir.
No. That will be taken with respect to which one, etc. Here you are missing something. Not with respect to its own true value. Simply, here it is showing 3 degrees. When I give 1 ampere. If I change this to 1.01 ampere, how much value it will be showing? This change in current is giving the proper change in output or not. Suppose if it is giving 3 point something, okay, yes, for this small change also this instrument is operating properly, high sensitivity we can say. Suppose if it is showing still 3, what does it mean? It is not having high. That's not the point. But not with respect to its own value. That is with respect to the bridges, I'll tell you later. But it means, yeah.
Sir, I hope you know that sensitivity in control systems, right?
Yeah.
Yeah, I'm telling related to that only, sir.
See, yes.
Yeah, please relate it, sir.
Correct. See, sensitivity in my measurements, change in input to change in output only in the measurement.
Okay. For any type of question related to measurement, we
Different.
should use this one only.
Different. But
Okay.
but one
Yeah.
second, one second.
Sir. Yes, sir.
In few questions, if he is asking sensitivity in degrees only, he is asking, for example, what does it mean? What does it mean? Then sensitivity equal to delta theta, right? Suppose I'm changing resistance, for example, delta R by R, we have to take. Why? According to his,
yeah, please go on.
According to his question, we need to answer. If nothing is mentioned, no data, nothing is, find the sensitivity, means change in output by change in input only. But change the sensitivity in terms of so and so means, yes, according to that you need to answer. Suppose find only sensitivity he is asking, simply we need to take this one only.
Okay.
Right? But that depends on the content. That's what you see. Very good. Yes, sir. Control system, something is there. Yes, that's something else also. You're going to take in the bridges also. There, with respect to its original value, we need to take. Why? That depends on the corresponding context and all. But in our measuring instrument point of view, as of now, what is that? Change in input, how much you are giving? Change in output, how much you are getting? And I'm giving clearly, right? Degree
Yes.
by ampere. But in the bridges, I'll be taking this one. I'll explain elaborately.
Yeah, that would be helpful, sir. Sir,
Yeah,
one more.
definitely.
Yeah, one more, sir. Sir, you have given I current equal to 8 plus 6 root 2 question you have given.
Yeah.
Sir, if he asks RMS, this is correct, sir. I know this. But if he asks average, we should take average of DC is the 8 magnitude itself, but average of sine wave is Vm by pi or 2 Vm by.
Come on. No, you're missing something.
Yes,
very
I'm
good.
missing, sir. I know that. I will tell after that. You please correct. Okay, na, sir.
No, I understood your point.
Yeah,
I got.
please go on.
This is a general note for every student. Concentrate. One thing in the network theory, if I teach, I'll give this. Symmetrical wave is there.
Yes, we go for half wave only. That's what. Okay.
That's what. Symmetrical means we go for half wave. Unsymmetrical means full wave. What is this? Is it unsymmetrical or symmetrical?
Symmetrical.
Come on.
Both together is unsymmetrical, but only signs.
See, we should not. What is it? We should not make into parts. I of t is dash.
Okay.
I of t is dash.
Yes, I of t is both unsymmetrical.
Yeah. See, don't say both are single. Here, both and single is not there. Only single is there. I of t is there. I of t means unsymmetrical. Unsymmetrical means full cycle. That's why. See, I'll give the idea. 1 by 2 pi. 0 to 2 pi. 8 plus 6 root 2 sine 314t. This is the formula, right?
Yes, sir.
After that, what you do? 1 by 2 pi. Integral 0 to 2 pi 8 into d omega t. Do you take 1 by pi now?
No, sir. 1 by 2 pi only.
Yes. Therefore, full cycle, it will be 0.
Yes.
This is 0, this is 8.
And now it's looking very much clear. Okay.
Okay, thank you.
Okay. Thank you very much.
Right. And keep on selecting one by one. Kindly unmute from your side and you can talk to me. Those who raise the hand.
Good evening, sir.
Yeah.
Sir, you said gravity control is not operated in horizontal, no, sir?
Gravity control?
Is not operated in horizontal, you said, no, sir? One statement.
Yes.
Horizontal ఉన్నప్పుడు కంట్రోల్ వెయిట్ అనేది హారిజంటల్ ఉన్నప్పుడు వర్టికల్ గ్రావిటీ ఫోర్స్ యాక్ట్ అవుతుంది కదా సార్, అప్పుడు మనం యూజ్ చేయొచ్చు కదా సార్.
You're missing. This is the problem with three-dimensional picture. Kindly try to visualize. Here, I'm taking two of things here. Can look at. This is vertical mode. This white color pen is balance weight. Okay.
Okay.
This black one is control weight. Clear? Okay, right. Here like this. It's called as vertical. Kindly you don't switch on. Yeah, here. Like this. Horizontal means like this. Like this, it is rotating. This is horizontal. If anything is rotating horizontally, do we get gravity on that? Come on.
Down in vertically downwards we will get, no sir.
Can you a little bit louder?
అంటే డౌన్వర్డ్ లో గ్రావిటేషనల్ ఫోర్స్ వస్తుంది కదా సార్.
అదే అమ్మా, మీరు మిస్ అవుతున్న ఒక పాయింట్, బేసిక్ ఫిజిక్స్ పాయింట్ మిస్ అవుతున్నారు. గ్రావిటేషనల్ ఫోర్స్ ఆన్ ద బాడీ comes into picture when the body moving against to the gravity. Are you clear? If any body is rotating horizontally, will not be creating the force, because which type of gravity we require, right? The body has to move against the gravity, thereby that gravitational force should move the system back to the normal position. That is we require. But it is horizontal, no? Yeah, horizontal means it is rotating like this. Yes or no? It has to come back like this. Will it come back like this? No, that is why horizontally we cannot use.
Okay, sir, understand. Okay, sir.
Right. You can raise again, but you are not unmuting. Kindly unmute. Yeah.
Sir, page number 27, sir.
Actually, in between, struck actually some papers missed. 27, if this one?
No, sir, not sir. You explained the balance. This one only, sir. This one.
Which one?
This one only, sir.
What should I say?
Sir, you told that when the degrees is above 90 degrees, the controlling torque will be decreased, no, sir?
Yes.
So if you take above, can you please take these two weights above 90 degrees, sir?
Yeah. Right. Tell me.
Sir, in this both are in this control weights, control weight and balancer weight both are opposing the deflection torque, na, sir?
Can you tell me?
In this figure above 90 degrees, the control weight and balancer weight both are opposing the deflection torque, na, sir? So the controlling torque should be increased, na, sir? How it is decreased?
See, with respect to TD, you have to speak. With respect to TD, you have to speak. Controlling torque should be produced by only this. Only this. Yes or no? What you are missing here is gravitational force acting on these two. Okay, gravitational force acting on these two. Here, whatever the gravity is there, that is divided into these two cases. I mean, here something, here something. What is this? Is getting reduced or not? Earlier, only control weight alone used to oppose. But now, both are using opposing means. This related only, this we have to know, we should not take it. It is only for balancing purposes. Now, the controlling torque is divided into two parts. Automatically, this will be reduced than the normal. You should not addition here. You should not take the addition. TC is based on the TD. But in this, what is it? This TC is getting divided into X and Y both. Means this is not equal. Only this one. So automatically it is getting decreased, not increased.
Yeah, sir, I understood. But in the degrees below 90 degrees, the balancer weight is experiencing the gravitational force, na, sir?
Balance weight is?
Balance weight is experiencing the gravitational force.
No.
Gravitational pull.
No.
in previous case, sir, original
Yeah,
case.
that's see, I'm coming. See, this is not coming down as it is experiencing the gravity. No, this is coming down as it is going up. Lot of difference is there.
Yes, sir. Yes, sir. This
That's
one
what
only
it
my
is.
doubt, sir. Yes,
Yeah,
sir.
now it is clear, right? Very good.
Yes, sir. Clear, sir.
Right, almost everyone over, right? Tomorrow by same time, 6 o'clock.
Hello, sir.
Yeah.
Sir, you said that dead time or dead zone is a static static measurement, no, sir. Static error.
Yeah.
Related. Sir, dead time is due to pointers movement, no, sir.
Dead time is due to pointer weight and pointer inertia.
Yes, sir. That inertia due to pointer inertia, some time lag will be there. That is not dead time, no, sir.
Yeah.
Sir, but the pointer movement is depend upon deflecting force, no, sir. Deflecting torque.
How? I'm
Sir,
not talking about after the dead time and dead zone. I'm talking about at zero time. At zero time, it's inertia only. Definitely, it will be having some inertia.
ఎస్ సార్. అంటే నేనేమన్నానంటే ఆ ఫోర్స్ అనేది ఒక్కొక్క అంటే 2 ఆంపియర్స్ ఇస్తే ఒకలా ఫోర్స్ ఉంటది, 4 ఆంపియర్స్ ఇస్తే ఫోర్స్ ఒకలా ఉంటది కదా సార్. సార్ అంటే ఎక్కువ ఫోర్స్ ఇచ్చినప్పుడు మనకు పాయింటర్ మూవ్మెంట్ అనేది కొంచెం ఫాస్ట్ గా ఉంటది కదా సార్. అంటే కొంచెం
వెరీ గుడ్. ఎస్, ఓకే, మీరు అలా అడుగుతున్నారా అంటే నేను ఏమంటున్నానంటే డెడ్ టైమ్ అండ్ డెడ్ జోన్ కాన్స్టెంట్ ఎందుకు అంటున్నానంటే డెడ్ టైమ్ అండ్ డెడ్ జోన్ ఫర్ ఎ గివెన్ డివైస్ ఫర్ ఎ గివెన్ కండిషన్ ఇట్ ఈస్ నాట్ వేరియబుల్. అది పాయింట్ అక్కడ. ఓకే, గుడ్ క్వశ్చన్. మీరు అనేది ఏంటి, ఎక్కువ ఫోర్స్ ఇస్తే ఎక్కువ కరెంట్ ఇస్తే ఎక్కువ ఫోర్స్ కాబట్టి ఫాస్ట్ వెళ్ళిపోతుంది. అందుకే డెడ్ టైం తగ్గింది కదా, అదే మీ. బట్ నేను ఇచ్చిన పాయింట్ ఏంటి, ఫర్ ఎ గివెన్ ఇన్పుట్ వాల్యూ ఇట్ విల్ నాట్ బి వేరీడ్. స్టాటిక్ మీన్స్ వాట్, ఫర్ ఎ గివెన్ ఇన్పుట్ వాల్యూ ఇట్ షుడ్ నాట్ బి వేరీడ్. యాక్యురసీ తీసుకుంటే ఎట్లా అంటే మరి ఒకసారి 1.9 చూపిస్తుంది, ఒకసారి 1.95 చూపిస్తుంది. అది ఎట్లా మరి కాన్స్టెంట్?
ఓకే సార్, ఫర్ ఎ గివెన్ కండిషన్
అది ఫర్ ఎ గివెన్. మళ్ళీ ఇంకోటి మీరు చెప్పిన ఆన్సర్ లో ఇంకొక పాయింట్ కూడా ఉంది. ఎక్కువ కరెంట్ ఇస్తే ఎక్కువ ఫాస్ట్ వెళ్తుంది కాబట్టి డెడ్ టైం తగ్గిపోతుంది కాబట్టి ఎర్రర్ తగ్గిపోతుంది. అందుకే ఏమన్నా నేను ఎప్పుడు కూడా టువర్డ్స్ ఫుల్ స్కేల్ వాల్యూనే ఆపరేట్ చేస్తే బెటర్ రిజల్ట్స్ వస్తాయని.
సార్ సార్ ఇంకో డౌట్ సార్. సార్ ఇప్పుడు అంటే అది మెటీరియల్ చేస్తున్నప్పుడు అందులో ఒక ప్రాబ్లం ఉంది సార్. అది ఒక 2 వాల్యూస్ ఇచ్చి రెడ్యూస్ ద సిగ్నిఫికెంట్ ఫిగర్స్ టు ద అప్ టు రౌండ్ అప్ టు 2 ఫిగర్స్ అన్నాడు సార్. సార్ అక్కడ అంటే సిగ్నిఫికెంట్ డిజిట్ లో సెకండ్ డిజిట్ అనేది 5 ఉంది సార్. మామూలుగా మనం 5 కంటే ఎక్కువ ఉంటే కదా సార్ నెక్స్ట్ వాల్యూ తీసుకుంటాం.
వాయిస్ నవ్వట్లేదు
సార్. అంటే 5 కన్నా ఎక్కువ వాల్యూ ఉన్నప్పుడు కదా సార్ దాన్ని నెక్స్ట్ వాల్యూ తీసుకుంటాం సిగ్నిఫికెంట్ ఫిగర్ కన్సిడర్ చేసుకుంటే.
అక్కడ ఏమన్నారు, రౌండెడ్ ఆఫ్ కూడా అన్నారు. అది 2 3 4 5 అదే కదా క్వశ్చన్.
ఎస్ సార్.
2 3 5 4 ని మీరు ఎర్రర్ ని రౌండ్ ఫిగర్ చేస్తే ఎర్రర్ లో రెండే సిగ్నిఫికెంట్ ఉండాలి. మీరు ఏం చేయాలి ఇక్కడ, మన మెజర్మెంట్ సిగ్నిఫికెంట్ తీసుకోవాలి, మీ మ్యాథమెటిక్స్ రౌండ్ ఫిగర్ తీసుకోవాలి. ఓకే, 2 3 5 4 ఉందండి.
ఎస్ సార్.
1 సెకండ్, సింపుల్. హియర్ 2 3 5 4 ఉంది. నేను దీన్ని 2 3 5 0 లాగా రౌండ్ అప్ చేస్తున్నాను, లేదా 2 3 6 లాగా రౌండ్ అప్ చేస్తున్నాను. సపోజ్ ఈ రౌండ్ అప్ చేసే దాంట్లో ఎన్ని సిగ్నిఫికెంట్ ఫిగర్స్ ఉన్నాయి
సార్? పైన దాంట్లో 3 ఉన్నాయి సార్.
కింద దాంట్లో
2350 కి 3 ఉన్నాయి, 2354 కి 4 ఉన్నాయి, 2360 కి 3 ఉన్నాయి సార్.
3 ఉన్నాయి. ఇది క్వశ్చన్ అండి, ఇది వదిలేయండి, ఇది క్వశ్చన్ వదిలేయండి. దీంట్లో 3 ఉన్నాయి. బట్ క్వశ్చన్ ఏం అడిగాడు, ఓన్లీ 2 సిగ్నిఫికెంట్ అడిగాడు.
ఎస్ సార్.
అవునా? అయితే దీన్ని ఎలా రాసుకోవచ్చు మనము, 2354 ని 2300 రాయాలి, 2400 రాస్తాం. ఇప్పుడు చూడండి, ఎందుకంటే రెండు పోయినాయి, రెండు ఉన్నాయి. ఈ రెండిట్లలో ఏది రౌండెడ్ ఫిగర్ చేయొచ్చు మనం?
అవును,
ఏది
సార్? అంటే మామూలుగా అంటే నాకు తెలిసినంత వరకు 5 ఉంది కాబట్టి 2300 రాయొచ్చు అని నా డౌట్ సార్.
అర్థం కాలేదు
సార్. అంటే 5 ఉన్నది కదా సార్ అక్కడ డిజిట్ అనేది. సో 23 దాని నెక్స్ట్ దానికి వెళ్ళకుండా 2300 రాయొచ్చు అని.
మీరు మళ్ళీ మిస్ అవుతున్నారు. మీకు ఏం కావాలి, 2 సిగ్నిఫికెంట్ ఫిగర్స్ కావాలా కావద్దా?
కావాలి సార్.
2 సిగ్నిఫికెంట్ ఫిగర్ తో పాటు ఏం చేయాలి, రౌండ్ ఫిగర్ చేయాలి. అందుకే చెప్పాను, ఒక డిజిట్ తీసేసాను. రౌండ్ ఫిగర్ అంటే
అవును
ఒక్కొక్క
సార్.
డిజిట్ తీసుకుంటే కదా, ఇది కాదు
అవును
ఇది కాదు.
అవును సార్.
ఇప్పుడు ఏం చేయాలి,
అంటే అర్థమైంది సార్. అంటే 2300 చేయకూడదా అన్న డౌట్ సార్.
అది దానికి వస్తున్నాను. ఓహో, ఈ 2 3 చేయకూడదు అంటున్నారా? ఓకే ఓకే, రెండు కరెక్టే, అదే అంటున్నాను. ఈ రెండిట్లలో ఏది రౌండ్ ఫిగర్ చేయొచ్చు అంటే చూడండి, 354 నుండి 400 చేస్తే 46 నెగ్లెక్ట్ చేశారు మీరు.
ఎస్ సార్.
54 నుండి 300 చేస్తే 54 నెగ్లెక్ట్ చేశారు. ఏది ఎక్కువ ఏది నెగ్లెక్ట్ చేయొచ్చు ప్రాక్టికల్ గా, మ్యాథమెటికల్ గా?
ఓకే, అంటే 46 ని మనం నెగ్లెక్ట్
అంతే
చేయొచ్చు.
కదా, అది పాయింట్.
ఓకే సార్, అంటే నెగ్లెక్ట్ ఏది తక్కువ చేయాలి అలా చూడాలి సార్.
అంతే కదా. ఇప్పుడు నేను 1.6 ని 1 సెకండ్ ఇప్పుడు నేను 1.6 ని 1 చేస్తానా 2 చేస్తానా అంటే ఏది యాక్సెప్ట్ చేస్తాం మనం మ్యాథమెటికల్ గా?
2 చేస్తాం సార్.
ఆబ్వియస్లీ, ఎందుకంటే ఇక్కడ 0.4 ఇక్కడ 0.6 అట్లా.
ఓకే సార్. అంటే ఎప్పుడు డెసిమల్స్ లోనే చూసాను సార్. అంటే డెసిమల్స్ లో ఉన్నప్పుడు మామూలుగా 5 అన్న 1.5 ఉంటే అది దాన్ని 2 కింద రాయకూడదు అలా చూసి.
ఓకే, కానీ దీంట్లో ఏమి ఇచ్చారు, సిగ్నిఫికెంట్ ఫిగర్ ఇచ్చారు, కన్ఫ్యూజ్ అయిపోతున్నా, అది పాయింట్ అక్కడ. రైట్.
ఓకే సార్, థ్యాంక్ యూ సార్, థ్యాంక్ యూ వెరీ మచ్.
Okay, then tomorrow we'll discuss almost all over. Right. Tomorrow same time 5 to 9. Same time 5 to 9.